very easily.
Zoom, I think they have upgraded. There is one more upgradation has happened. Is it not taking up now?
Like some of them are saying that YouTube is very, very easy.
Okay.
And just one link, click, and it's there.
Yeah.
And anyway, the questions you can put in chat box from YouTube also.
Okay.
Yeah.
I have not done that. Only
Yeah.
Zoom and WebEx and this Meet, MS Meet. All those things I have used.
So there were 27 speakers yesterday. It was like pretty intense, and especially the students.
Correct.
They were really. Ma'am has noted down all those points.
Lot of appeal to the government. Very nice. See, the new gen graduate students are really more focused.
Very good.
Very good.
No, they
They have the clarity of their thinking.
very.
Focusing what they have to do in future. All this very rare. That career road is they have already made.
No, they have to.
Yes.
Competitive.
Yes.
Should start.
Yeah,
It is
Yeah, it's
actually.
nice.
Wait, I think
Two more minutes.
Mukesh will introduce
Yes.
the chair. Right
Because we should start on time.
Yeah.
He's waiting.
I think this time is
2 more minutes.
2 more minutes. Yeah.
20 minutes.
That shows more. I'm looking at that.
Oh.
That one. I just went and met director.
Oh.
How is it?
I just met him that I'm not doing. Oh. They're not coming.
No, I'm coming, but we're always busy.
That's why I made it a point that I'll rush there, stay hour. Now it's cafe, coffee. How did it go yesterday?
Yesterday went on very good. Good response. They registered online around 7, and then we kept our lecture all open, sir, so that
So it is related to that.
Yeah.
And then the people can say,
Yeah.
that's a good idea. Good idea.
we didn't give link to everyone. Only IN members we gave a link. Rest one can come
Good.
here. And of course, now finally we will share the YouTube links.
You're getting any funding for this?
No, sir. This is from chapter Little Money is there, sir. Whatever.
There is a new link.
Could have applied for some of these agencies.
Yes.
These are very important.
Yeah.
I'm sure I see more companies that have.
Yeah, we didn't try much because the expenses are as of now not major one.
Unless you are bringing out something.
Yeah, yeah.
If you are planning to bring out something, I think SA not should. help.
Yeah.
We have to recommend the government through IAN some of these,
All the more, that's why if you have taken even 10,000 rupees, that is just for the sake of it.
Yeah.
What happens is this becomes easy. When
Okay.
recommendation goes, it becomes easier.
Okay. Yeah,
That is the idea.
got that.
Idea behind it is that you send a report, you send a recommendation. That helps a lot. If you are already linked up with ICMR or something. That means it is sponsored by ICMR. Like
But the thing is, sir, this is a Bangalore chapter. So we have to connect it to our headquarters. And they have to do it.
could be done.
So they are also attending.
Yeah.
Good morning to all the participants to the second day of the symposium, Sketch and Etch Creative Ideas in Neuroscience. On the first day of the symposium, we heard 27 scientists telling their stories and research activities. Today in the third session, we have some big stalwarts talking of options to advance career after PhD. The session will be chaired by two NIMHANS greats, Dr. T. Raju and Dr. P. Satish Chandra. Dr. Raju is currently an A.S. Pinter Distinguished Scientist Chair of ICMR at NIMHANS, Bangalore. His affiliation with NIMHANS goes back to us having him as the former Dean and Senior Professor of the Department of Neurophysiology. On behalf of all the committee members, I would like to welcome you to chair the session, sir.
Thank you.
Our second chairperson, Dr. P. Satish Chandra, is currently a senior consultant in neurology and advisor at the Apollo Hospital, Bangalore. He also holds the position of Honorable Professor at the University of Liverpool, UK. We had the honor of having him here in NIMHANS as a former professor of neurology and as former director and vice chancellor of the institute. His efforts in administration brought NIMHANS to the limelight, and during his tenure as director, NIMHANS got recognized as institute of national importance. I welcome you, sir, to chair the session and take this symposium forward.
Okay. Good morning to all. First of all, let me thank the organizers for giving me an opportunity to chair this session, along with my great friend, Dr. Professor Satish Chandra, outstanding neurologist in anybody's language. I'm very much impressed by the overall program put together by Dr. Lakshmi and the team. It starts with creativity. Creativity is extremely important for generating new, bright, novel ideas. Then you translate these ideas into successful PhD programs. After PhD, then what? And this workshop is addressing that, especially this session. And I am deeply honored to introduce our speaker, Shri Chris Gopalakrishnan. We always know him as Chris. Chris has been the MD, CEO, Vice Chairman, and co-founder of Infosys, which is truly a jewel in the crown of Indian industries. He is recognized as a global business and technology thought leader. He was voted the top CEO, and he was the president of India's Confederation of Indian Industry, CII, for 2013 to 14, and served as co-chair of the World Economic Forum in Davos in January 2014. In 2001, he got Padma Bhushan, the country's third highest honor. Chris is also the chairman of Axelar Ventures, an accelerator that helps startups during the early stage of their business journey. Chris invests in promoting research on brain sciences, aging-related disorders. Chris really made a history. He donated 220 crores to start the Center for Brain Research at the Indian Institute of Science. I must say, he opened up his heart for research. And 220 crores, which maybe is equal to 300 million. In anybody's language, again, it's a huge sum because he trusts science. Thank you so much for trusting science. And we are really proud to have you, and we are looking forward to your talk, Chris.
Thank you very much, Dr. Raju and Dr. Satish Chandra and Lakshmi for inviting me to this very important session. I'm going to share my screen because I have a presentation which I would like to. I hope you can all see my slide now.
Yes, sir.
Yes, yes.
Thank you. So, I think it's a very, very interesting and important topic, very relevant. And I want to share my perspectives, my thoughts. It's important from the research scientist perspective, looking at a career in research. It's important when we look at economic development of our country, creating new enterprises, creating startups. It's important from India's perspective, the country's perspective. And this is what I want to share in my presentation to you today. Now, let me start by sharing with you a quote from a very young person. And You probably would have actually seen this. Gitanjali Rao, age 15, was recognized as the first kid of the year by Time magazine. First kid of the year. And she was recognized for her interest in research, science, etc. And she says, in our minds, superheroes can jump tall buildings, have technological gadgets and superpowers. But what do they have in common? The ability to save lives. And the magical thing is that they show up exactly at the right time to save a life. How are living, breathing scientists different from the superheroes in comics? No matter where they are, scientists come with solutions to help people. I love science and I want to be a scientist superhero solving real world problems and saving lives. Very, very aptly put. And especially, during this challenging period of COVID. And I want to actually compliment the work done by our scientists during the COVID-19 crisis. We in India were not manufacturing any personal protection equipment, ventilators were imported, but in a very, very short period of time, working together with scientists in industry, scientists in academic institutions, government, all working together, we have actually now, a capacity to manufacture all these things, capacity to manufacture test kits, and we are starting to export actually. And this reinforced the confidence in our scientific capabilities, appreciation for science and scientists. And I also see that fast-track approvals are possible. But why do we need a crisis for fast-track approvals and things like that? Why can't we actually work together if there is something that is beneficial to bring that to market as quickly as possible? We also have seen that this is a decentralized model, and that's the model I believe will work very well going forward in the future. So, my compliments, my salute to all the scientists, and that's how I want to start. And when you are thinking about a career in science, as Gitanjali said rightly, society must consider you as a superhero, and you are actually training to become a superhero because you can save the world. Now I want to actually share something that our Union Minister for Science and Technology, Sri Harshvardhan, gave as a reply in Lok Sabha. This is about the LIGO project, actually. He says, I won't read everything. He says 37 authors from 9 Indian institutions in the scientific article presented the world with the first discovery of gravitational waves published by Physical Review Letters, etc. And these scientists are from across many institutions, Chennai Mathematical Institute, TFR Bengaluru, Indian Institute of Science, Education and Research, Kolkata, Thiruvananthapuram, IIT Gandhinagar, Institute of Plasma Research. This program is a program that was running for 30 years. 2,000 scientists from across the world participated, multi-billion-dollar budget. What Einstein postulated 100 years back, it took 100 years for it to be proved experimentally because the technology, the engineering that is required, the science that is required, the computing resources that was required. In fact, many of the contributions from our Indian scientists were actually to create and run these computational models actually came from India. This is an amazing discovery, and certain people said that this is probably one of the biggest science discoveries at that point of time, a couple of years back, actually. And again, India has contributed. This is again why I'm very confident of the capabilities of our Indian scientists, and I want to reinforce that. The importance of science, actually, again, right? We are faced with this virus, but look at this. Never in the history of the world we have come out with a vaccine for a virus at such a short notice, got all the relevant trials done, got relevant approvals done, and we are starting to vaccinate people. And look at the breadth of science here, actually. You have the messenger RNA vaccine, where you are in the lab creating a snippet of that virus and injecting that back into the body, where it creates the signature of the virus and helps the body develop the immune therapy, immune capabilities, actually. Then you have weakened version of the actual virus. You have the inactivated version of the actual virus, which is what Bharat Biotech has developed in India, which is the traditional way of looking at it. And then different other technologies also. Multiple, 9, 10 different vaccines in such a short period. Amazing global collaboration, and at the speed at which it has been all developed. But the most important point I want to bring here is that, if you look at some of these vaccines, they are very expensive. They are not suited to Indian conditions. We don't have the logistics capabilities to store and transport these vaccines at -100°F. And this is again why we must do research in India. See, when the developed world does research, they come up with solutions which are to be used in the top 10% of the world. When India participates and does research, we think about the 90% of the world. So if the majority, 90% of the world must benefit from the research, India must step forward and do research, participate in research. And this is why I believe research in India is important to the world. We bring very different perspectives. We bring the challenges and the problems that represent 90% of the world, as I said. And if, especially for example, in healthcare, this is a neuroscience platform, right? When we talk about that, we need solutions where Indian data, Indian subjects, trials in India are all represented. And when we represent 20% of the world's population, if we don't participate in that research, then clearly we are not sure whether that solution is going to work in India or not. And this is the reason why Professor Raju talked about my investment in promoting the Center for Brain Research, Brain Sciences, aging-related neurological disorders, disorders like Alzheimer's, Parkinson's, dementia. I strongly feel that, of course, these are unsolved problems, and if we don't participate in that research, yes, we may find a solution, but that solution may not work in India. That solution may not be affordable to Indians. And if we participate in this, we will bring different perspectives. If you look at the population in India, it's very unique, actually. The genetic dispositions, the cultural nuances. We have people who are literate, illiterate, people who are vegetarians, non-vegetarians, people who are poor, people who are rich, people who have sedentary lifestyles. We have incidence of diabetes, high blood pressure, etc., widely in India. So all these perspectives need to be brought in and our use of spices, right? Does it have some impact on either the incidence? So, is the incidence lower in India or is the incidence higher in India? All these data points must actually be part of the research and part of the solution. And I talked about cost, definitely because we are a lower cost economy and the people are as good as anybody anywhere in the world actually. But since we are a lower cost economy, the research in India is cheaper. I strongly, when I meet people around the world, when I meet foundations in the world, I tell them that $5 you spend in US, if you spend $1 in India, we will produce the same results. So, our output is 5 times more for the same dollar you spend. And that's why I believe they must, if they spend $5, spend $1 in India. You will actually get double the output. Of course, more people working on the problem solves the problem faster. We have capacity, we have capability, we have smart people, and we have more of those smart people because we are a large country, 1.3 billion people. So we have more smart people in India. Of course, we need to scale up investments in technology and the scientific infrastructure. And this is a joint effort. It's just not about government, private sector also, and I'll come back to this further down. See, future is not a linear extrapolation of the past, and this COVID situation has clearly demonstrated that future is not a linear extrapolation. We will see disruptive technologies changing the future, crisis accelerating the change. Adoption of digital, for example, technologies has been accelerated in the last 5 months, 6 months. What would have taken 5 years happened in 5 months because of the crisis, actually. It is also deeply influenced by scientists, engineers, entrepreneurs, and leaders. Because, the scientists, the engineers create new products, entrepreneurs and leaders bring those products to market, to society. And this is how change happens. How did the mobile phone come about, actually? It came about because of research efforts in the labs, etc. Finally, those research efforts translated into a first version of the mobile phone way back in the late 80s, 90s, etc. And today, that has empowered every single citizen in the world. And the technologies that are used in the mobile phone came out of some research work done in some lab somewhere in the world. And see how it has transformed society, see how it has empowered the individual. And if today, in spite of being at home, etc., we are able to connect, communicate, do business, work, it's all because of mobile technology, the digital technology, the communication technology, all came out of labs somewhere. And we are always looking for a faster, better, cheaper way to do things using better tools, technologies, and business models, actually. And that's the way future is created. What gives me the confidence? I'm a child of the digital computer revolution, the third industrial revolution. Introduction of personal computers allowed business process to be automated using computers and software. Again, the same principle that I talked about in research. We use the same principle to use the lower cost economy in India to develop software cheaper for the world. And that's the business model that created today a successful IT services industry in India. It's $190 billion. It employs 4 million people. It has created a first world industry, a world-class industry in India. So much so, today this has become the de facto model for delivery of work, remote work. If you're working from home, working remotely, that's what Indian IT services companies pioneered, right? So, this has become the de facto standard even during the COVID crisis of how work is done. And that's what Indian IT services companies pioneered and created a huge business out of India. This is why it gives me confidence that we can again do research in India. So as I said, this is $190 billion business. Now look at the the technology industry itself, it's $5 trillion direct revenue for this industry. Actually, it has some of the largest companies by market cap in the world. All this has happened in the last 50 years. Imagine that. In my lifetime, I have seen the growth of this industry to become a $5 trillion industry. And digital computer was introduced in 1945. 1945. So 75 years, we have seen a $5 trillion industry being created. That's the power of research. That's the power of innovation. That's the power of entrepreneurship and things like that. And it impacts every industry today. All our life is impacted because of this. Now we have a lot more that we need to look at, actually. The more you know you don't know. You know, this is from Aristotle, long back. So, you know, that is why, again, I'm fascinated by research. You know, if you have a mindset, you know, a curious mindset, there's so many things that, you know, we still do not know. And this is another reason why, you know, I'm fascinated by brain. And I'm, you know, talking about this, the unknowns in neuroscience, I just, you know, picked up 3-4 things here, but if you go into internet, there's so much actually interesting thing about neuroscience that's yet unknown. You know, even in the 21st century, in 2020, there are still things that we do not know. You know, and of course, you are all experts, so I don't need to tell you this actually. You know, how plastic is a mature brain. You know, we know that it changes every second. As you hear me speaking, your brain is actually changing. You know, new connections are being made and things like that. But you know, can we leverage this better? Can we understand, you know, the workings of the brain better? You know, we always, you know, the whole digital computer industry is created by us thinking about how the brain works. The brain is the model or the inspiration that created the digital computer industry. But we still don't understand the brain, actually. You know, I always joke that, you know, the two people who are considered the fathers of the digital computer industry is George Boole, who created Boolean algebra, and von Neumann, who came up with this concept of, you know, different, you know, the stored program concept, where a program is stored along with data in the memory of the computer, but it's in different location. And they thought that the brain is a logical device. Boolean algebra is how, you know, the computations happen in brain. And there are different parts of the brain where data is stored and programs are stored, etc. You know that these are all wrong things. But that wrong models, you know, mistakes created this $5 trillion industry. And look at the, you know, the impact even of things that were wrong, but created a huge industry. And this is how, when we want to actually copy nature, you know, human history is all about us trying to understand nature. And we copy nature. You know, we look at birds and say, why can't humans fly? So we created the aeroplanes and things like that. But when we copied, we quickly learned that flapping the wings won't work. You know, it's a lot more mechanically difficult to create the lift and the flight that's required using flapping wings. The engineering is too complex, actually. But if we create fixed wings, if we put a propeller or a jet engine, we can actually fly, right? We created mechanical tools. We created digital tools that allow us to fly. Now, when we look at nature and wonder about nature, and we want to replicate nature, we actually do. We humans do that, and we do that amazingly better, but probably not with the most efficient use of resources. And that's why, you know, we have air pollution and things like that. But we do copy nature, and you know, human history is about copying nature, wondering about nature, and trying to figure out how we can replicate this and do it better. You know, there are questions about why evolution indeed created brain, right? How did suddenly the brain become an organ? How is the brain evolve and how is it evolving today? Because if I don't now remember telephone numbers, etc. If I don't have mobile phone, I'm actually useless person actually, right? But is it changing your brain? How is it impacting your brain? So many questions are there, and that's the wonder of research, etc. Now the tools that we use are also changing actually, and more powerful tools are being used. The digital computer, introduced in 1945, has completely transformed research actually, and a lot of the computations that we do, research is not possible. But the paradigm that the digital computer gave us was that we need to know the problem, understand the problem, we need to write an algorithm, we need to program it, and feed it into the computer, and the computer religiously executes that program. And that's the model of computing that we have till now. But first we need to know how to solve the problem. Now in AI and ML, the paradigm is completely different. We don't need to know how to solve the problem. We train the computer to solve the problem. So we actually give labeled data, we give actually results that we want, and train the computer to find an algorithm to solve the problem. The solution actually is created by the computer. You leverage the power of the computer to find the algorithm. So face recognition, for example, you feed a lot of pictures and say, okay, this is a human face, right? And this is a face of a cat, this is a face of a dog. And then the computer learns with enough data points, tagged, labeled data points, how to now figure out how to do this actually. And later on, we show a picture, the computer will tell you, yes, it's a human face, it's a cat's face, it's a dog's face, etc. Pattern recognition, etc. So suddenly, you have a new tool with you. Now you can solve new class of problems with this actually. Pattern recognition, medical diagnostics, natural language processing, speech recognition, real-time translation, surveillance, all kinds of new problems can be solved, and it's called the intelligence revolution. With new tools, suddenly you realize that you have new capabilities actually. I won't go into this slide, but I strongly believe that we will be able to replicate artificial general intelligence in the future sooner than later. It will not be again an exact replica of the brain. It will be probably some set of capabilities that machines develop, which combined together can become as intelligent as humans. But look at this, using the AI and machine learning program. This is DeepMind from a company that Google owns. We have figured out how at least 2 of the proteins fold. Now, why is protein folding very important? And again, I know you are more knowledgeable about this than I am, but from my limited understanding of protein folding, because this is a challenge from basic DNA code. You create these proteins, but if you are able to understand what proteins are created and how to create a particular protein, actually you can engineer life. And to some extent, the messenger RNA vaccine is just that actually, but it was very simple. But how do you do complex proteins and things like that? This will completely transform drug discovery. This will completely transform how you combat diseases. You can actually re-engineer your immune system to combat cancer and things like that, right? And this is what is amazing about research, and this is what we can do with research, etc. And I strongly again reiterate that we can do this in India. You can see that the experimental results and the computational predictions are almost 90+% accurate. That means we are starting to now predict protein folding in the lab. This was a problem that was unsolved for 50 years actually. This is like the LIGO thing, right? Einstein predicted the theory about gravitation 100 years back, and it took 100 years to prove that. We knew about protein folding, the structure of DNA, etc., but it took us 50 years to figure this out. More technologies are emerging, and again, I won't have time to go into these details because I want to get into a little bit about career in research. The important point here is new tools are coming, and you will be able to solve more problems, and this will transform every single industry. So the research that you do has a direct impact on every industry. Every industry will change in the next 30 years. Driverless cars, new financial instruments, transactions, etc. We all consume content on our personal devices today, right? You're probably watching, some of you at least are watching this on your video, on a mobile phone and things like that. Everything is changing. Healthcare is going to be completely transformed with robotic surgery, personalized medicine, telemedicine, right? The whole area of how consultations happen today. Genomics, again, will transform, and I gave you a glimpse of that actually, how healthcare will be, healthcare industry will evolve in the future. When I look at research itself, it is the engine for innovation. Everything that you see around you, everything that you see around you is because of some curious person somewhere thinking about that, investigating that further, creating a prototype, then thinking about commercialization, bringing it out to market, etc. And Indian research, is also very innovative, and we sometimes, of course, find solutions for unique problems in India. The robots that clean sewers and perform assessment of underwater structures. These are all, things that Indian scientists, Indian labs created, nanoparticle-based drinking water purifiers. So it is possible to do world-class research and research that helps society in India. I have looked at research only for the last 6 years, and I'm convinced that world-class research can be done in India. Another reason for this confidence is if you look at multinational corporations, their second largest or the third largest laboratory, R&D laboratory, is actually in India. Many of them here in Bangalore. You just look at Google, you look at Microsoft, you look at Intel, you look at Texas Instruments, every one of them. We can actually, Intel has this advertisement which says Intel Inside, right? We can clearly say India Inside, because everything that you use today, the mobile phones or anything that you use today, has some part of it, especially if it has software developed in India. So we can actually claim India Inside on everything that we use. Design, the R&D that is done, etc. Very big research projects are coming to India. We are setting up, the LIGO project, the Neutrino project, and I want in healthcare also some of the largest projects to be in India, and that's one of the reasons again for setting up the Center for Brain Research at Indian Institute of Science. Indian research is getting more global, more multidisciplinary, and more fun. And we are now fine-tuning the research to entrepreneurship, the lab to market, that value chain also. Private sector must increase its participation, and I completely believe in this, and that's the reason why I'm walking the talk. I said if I'm going to ask my colleagues in the industry to do something, I must do it first, and that's why I'm supporting research. I believe that there is a role for business and industry. Typically, they support applied research, which is research that can come to market within the next 5 years. And beyond that, it's philanthropy or government, which primarily supports. Today, research in India is supported primarily by government. So we need to actually increase the investment from industry by 15 times. Today, the estimate is that investment in research is about 0.1% from industry. It has to go to 1.5%. Government will go from 0.6% to 1.5%. That's about 2.5 times. So 2.5 times increase from government, and government is doing that. I am part of many of these initiatives, and I see that government is actually increasing its spending on research. And I will talk about, some of these very quickly actually, and these are models that I've studied in the last few years actually. Now, how can we change the way research is done in India? And this is not everybody changing. It's about some changes that we need to make. I think when we set ambitious mission mode programs, I'm very confident that we can achieve those results. And next slide, I will have ISRO as an example actually. See, most of the research today is that a professor with a couple of PhD students with a budget of 10 lakhs, 15 lakhs, looking at a problem. So what happens? We write a paper. Everybody is happy. The student gets the PhD. The professor goes on to go to the next problem, next PhD student. Bulk of the research is that there's nothing wrong. You are actually adding to the knowledge in the world and things like that. But can we have some multi-year large programs, interdisciplinary with committed budgets, 10-year budgets and things. You can't give budget in a 1-year time frame. You need to give assured budget for 10 years and things like that. And that's why, again, when I set up the Center for Brain Research, I told them, I will fund you for the next 10 years. You don't need funding from anybody else. Everything will be funded by me. So that, they have the confidence that, even if it takes more time, even if they don't get the results immediately, they have time in front of them. And embed the translational team. Always think about how can we take parts of this to the market, because that's how the money flows back. Now, ISRO, I talked about mission mode projects, right? We are one of the 4 or 5 countries that can land on the moon, land on Mars and things like that. And the model is very, very actually interesting. It's directly under the PMO with budget and financial control, ability to do extraordinary world-class scientific work, in spite of a lot of constraints placed on ISRO. A lot of technology was not available to them, actually. They were not able to import those technologies, but they were able to do world-class research, achieve ambitious goals. So this is very good for creating missions on specific national goals and objectives, cure for cancer, autonomous car, demonstration of artificial general intelligence, etc. The second is the BIRAC model. It's probably, and you are part of the biotech system. They work very closely with industry and industry associations. It's probably the best example of working closely with industry and industry associations. I've looked at the India bioeconomy report, very ambitious. We are also creating hubs for biologics, biosimilars. We have the BioNest incubators. And industry has actually stepped forward. 1,000 crores industry support, 1,100 crores from BIRAC. So, almost matching and things like that. 621 companies supported, 130 plus products, 1,000 plus startups. So we must look at this model to create sector-based research councils and a model to work with industry associations on building research ecosystem. So autonomous cars, right? Can we now, with the manufacturing industry, create sector-based research councils, work together to build this new technology? The IITM Research Park model. So my question to NIMHANS would be, why you are not setting up a university-based research park around NIMHANS actually? Because every research university, especially the larger ones, especially the national research institutions, must set up research labs across the street so that students can actually work with industry, industry can work with students, industry can work with scientists, etc. It accelerates research, it accelerates the involvement of students with industry, industry with students, etc. And the results are there to see. So we need to accelerate setting up such research parks across the country. Our NIRF rankings actually improved our institutions today. In institutes of national eminence, etc. So there is now a framework to measure and evaluate institutions. I believe that we need to create a framework to rank research organizations so that there is a sense of competition. There is a sense of trying to achieve goals, trying to achieve certain benchmarks and things like that. It's very important. We need to look at As part of this framework, research outcomes, industry collaborations, products created, startups created, funding raised. Funding is very, very important. And these can be benchmarks for evaluating a research organization. Then to create public goods, what I call public goods, is the I-Spirit model. And India's fintech industry is one of the best in the world. I strongly believe, built on Aadhaar and things like that. Actually, it's an open platform, completely volunteer-led. They work again very closely with industry, especially startups, etc. They create a sandbox with regulators for piloting this. So, even in the healthcare space, actually, how can you create a sandbox with Medical Council of India, ICMR, etc., so that new things can be accelerated to the market, can be piloted quickly, etc., and then hand it over to government industry body to take forward. So if you look at India's stack for healthcare, now the Prime Minister has announced the National Digital Health Mission, and again a very ambitious program that will completely transform healthcare. Now here we need to work together to create a digital infrastructure for healthcare in India. Every hospital must be connected to that infrastructure, must be able to provide electronic health records for every patient, every subject. This can be beneficial for the patient, for the healthcare professional, for the industry, as well as for research. And another is, DBT Genome India project, where we are creating huge data lakes. This is again another problem, actually. Every research lab has little bit of data. They have data from 100 subjects, 200 subjects. But when you want to do research, you want to look at large amounts of data. And how can you do that? By sharing, right? So we must look at open data. We must look at creating public databases so that we can use it for AI machine learning. We can do for large scale research and things like that. So in conclusion, I want to say that if India needs to develop into a middle income country, India wants to become a developed country, it has to be driven by research and innovation. It has to be done by you people. The next 30 years, history of India will be written by all the people listening to this, actually, the research scientists, etc. So you have to, it is possible to do. We have seen this, we have planted the seeds. It is, I am very confident about the capability of our people, of our scientists, and we must actually make it happen, because that is how we will transform this country. This is the history of the world over the last 200 years. And you will see that US was 2% of the global economy, the blue line here. US in 100 years, from 1900 to 2000, dominated the world, became the largest economy. Today, US is the largest economy. Built on the first half of the 20th century, its innovations around manufacturing. It came out with this model for factory model, high throughput, high productivity manufacturing and things. There are a lot of business model changes, management theory, etc. And the second half was all about built on digital computing. And again, driven from the labs in Harvard and MIT, in Stanford, etc. And they created this. And we have several areas in which we can do this. So my question to you is, can 20th century be India's century? I think the solution, the answer is in all your hands. I strongly believe it can be. You can actually build a career. It will be very, very rewarding for each one of you. You will also become a superhero, at least in the minds of youngsters. It will create new industries, new businesses, new startups, and it will be transformational for our country. Thank you all very much. For giving me this opportunity to share this. This is my passion nowadays, and I get an opportunity to present. So here I am. Thank you very much.
Thank you, sir, for a wonderful lecture. And I think the morning has started very well today with your inspiring lecture for our postgraduates as well as the research students and the postdoctoral students. And the last slide is 21st century, belongs to the India, is the most important slide which you have said. And I do agree that we need to project towards that level. But to project to that level, I was thinking that having achieved some of these things at the initial stages in a post-independent era of 75 years, can we think that the research contribution, you mentioned that it is 0.1% of our GDP, which has to grow to 1.5%. And also the philanthropy and the private participation is extremely important. What it requires to drive these two engines so that we can get the maximum funding for the research, which is of translational nature. What you said is very true, that we require research which would be translational and prioritized for our country and what we require today. So how do we drive this, and what can be done to take this further? That is what I wanted to ask you, sir.
Clearly, one way to look at this is to identify, let's say, in major thrust areas. Definitely healthcare is one of them. Let's define 10 mission mode programs. Let's allocate maybe 1,000 crores at least to each one of them. Identify for each of those 10 areas, let's say 3, 4, 5 institutions across the country, and allow them to work on these problems for the next 10 years, right? See, this is what I'm driving at. This is how ISRO was able to do that. And I'm very confident it can happen. It will work, and we will be able to do that. And we have actually rotavirus and things like that. We have identified problems and done that. But let's identify more of these and look at such programs for taking our country forward.
Thank you, sir. Thank you very much. I think there are one or two questions we should, we can take up.
I can read it. So there are a lot of comments. People feel inspiring. The talk is so inspiring. They get very useful information. And so there is one question from Sri Kumar. Thank you for the point that Indian scientists should work for India's specific solution. I feel the industry has an equal role as that of academia in this. In the context of drug discovery and development, there are so many players, but recently, quite a few of them have quit drug discovery. Examples such as Piramal, Lupin, MCure, and even AstraZeneca, which was working on tropical infections. I would like to hear your perspective on the reasons and solutions. It is very true. Neuro-related drugs, and even abroad also companies have quit.
Right. Unfortunately, the trials have become very, very expensive, and the results are not predictable, right? In Alzheimer's, they went with a lot of molecules, etc., but none of them actually fructified. So these are cycles. I think there is renewed appreciation and focus on the drug discovery with this vaccine, right? That is why I talked about the speed at which they came together, trials were done, all the regulatory approvals are being given, etc. And why we can't, do this together? Why should the approvals be given only once a month, or sometimes once in 3 months and things like that, right? So you have to accelerate these things. Everybody has to work at a faster pace and faster speed. Everybody has to think about how can we contribute to reducing cost, right? Now, a lot of trials are not happening in India. In India, if you do the trials, it is cheaper to do trials. Of course, we need better protocols. We need better data gathering capabilities, but this can be done. It can be done. So I feel that if we I know there is a change in the perspective today. People are looking at Indian pharma industry. I strongly believe that India pharma industry can be another sunrise industry from India. So we must, and there are startups emerging. So, you're talking about larger companies, but there are startups emerging, working in the area of healthcare, looking at bringing new molecules. I think we will see a lot more now in the future.
How are we going with time?
Yeah,
We are running out.
There's just one more question. Can we approach our funding with bright ideas alone without any pilot project or preliminary findings?
Yeah, so when you look at philanthropic or government funding, you can look at open-ended research programs, questions that you would like to explore and things like that. When you approach industry, typically you need to look at applied research, translational research, because they need to, because they're funding from their balance sheet, and so they need to show returns to their investors sooner than later, right? So industry will not provide risk funding. Industry will provide funding for creation of new products, and these products will have to be created over the next 5-year period. So yes, it is possible, but these will come from philanthropy as well as governments, private funding from philanthropy or public funding from government.
Thank you, sir. One of the major issue, what we find is the continuity. The continuity of funding or continuity of the project is lacking. What happens is there is a sudden shift depending upon the need wherever it arises. Suddenly we shift our funding, suddenly we change the direction. That harms any of the ongoing project or a long-term project. So what would be the solution for such thing is usually a problem.
So we need to give protected funding for what I call mission mode projects. We need to identify certain priority areas. In those areas, we need to protect the funding. It doesn't matter which government is, which priority, which leadership is. They must protect the funding for these mission mode projects. And the LIGO project it took 100 years, right? And multi-billion dollars. The scientists working on that were working for 30 years, and they didn't show any result for 30 years. Still, funding was provided. It is difficult, but we must believe in these scientists, and at least some programs we must have protected funding.
Thank you, sir.
Can I have just one last question? Chris, what is your personal take on this? This is a question I'm brooding over it. So you have multiple agents in India funding for medical research. You have DBT, you have DST, you have CSIR, you have ICM. But if you go to the US, it's NIH. NIH supports basic research, NIH supports translational research, NIH supports clinical research. This kind of integration is my personal feeling has to occur in India.
Yes and no. It's very difficult to actually do this. We probably need to, for each program, each area, we need to identify a particular agency to take leadership. That's something we must do. There must not be competition between these agencies, these ministries. Less of that. Cooperation is okay, but for each area, you must identify a particular department to run with it. That's my take. I think the whole concept of National Research Foundation, setting up National Research Foundation, integrating these together is probably a move in that direction, and we should wait for that, I think.
Yeah, it creates an excellent platform for basic scientists, applied scientists, clinicians to talk to each other 24/7.
Thank you, sir.
Thank you all very much. Again, all the best to all the scientists. As I said, you are superheroes. Thank you.
Thank you, sir, for inspiring and encouraging talk. And we will follow as much as possible. And our students and researchers should take up your advice and move forward. Thank you, sir. Thank you very much for your time.
Yes. No, he's done.
Is there? Satish Rao?
The team was
Prioritization. Yeah, Satish Rao.
yeah, he's there.
Yeah.
Hello.
Good morning. Good morning, sir.
Good morning, good morning. Very good morning to you all.
Sure. I think we should start your talk, sir.
Sure.
It is my pleasure to introduce Dr. B.S. Satish Rao, and who is very well known in the field of medical research. And he is the Director Research of Manipal Academy of Higher Education, MAHE, at Manipal. And he has the various research interests, of which the most important is experimental oncology and nanotoxicology, which are extremely important in the present day. And a lot of activities are going on in both these areas. And he is recognized as IMSA Teacher Award in 2017. And he was also a visiting scientist in a number of universities and is on the editorial board, a member of many of the important journals. I have a pleasure to invite you, sir, to talk to us this morning on your options in advanced career after PhD. Thank you, sir. Thank you for accepting our invitation.
Very good morning to you all. And thank you, Chairpersons, Dr. T.R. Raju and Satish Chandra. And also, I extend my sincere thanks to Dr. Lakshmi Rao for giving me this opportunity to share what are all the career advancement opportunities what we have at the Manipal Academy of Higher Education. So what I'm going to do, I understand that we have the audience from UG, PG students, as well as doctoral students, and those people who have just completed the PhD, and people who are enrolled for postdoctoral studies. So I thought, okay, let us, we can have a, let us give a brief idea of what we have at Manipal Academy of Higher Education for all these aspirants. Now, when we look into the opportunities for PhDs, whether it is national or international, when we look into the global situation, we all agree that the world is moving towards knowledge-based economy. It means, as Dr. Chris has emphasized, now the research and development has a major contributions in transforming the whole higher education institutions or universities into a very vibrant place for creating the new knowledge. So the higher education institutions have very, very important role in creating the human resources reaching towards this goal. And in alignment,
Take it, sure. Your last name.
No, it's from.
There are so many.
You're not audible. Hello.
Why did we go for it? Why did we have to go for it?
hello, am I audible now? Hello?
Yes, sir.
Yes, sir.
Please.
Yeah, sorry for that.
No, not yet. Please go ahead.
Okay, yeah. Thank you very much for giving this opportunity. And let me thank the chairpersons, Dr. Raju, as well as Dr. Satish Chandra. And at the same time, I would like to extend my sincere thanks to all the organizers, especially Dr. Lakshmi Rao, when she requested me for giving this talk. I thought it will give some idea about what are the options actually is there for all the PhD scholars or post PhDs or some of the postdocs. How actually we can accommodate in these researchers in Manipal Academy of Higher Education. So in keeping in this view, I thought my first half of talk would be about in general, it means what are all the opportunities a PhD graduates they have by utilizing their soft skills, how they can explore their employment or job opportunities in different fields. Usually what happens, most of us actually immediately after the PhD, we will try to get into the academics. There are so many non-academic opportunities. So one can really explore those things. So in the second half of my talk, probably I'll be talking about what exactly, what are the opportunities which are there in Manipal Academy of Higher Education, so that our people who are aspirants, they can certainly explore these activities, these areas. Yeah. Now, we know that when you consider opportunities for PhDs, whether it is a national or international level, we have the understanding that now the world is moving towards knowledge-based economy. Now, especially when look into the research and development, it has a major contribution in transforming the higher education institutions or universities into a vibrant place for creating the new knowledge. So this is the place where actually the new knowledge is generated, and it has to be transformed into a useful product or useful if you are talking about health sector as a treatment strategy, which will be beneficial to the human being. Now, if you look into the National Academy policy, education policy, it gives a very high emphasis on creation of the vibrant environment for interdisciplinary as well as the multidisciplinary research. So the expectation of NEP is that now, over a period of time, the university will be transformed into a vibrant environment which performs interdisciplinary as well as multidisciplinary research. It also gives a clue that, yes, our PhD graduates, they will have ample opportunities where actually they can explore in various universities as well as industries. Besides this, there is a lot of technological advancement in the health sector, like health universities like Manipal. We have a couple of health educations, medical education colleges. And of course, there are a lot of industries, as Dr. Chris has already mentioned, which is coming up. And it will add to the opportunities what actually PhD scholars or PhD graduates or the postdocs can explore. So the first and foremost question, what I also experienced after my PhD is what is next actually? The first role model, what we can see in front of us is our PI itself, the principal investigator under whom we are actually working, the mentor. But we need to know actually there are a lot of other alternative jobs which will be waiting for PhDs in science. The good news is that for us, and the bad news for us is that we have lots of options. Of course, the answer is true for bad news as well, because when you have a lot of options, you don't know, you are in a dilemma whether to go with the academics, whether to go with the industry, or whether to get into a service sector, so on and so forth. The good news is that we have a lot of options. So we have to decide actually how to move forward, how to develop our career. That is an important thing. Actually, we need to decide immediately after our PhD. Now, the point what we need to do is actually, as a PhD, a fresh PhD or a postdoc, we need to think what are all the rich experiences what we have got during our doctoral studies or postdoctoral studies. For a couple of years, we have done that, and then how we can move forward. I quote the words of Fiona Denny, ICAO's University Graduate Development Director. What she says, in order to write a thesis of around 80,000 words and defend it in a viva, you have to have a huge range of highly developed skills that are transferable to a range of difficult jobs. So you have been trained and you have acquired all these soft skills. Only thing now you have to explore.
That's what we should.
Do you
Hello?
have?
Am I audible?
Do you have slides?
Pardon?
Share the slides with us.
Slides,
Yeah.
but slides are not coming.
Even now?
Yes, slides are not there. They are hearing you very well.
I have shared the slides. One minute, excuse me. Are you able to see the slides now?
No,
No, we can't see.
it's to go back. Go back, restart. Then only it will happen.
The share screen is quite obvious. No?
Yeah,
Yeah, but he did it first, then audio.
when the problem with audio came. Now
It's there.
it is there. Right?
But 1 minute, I will confirm. I will put it in this one presentation mode. Are you able to see now?
Yes, yes. Thank you so much.
Please go ahead.
Okay. So I will move for. Sorry for the inconvenience.
No.
Okay, let us have a retrospective analysis. We have PhD task and activity and the skills and competences what we have developed during the last couple of years during the process of developing or writing your thesis. Now, imagine you have wrote 5,000 words of the thesis. Now, what is the skill or the competency what you have developed? Most of the times we have not realized what are the skills what we have developed. So that is an important step after PhD one need to know actually. Ability to present and organize large amounts of information in a clear manner. Fluency in Microsoft Office packages and other softwares. So these are very, very essential skills, soft skills, probably which is, our employer is going to look for. Had two or three supervisors and supervisors did not get on. If you are working in such a situation, probably you must have negotiated with these two supervisors and then you are successful in submitting your thesis. So in a way, you have developed a very good negotiation skill. Analyzing loads of data. Obviously, when you are doing research, you are going to accumulate a lot of data, and analysis of this complex data and presentation of emerging conclusions and the concepts are very, very, essential. So this is the skill what you have developed, and this is the skill what actually the employer is looking for. You must have conducted several interviews for research projects. Suppose if you are in a clinical research, you have to have a questionnaire designed properly, and then you will interview all the subjects and get back their answers. Experience. Meanwhile, you will get the experience in quantitative, qualitative analysis. While interacting with these people, you'll be sensitive to the needs of the others. You have to get along with them nicely. And you have to have diplomacy as well as confidentiality should be retained. So all these experiences, what you will get, you will have a lot of soft skills. The experiments or theory testing did not work, but you found out why and tried again and again. So this is a common situation whenever you do your experiments, you will come across. There are a lot of hurdles. So you will try to standardize certain experiments, and then of course you will come up with the right procedure and you can tackle the problem and address the research question. So during this process, the research skill what you have acquired is problem solving skills. And later on, you have accumulated a lot of data, analyzed it, and of course, you are going to publish that. Basically, you have to communicate your results to the scientific community by means of publishing your papers in good journals, high impact journals, and of course, writing your book chapters. And not only that, you also need to present all those things in several conferences. Now, what you are going to get actually during this process, the ability to communicate complex ideas, you will pick up this ability, and effective communication is one of the most important factor which is essential for your future career development. Now, imagine that you have completed the PhD in 2 to 3 years. It means that you have the ability to plan a project and to deliver it to the agreed timeline. So you met the timeline. So whenever you get any projects, you will be able to meet the timeline because of this experience, and which is also very, very essential soft skill which any employers looks for. And of course, you have completed the PhD, able to work with the minimum supervision as well as part of a team. So these are the two important aspects. You need to have a originality, original thinking, and you should be a good team member. So these are the soft skills probably you are going to develop during the process of your PhD. Okay. Sorry, yeah. Now, meanwhile, your supervisor must have given you an opportunity to organize some of the meetings. So event management or event planning skills you will be developing. Your research group was international, or you spent some time abroad for your research. Now you are going to get the ability to interact with the colleagues from diverse professional backgrounds to successfully work towards the common goals. So this is also one of the important skill what you are going to acquire during this exercise. You took part in science communication or public engagement events such as science festivals, visiting schools to explain your research. Once again, it gives you an opportunity to develop your communication skills effectively to a larger audiences. In charge of a facility or equipment, or you set up a research seminar series, etc. So these opportunities you are going to get during your PhD program or postdoctoral program. So basically it reflects initiativeness as well as self-reliance. So whatever the soft skills what you have developed, like resilience, that is the flexibility, tenacity, team working, dealing with the difficult people, presentation skills, communication skills, analytical skills, leadership, time management, confidence, focus, ambitious nature, self-management, common sense, situational awareness, listening, self-control, positive attitude, assertiveness, empathy, responsibility, self-motivation, problem-solving nature, adaptability, creativity, original thinking, conflict resolution, and so on and so forth. These are all the soft skills. Actually, it could be classified at the personal level. In a way, actually, these are all some of the personality traits what you are going to develop during the period of your PhD program or postdoctoral program. And these are also comes under social skills and methodical skills. Now, altogether, during the period of your PhD, you have also developed and integrated your knowledge in a particular field, and all these things will help you to choose your career for your career excellence. Now, what can you be with the PhD? As a fresh PhD, one can think of basically, as I told you earlier, the two possibilities, either academic or non-academic. Now, when you talk about non-academic, actually there are a lot of opportunities like industry, entrepreneurship, business, government, in government sector and various service sector. So most probably, when you come out of a PhD graduate, you have all the inclination towards the academic thing. You wanted to become an assistant professor, and then of course associate, and you wanted to retire as a professor. But most of the people will look, more than 50% or approximately 50% of the people are looking into this, getting into an education sector. Unfortunately, with the skills what you have, you can always explore the non-academic sectors like industry, entrepreneurship, as well as business. One can think of your own startups. And of course, there are so many other fields in government sector where you can explore. Now, here is a slide, actually, what is the fate? What are the career options for a PhD? Now, as I told, most of the people who explore is teaching and education, and some people may go for the government sector, especially related to the field of policy making, education, regulatory things, and funding, etc. And another important area one can think of is journalism. These days, actually, there are a lot of databases like Scopus and Web of Science and so many things, where there are a lot of job opportunities. With the background what you have got as a researcher, you will really fit into this program. The most important aspect what you need to develop is the communication skill, of course, analytical skills, all those things you have already. So this is the area actually one can think of for their career prospects. There are a lot of social programs one can think of in the area of global as well as public health. And then, of course, if you are wanted to become an entrepreneur, one can look into the business sector. Now, the biotech startups are booming like anything, and one can really excel in this area, starting some of the industry. And then, of course, one can get into with the law background, one can get into, or you can have some crash courses and get into opportunities in IPR field like intellectual property, creating science policy and patent related activities and all those things. There is a huge scope for PhD graduates in this area. And of course, one can always look into a postdoc as an immediate option. And then, of course, at least you can divert to any one of these things later stages. So basically, what you need to do is you need to realize about the soft skills, what you have acquired during the period of your graduation. And you have to stick on to your values and interests. And then when all these things overlaps, you will be able to get to know what will be your ideal career to move forward. So by getting to know yourself, it is very easy to identify an area of your interest, and you can explore your future career. So with this introduction, I will move to the next half of my talk regarding why MAHE. So what all the opportunities are there in MAHE for a researcher, as a faculty, or as a postdoc? As you know, MAHE has a legacy of more than 70 years. With the humble beginning of the genesis of Kasturba Medical College in 1953. Now, this institution has grown into a nationally and internationally known university. Now we have a lot of campuses in Bangalore, offshore campuses in Dubai, as well as in Malacca. And the streams, life sciences streams, health sciences streams, all these things, basically it is located in Bangalore as well as in the Bangalore campus. Bangalore, Manipal, and Bangalore campuses. We have, if you look into the statistics, we have more than 2,800 faculty in my campuses itself, and then more than 30,000 students from various countries and from India. They have, undergoing several degrees, and then we have students from more than 65 countries. If you look into the research sector as well as collaboration with international universities, we have right now more than 250 plus international collaborations, both in the field of education as well as research. And last year, actually in 2019, we got about 37 crore grants for the fiscal year. And if you look into all the various institutes, more than 22 institutes we have, so they are actually under Faculty of Science, which includes Allied Health, Life Sciences, and then Faculty of Pure Sciences, Technology and Management has been put into together. And then we have Faculty of Humanities, Liberal Arts and Social Sciences. And Manipal University is trying to become a research-intensive university. Right now, we have both teaching as well as research responsibilities, but over a period, we wanted to become a research-intensive university by giving equal importance to the education, but giving more emphasis to the research activities. Now, here is a brief outlook of the various ranking agencies. This is the NIRF ranking data. Now, if you look into the overall ranking of the university, overall ranking is number 14, whereas if you take it as a university, it is 8. And here is a table which gives over the years, MAHE has steadily combined with the NIRF ranking. It climbed the ladder of NIRF ranking for the past few years, and now it is within the top 10 universities in the country according to the NIRF ranking. It is ranked in the 26th position by QS India University ranking. So here is a comparative account of the rank from the various ranking agents, like the QS World Ranking. It is in plus 701 to 750, and QS India, it is number 26. BRICS ranking, it is 120. Times Higher Education World Ranking, it is 1000 plus, and Center for World Ranking, it is 1495. Now, the vision of our university is global leadership in human development and excellence in education and healthcare. So basically, MAHE is known for its healthcare sector. Recently, it is also coming up and benchmarking outcome is visible in the other sectors as well, especially in the engineering sector. Our mission is to be the most preferred choice of students, faculty, and industry. So therefore, we provide a very congenial environment for our faculty, researchers. So we want it to be the top 10 in every discipline and education, health sciences, engineering, and management. Therefore, we are giving equal emphasis for all the sectors. By keeping all the Manipal values like integrity, transparency, quality, teamwork, execution with the passion, and human touch. So considering all these things, as you know, the MAHE has achieved Institute of Eminence status by the Ministry of Human Resource Development, Government of India. If we look into our IOV document, one of the important pillar what we consider is exemplary research and innovation. It means MAHE is going to give and already given very high priority for the research and innovation, and we welcome all the job aspirants. Now, with this background, let me see what are all the career as well as job opportunities, what MAHE is providing, and what type of potential aspirants we are looking for. Like any other university, MAHE as the research intensive university, and it has already defined the faculty role. So we give a lot of opportunities for research and development, especially for the innovation, not only in terms of scientific publications, quality publications, but also in terms of technology transfer, creation of various IPRs and patents, etc. And our faculty also work with the research as a passion. So we always imbibe people with the high potential of research. And people also have the apprehension, or faculty also have the apprehension that publish and perish. It means our policies are actually very, very stringent. Not only we support the publication and patenting and all those things, we also nurture them by providing a right congenial environment. So there are a lot of career advancement opportunities, and our promotion policies are also incentivized, or it includes enough emphasis is given to the publication and patents, etc. And also our faculty are trying to publish their publications in very high impact journals with high index, as well as these days people are talking about the quartile, and everybody is sensitized for these aspects so that they can publish in quality journals. Here is a overview of the policies what we give in terms of incentives to promote the research. So we have very, very attractive policies so that our research and development activities will be accelerated, and these are all being given to our faculty members. For example, we have Dr. T.M.A. Pai Best Paper Research Gold Medal at the institution level for best researchers who published good paper in a very high impact journal. And we provide yearly conference travel assistance. Yearly, more than 50,000 rupees is actually dedicated for all the employees, all the faculty members. They can utilize to these funds for international conferences as well as national conferences. And every publication, whatever the faculty publishes, is being incentivized by giving some monetary benefits, and also we give a lot of additional publication incentives. And then of course we have given a red carpet to Ramalinga Swami Fellows, Ramanujam Fellows, and any other national level postdoctoral fellows who wanted to come from abroad and settle here. And they have been provided a very congenial environment to set up their labs, and we give all the logistics supports. And of course, we give a lot of research assistance. This is the area one where actually the our PG students as well as the PhDs can think of. This research assistance will be assigned to all our faculty members, where especially the clinicians, where they don't have enough time to dig out the data, whatever they have. As the clinical data is a gold mine, I mean, they can utilize the services of research assistants to extract those data, to analyze, and they can be, because of this, one can promote a lot of, publications. And also, they can also develop some preliminary data for the publication, the grant writing. And specifically, we have some postdoctoral fellowships. It will be facilitated, it will be attached to some of the departments as well as the faculty. depending upon their credentials, they can actually take the initiative to hire some of the postdoctoral fellows. And we have a lot of structured PhD programs. Every year we support MAHE structured PhD program, Dr. TMA by program. It is more than 150 per year. And we take in, 2 times in a year, we have 150 such fellowships. So most of the graduates, postgraduates, they can explore this possibility, and one can look into our website to explore these possibilities. And faculty incentive for the PhD guidance itself. So we promote our faculty by giving some monetarily benefits so that they will, take more and more students for PhD. And one of the most important thing what we have this year is that for the last 1 or 2 years is that MAHE Springer agreement for open access. Now, under this program, we have open access agreement with the MAHE Springer, is that we can publish our papers through their contract in an open access journal, where actually our faculty members and researchers can utilize this facility, so that MAHE bears all the article processing charges. This is how actually we promote our researchers. Now,
Dr. Satish, sorry to interrupt. Could you finish in 2 minutes, please? Thank you.
Yeah, like this, we have a lot of MAHE policies which will promote our any faculty aspirants or researcher aspirants who wanted to come to MAHE. So one can always explore these some of the postdoctoral fellows from National Postdoctoral Fellowship or SERB related research grants, and MK Ban postdoctoral fellowships, Hargobind Corona Innovative Young Biotechnologies Award one can get, and then some ICMR postdoctoral fellowship. So if you are would like to come to Manipal Academy of Higher Education to explore your higher studies, you can explore such postdoctoral fellowship, and we always welcome you. Some of the institutes such as Manipal School of Life Sciences, where people with the health sciences as well as life sciences background, you will be imbibed in various departments, research departments in School of Life Sciences. And then we have a Center of Molecular Neurosciences, where we have a couple of Ramalingam Swami fellows. And similarly, you are all welcome to come as a either faculty or as a postdoctoral fellowship. So these are in brief about the job openings, and you can look into our website, so you will get to know about the openings in time to time. And I kindly request you to explore these so that there will be opportunities. So these are some of the other potential institutes like departments. As you know, we have a very good medical college, and we have allied health colleges. And of course, this is the one place where actually, if you wanted to do some interdisciplinary research, we have the strong backup of Manipal Institute of Technology, not only the engineering field in areas of IT and computer science, etc. We also have biotechnology, and we have a very good pharmaceutical sciences college where there are a lot of job opportunities as well as postdoc opportunities. So you can explore all these opportunities if you are able to explore some of national postdoctoral fellowships. So with this, I welcome you all, and if you need any assistance, you are free to contact me to explore any such possibilities. So if you have any questions, I'll be pleased to answer. And once again, I thank for giving this opportunity to show what all we have in MAHE. Thank you very much.
Thank you, Dr. Satish, for a very lucid presentation In fact, you made PhDs to recognize the kind of soft skills they possess. Even I didn't realize it before. That starting from conflict resolution, creative thinking, and management and communication. Oh, so many things they do have. This reminds me, 40 years back, Harvard Business School introduced an MBA program for PhDs, 1-year MBA program.
Yeah.
They recognized at that time, which we did not. And also, your institution is so impressive with so many opportunities which are available for after PhD. If somebody wants to utilize these opportunities, I'm glad to see that your institution is open for that. Thank you so much.
Thank you. Thank you very much.
Any questions? Just come.
I just have one question.
Yeah, please.
It was a very impressive talk. I just wanted to know, since you have all under one roof, like technology, medical, allied health, as well as pharmaceutical industries under the one group, how much is the inter-institutional collaborative research going on in your place? Because taking the technology into the allied health or taking the pharmaceuticals into your medical college.
Right, yes. In fact, most of our research activities are interdisciplinary in nature right now, because thinking of our IOE targets, we have already initiated and it has already crossed 60% of all our research projects are all interdisciplinary in nature. Especially these days, there's a, very good bonding between the allied health and engineering, developing some biomedical devices and all those things. Similarly, it is also seen in medical college as well as the engineering stream, especially the computer science and IT technology and all those things. It is going on actually, it is catching up. Yeah, hopefully in near future, we are going to reach at least 80% of our all grants will be interdisciplinary and multidisciplinary in nature.
I think that is a great opportunity wherein you have a technology along with the medical field together, where we can work together and get the things what a medical person requires or what a technology person needs. So both can work together and develop these things. It is very, very important.
Yes, yes. Thank you. Thank you, sir.
One important thing he has said this that he can, the students can explore PDF marking. That's a good suggestion.
Good.
Sir, I have one question to you.
Please, please.
For example, now the previous speaker, he said mission mode approach for any kind of research. So identify some areas. Like in a similar language, if MAHE is the one center for multiple discipline, whether MAHE can take up one areas and fund other smaller institutions so that research can come not just only from MAHE but from other. They can join the MAHE in identifying certain areas and also giving some very innovative results. Is there any such kind of things you think we can do it from MAHE?
At present, we have collaborative research grant explorations. We do that actually. Yeah.
But most of the time, any big centers, they look for collaborations with a big center. I know that MAHE is actively collaborating with NCBOs and INSTEM. But if MAHE can also collaborate with a smaller institute, it could be for example, in Bangalore, we have many centers. Simple smaller colleges, research colleges. Colleges convert that into research colleges.
Yes, yes, yes. Certainly, we welcome that. It all depends upon the expertise of what they have. And if they approach us jointly, we can explore some, public funding grants. And there are so many such instances. Already we have such things. It is going on actually, including some of the, degree colleges and all those things. We do promote all those activities.
So is it through funding?
Yeah, mostly it is through funding, because I mean, at right now, as you know, because of all these situations, COVID situations and all, even our intramural grants, all those things have been suffered. Probably over the years, when we, grow further, certainly we will look into that. Yeah.
Yeah, I think it'll be wonderful if you start hand-holding smaller institutions.
That's true. That's true. I got it.
Thank you, sir.
Thank you. Thank you very much. Thank you very much for the opportunity to all of you. Yeah. Thank you.
Thank you, sir.
Okay, then we can continue. I think other speaker is online, I guess.
You can just find out whether he is ready. He's from abroad, isn't he?
Indian universities becoming vibrant environment. If that can happen, that's the best.
Yes.
But so far it never happened.
It should now. This is the time that
That's
we
the
need to
reason.
go up.
Yes.
See, the best advantage Margie has, which he also mentioned, under one umbrella,
All under one roof.
there is so many. We need to improve the
Correct.
world ranking, because whenever all the world ranking agencies, they are not looking at the standalone universities,
Correct.
medical university,
They
technical
have that
university.
vision.
There is an advantage. University.
Huge
That
university.
is what is very important.
In
Very
80s,
good.
in 1980s, even in Nimmans, we didn't have that one.
No, they have
rooms.
that is
Just
what-
parking boardrooms.
Exactly. Now that is what I was asking, because for example, if I want to develop something here in demand, we have to collaborate with some other outer.
Oh God, I was
Taslim Arif Said.
ready.
You also say.
Can you hear us, Dr. Said?
Yes, I can hear you well.
Okay.
Good
thank
morning,
you.
everyone.
Good morning.
Good morning.
Yeah. I'm delighted to introduce our next speaker, Dr. Syed. Dr. Syed is CEO and Director at Center for Cellular and Molecular Platforms, CCAM. CCCAMP, is it, or CCAMP?
CCAM.
His initial training has been in neurosciences, where he received his PhD from Max Planck Institute of Brain Research, followed by postdoctoral training at the University of California, San Francisco. At the same time, he also underwent training in management for biotech and innovation from QB3 at the University of California, Santa Cruz. He has also completed biotech management program for biotech executives at Wharton School of Management in the Bay Area. He served as a management consultant with QB3, New Biotech Venture Consulting, and in individual capacity, he is also consulted for many biotech firms in the US. Dr. Syed is an adjunct faculty at Indian Institute of Technology, Madras, and also Amrita Institute, School of Biotechnology. He also heads the Discovery of Innovation Accelerator Program at CCAM. He is actively involved in promoting innovation in life science, healthcare by supporting translation of discoveries to application, entrepreneurship, and technology development. We are very, very happy to welcome Dr. Syed to deliver the next talk. Thank you.
Thank you. Thank you very much, sir, for your kind introduction. And it's a pleasure to share some of the thoughts here. I'll just try to share my screen quickly to start going. Yeah. Can you see my screen?
Yeah.
Yes.
Okay, excellent. So I think in next 20 odd minutes, I think it's a great opportunity, and thank you for bringing this aspect of how exciting science can actually be taken forward through various means. And when one looks at it, I think one of the major biggest impact of science, as we all know, and I think from my own understanding of when I started my work in PhD, I just want to share very quickly, my work was largely related to how neurons talk to each other, how the presynaptic and the postsynaptic neurons talk to each other, and what are the messaging system and so on. But the implication of that in terms of the further on, how the damage happen at the presynaptic side or how postsynaptic the cluster formation gets damaged has a huge understanding impact later on in terms of how the broad neurotransmission derailment happen and what can be done to do that. Similarly, I think science at large has a great role to play when the discoveries happen and support that to take it forward. And I just want to give you a quick perspective from the CCAM side. I think I'll just very quickly mention about, I think science entrepreneurship, as we know, while we talk about entrepreneurship from a perspective of company formation, I think entrepreneurship was never meant as a company formation. Entrepreneurship, as we go back to the word, entrepreneurship is something that one takes as a task to do that. And if you want to take scientific entrepreneurship as a journey to take knowledge towards its application as a task, I think that's what I call it, scientific entrepreneurship. And that scientific knowledge reaches its maximum impact when it solves a societal problem. And I think it has to be that strong fundamental knowledge actually taken all the way to solve a societal problem, which is very, and we do have many knowledge actually such like that, which has come to the forefront now. And we have seen that the first of its, the RNA vaccines, mRNA vaccines, how that has resulted into the first vaccine for COVID-19 compared to the traditional conventional aspect of the biological based vaccine. So this is clearly how science is going forward, as we see how CRISPR actually is going to make changes in terms of the gene modification and hopefully, looking at gene therapy for many aspects, not only healthcare, but other agriculture and other aspects. So this is clearly how science, as we speak, actually takes a center stage once it actually gets into the application mode. We have many examples of how this has been taken in entrepreneurship journey and very close to our heart. Many applications are being built around us. Bangalore is a clearly an epicenter in terms of amazing work being done by many companies, including the works of the biocons of the world, but very importantly, their collaboration that is happening between academia and industry that leads to a fantastic work. Importantly, I want to talk about when academic scientists or PhD scientists or postdoctoral scientists or faculty, when they take on to decide their own work, her or his own work towards building a product, this is where the real passion actually goes to the next level. And we do have several examples. The world's biggest biotech, as one would call it, is Genentech, which is based out of San Francisco Bay Area, which started from a US, my alma mater is one of the faculty, UCSF, when they decided 25 years back that they want to start a company based on that. And this is the world's biggest biotech right now, acquired by Roche, of course, a few years earlier. But this is how an excitement, a passion of science actually allow you to go and then solve a lot of problems around us in the society. India, if I may just come to close to our home, in India, last 8 to 10 years have been phenomenal in terms of way science has been looked at to drive innovations with a journey that would finally reach a destination to solve a problem. And what I want to share more today about is that there are real good examples around us right now, which is happening, and how I thought that this is a good idea to share with a larger audience, which is a scientific healthcare community, which can actually take a note of it. And then if necessary, a dialogue can be created around it and more could be done. And at the last, I would have a small request to Nimhans, but I'll come to that at the very last stage. So just to come back to, as I said, that I would like to share, this is from the perspective of the CCAMP. So CCAMP is actually based out of right north Bangalore, which is a part of Bangalore Life Science Cluster. CCAMP is co-habitat of the Bangalore Life Science Cluster, which has also INSTEM and NCBS. NCBS is already a known organization. I do not need to introduce, but a phenomenal, top-notch fundamental science organization, a center of TFR. INSTEM and CCAM came around 2009-10 with the support of Department of Biotechnology, while NCBS is a DAE organization. INSTEM's mandate was to do stem cell research and regenerative medicine approaches, and CCAM was clearly positioned as a catalyst, as if I may call it on a soccer field, a midfield player on a soccer field, which works with the defenders as well as the strike players, and ensure that what gets done in the defense, how from the right flank or the left flank, it can move forward, and the right opportunity, the striker actually goes and scores the goal. So the midfields, just like Zinedine Zidane's of the world, is a very important game, and catalyst is something, a very important role that was given to CCAM. And this was conceptualized by Dr. Ban and Professor Vijay Raghavan at that time. And we hope to continue that mandate forward. And I'll show some of the work that has been done over the last 9 to 10 years. So I welcome, of course, this is CCAM. I welcome all of you to whenever you can get a chance, once the things get better for all of us, to visit us. But at the same time, we have two verticals. One is the technology platforms, and the second is entrepreneurship program. Third vertical, which is Discovery Innovation Accelerator. I'll not talk about it much today, but happy to discuss it if the discussions go that way. So the first one is a technology platform, which was an angle created where we said that in science, the way science is working lately, it has been largely that science and technology is driving each other. The technology is a tool which is driving science, and science is pulling technology further in terms of the analytical approaches and so on. Hence, the tool has become very important to drive science to the cutting edge. As we know, the cutting edge of the cryo-electron microscopies of the world, or you want to talk about the cutting edge of sequencing, it has become one of the very important things. And these tools are actually driving how good your science becomes forward. And that's where what we have done over the last few years is that work with the NCBS, INSTEM, and CCAM is to put the best of the technology platforms under one roof and make technology platforms as well as experts have it available and accessible to researchers across India. What do we have it? I'll just very quickly go by it. We have best of the fly cytometry to the screening capabilities, genomics, mass spec of all kinds, structural capability, including India's only high-resolution cryo-electron microscope, microscopy, and so on. So now, while this is available, what has happened through that? We have done more or less more than 2,500 projects across India, as we can see. These are the different collaborations in terms of through technology platforms we have done. Have very high amount of publications, which is nearly 200 now, and we have worked with 250 organizations across India. This includes academia, this includes industry, this includes startups for under technology platforms where projects come, we work with them on projects and take it to the next level. How does it help largely? It helps that you already have a high-end capability technology platform established. You have champion of that technology working with you to ensure that you get to the next level, and then you can achieve the scientific outcome rather than spending time to establish, get better, and have a person to look after it. And this has worked out very well. I didn't mention one aspect, but we also have India's only capability in building transgenics, including CRISPR. For at our place, we can do transgenic animals. We have collaboration with the international facility for having our own mice, which we can share with others, including in fly models and so on. I'll quickly switch the gear, but I just wanted to give one perspective to all people that how this is happening. I'll quickly switch the gear. The second one, which is something that we want to talk about more. So what we have done in last 8 years under this vertical is to identify very interesting concepts, ideas, and support them through various means. But more importantly, give them a chance to fly. Many a times, this is a very important aspect in a broader scale, that how do we actually build a capability to give a chance to young ideas. And this is something that we have built in terms of our ability to fund young ideas through collaborations with central funding agencies as well as local funding agencies in the state. Of course, we have very high-end capabilities in terms of incubation. More importantly, and I think this is more intangible but very important thing, is to guide young ideas, guide young innovators to actually ensure that their ideas are post proof of concept, post pure scientific journey, are also going towards its impact and productization and so on, and of course accelerate them later. What has happened now, these are the schemes which we think which are means of doing it, but what has happened is this: we have now around 200 innovations that we actually have supported. 200, and this is really stunning, because while we have done this number, while this is not important, what more important is what has come out of it. What has come out of it? India's only entry in what would call it in world's game-changing innovations across all sectors. You take aerospace, you take nuclear energy, you can take anything. So there is 35 best game-changing innovations of the world were cited, and India's only entry was Bugworks, which is a company, which is a startup which is trying to develop novel antibiotics against AMR. To this audience, I don't need to, tell you more about AMR, but all we know that AMR is the biggest health. The projection is that right now, while we have lost in COVID-19 possibly more than 1 million people across the world, by 2050, the projection is that AMR will cost us 10 million lives a year, 10 million lives a year within within 3 decades. And I think this is something we have to work on. Bugworks has developed a new capability which has new small molecules which has been tested, including in the hospital acquired full complete resistant strains, and shown that they have the ability to take care of the infection there. They are going in phase 1, and this work has been completely based out of Bangalore. The important part is that they have been funded by BARDA, which is US government, and other programs which has given a funding agency called CARBEX, as well as Japanese investors. So what we have is a very interesting drug discovery for AMR, where the last gram-negative bacterial infection antibiotic was actually developed in 1960s. And this is something this is very interesting in making. So this was Bugworks. If I just shift the gear towards, continue with the infection biology for now, but come to other aspects very clearly, is Koyo Labs. Koyo Labs actually came through a very interesting mechanism, and something that I want to talk to Nimhans in the last slide is through an immersion process. This company was formed by 2 young guys, less than 30 years. One was a product of NID, Ahmedabad, a design engineer. Second was a mechanical engineer. And they wanted to do something new. And they took part in an immersion program where they would shadow ICU clinicians, ICU specialists, and just say that, okay, we will just observe. And during this, they observe one of the major issue in terms of ICU called ventilator acquired pneumonia. All of you would know about it, but VAP, ventilator acquired pneumonia, is one of the biggest cause of losing lives, more so in elderly once they acquire pneumonia. I don't need to possibly tell you what VAP is and what it does, but they have now a US FDA approved product right now in market, which actually prevents occurrence of VAP. And this is, as we speak, considering COVID is around us and a lot of people actually went on ventilator and the survival rate was only 10% or 20% where COVID patients went on ventilator. This machine was very important to prevent secondary infections caused on patients who are on ventilator. And this is actually one of the very, very important things. This was a combination of engineering. What they did, they had a catheter which went on the ventilator machine, which actually goes to our trachea and senses humidity or moisture. So as soon as your mucosa or saliva is formed, it actually aspirates it out and bleach it right there. So it's actually preventing the occurrence of pneumonia by not letting any of your oral secretions go down to your lungs, which causes the pneumonia. It's phenomenal work, a smart intervention, and actually it's now US FDA approved. Of course, it's also in the market. So it is a real exciting that they have done. Same way, we have a stem cell work which is happening in few of our companies. I'll very quickly mention about them. Pandorum is a group which is trying to build stem cells for, in terms of the mini liver outside the body, human liver outside the body, and they have the ability to do that. At the first low-hanging fruit for that, they are using it for hepatotoxicity studies on liver for drugs and so on, so that you can have instead of animals, you can now have on human cells, which you can grow as much as you want. At the same time, futuristically, you can actually build liver patches so that you don't have to transplant livers and so on. The second thing they're doing is actually a suturable cornea, one of the only 2 groups in the world who have now the capability to grow suturable cornea and use that. They started from here, they are graduates from ISC, one from biophysics and one from aeronautical engineering department, got together and built that. Very exciting work. They are right now in the US at the UCSF again, and as well as here. They're running a company from 2 places. Again, very, very exciting work. I'll switch the gear and mention about a few other companies like iStem, which is right at the bottom, which is also doing stem cell therapy for vision disorders like retinitis pigmentosa or acute macular degeneration in terms of age-related and so on. Again, very exciting work, and they have shown the data in US labs where they have done the data in the rats, where the model animals which didn't have any vision, upon implants, they were able to more or less see it and as good as any other technology right there. The most important thing is that it is an affordable technology which India can actually take on compared to another technology which is based on AAV vectors, which would cost you $400,000 a shot. So this is something very, very important. I'll give you one more example and possibly jump out, otherwise I'll take too much of time. In environmental biotechnology or synthetic biology, just to shift the gear, we have something in agri as well. But string uses synthetic biology, this microbials, to convert what you call it methane gas, which is a global warming gas, into peptides, proteins, and hence food, which would be value-added foods from what you call it as a global warming gas, as like methane. So this is something that is, these are the clear examples of India is now seeing amazing scientific ideas which have come forward. What they needed was a platform and appreciation and hand-holding and nudging and mentoring to take those forward. A lot of these are successful. What they have done is they have been now invested later on by the private investors. Many of them will fail, but what India needs is this scientific journeys going forward to build products and so on. And just I wanted to give you a very quick perspective of this. We also have going on in diagnostics, many of them which can do a point of care diagnostics, and several other examples, but I'll possibly happy to come back later on. So our innovations are broadly, in antimicrobial resistance. I didn't talk about all of them. One that we are doing is a biomonitor, which actually uses textile chemistry and aerodynamics in a smaller environment to be able to take the microbial load down by 99.9999%. So it could be in ICU settings, it could be in normal settings. Any microbial load can come down, and they have data available for that. We are just testing it for other airborne pathogens, including COVID-19, and see that could be done as well. It's difficult to get the testing done on that, as you can imagine. We are trying to aerosolize some other viruses, and we are trying to see if that would work. In molecular biology, of course, there are several. Regenerative medicine, I talked about iStem and Penderum, but we have few more here. In oncology, there are several which are using immuno-oncology. There are several in medical devices. In maternal child health, we are seeing something that we want to do more because of specific issues in India, and so on. I'll just move fast. Many things in agriculture, I'll not talk about it, but again, very interesting approaches in agriculture. I'll just give you 1 minute backup of this. Praveen, who is also a faculty at INSTEM, started a company called Sapio. He is actually a nanotechnologist who has small chemicals which actually can go on a skin for farmers and farm workers who are otherwise heavily exposed by pesticides and have a long toxicity, and how you can decompose them as soon as you get in touch with them. So it doesn't penetrate to the skin and your toxicity doesn't build up. C6 uses algal glycobiology for agricultural things. There is a veterinary science, and there are several more. I'll just quickly move. So I just wanted to say that slowly, while we are building innovations, now we are trying to say that there is something important that we have to do. We have to build societal impact as well. So we are selecting a few programs which are important for India. Nurturing innovations in maternal child health, we think is very important. We have a technology which would possibly look at therapy for symptomatic uterine fibroids, which is minimally invasive. We are trying to look at platform for preeclampsia, which you know of how important it is. Fetal monitoring device for preventing stillbirths. Diagnostic platform for early neonatal sepsis, which can be a companion diagnostics to understand inflammations based on saliva markers, and several more. I'll just keep on going. Agriculture, I'll not go into it, but again, very important for India to build innovations in agriculture. We have not seen groundbreaking innovations in agriculture. And of course, antimicrobial resistance we see is a very important thing. Ourselves, CCAM has been funded by a US government program called BARDA, as I mentioned, as one of the top 9 or 10 accelerators of the world. The rest 9 are from North America and Western Europe, and CCAM is the only one for AMR accelerator outside that. This is our overall impact. I think I have said that, but idea is to be the catalyst. Idea is to be the midfield player, as I mentioned, and be a very important role. We are not from the starting line to the defense. We are not the striker as well, but we are trying to play the midfield role very effectively, and we would like to do that. I think there are several roles of taking the scientific journey forward. People somehow box it towards a company formation or something, but there are many ways to do that, including translation areas. CCAMP has started a translation program called the Discovery to Innovation Accelerator, where we take academic discoveries from India, do the risk mitigation, and then try to make it available to industry, because that gap is very big and not being something. So we actually have a program right now, call is open, called NC Track. Call is open, the website details I couldn't put it here, but again, very important. Translation of great science is important, and that culture is slowly building in India, and we have to push that more. So there are several open positions. If there are scientists, there are colleagues who are looking to that. We have several positions open. The details are on the website. All of them have the positions at different level open, and we are trying to see to attract the best talent which can actually come and work with us. Before going, if I may just, so one of this aspect, we have a program for immersion, the way I mentioned for Koyo, where they identified that the VAP was there. We have a healthcare program where we are hoping that we will formally write to NIMHANS director to see the immersion for this innovation fellows could be allowed, to see that those fellows can shadow some of the clinicians at NIMHANS and see problems which have otherwise become a part of general norm, and see if they have new ideas to solve it. So problem identification, and we see NIMHANS as an important partner. So this is a kind of a precursor to our formal note to NIMHANS director that we will come to you and request, hopefully that would, if it is possible, we would love to see if that happens. I'll stop here with happy to be reached at any of these coordinates. And thanks again for giving this opportunity to share about our efforts, because this is the only way we can reach out to the larger community and work with them to take our efforts forward. Thank you so much.
Thank you. I think you have brought up a very important point where you said that the researchers can shadow the clinicians or the people at NIMHAT, which is a very, very important aspect. I think that should go a long way. In that direction, I was thinking that you were talking about many of the innovations in the microbial resistance and VAP. And that is an important area from the clinician point of view. I am a clinician. That's the reason I wanted to ask you a question. Whether do you have something or the barrier in the ICU setup? The reason for that I'm asking is one of the major problems in ICU is the cross infections, which are extremely important and very dangerous. And we have many patients succumbing to the cross infections in the ICU. Is there anything which is there in the innovation or the way you can isolate or separate out without much of hindrance? Isolating with a room is a different thing, which is extremely difficult and very not cost effective. What I wanted to know, is there any barrier method by which can be done?
Correct. So, no, thanks, Professor Chandra. I think that's thanks for that question. I would say that in terms of physical barrier, as you said, that it's one thing is possible to do, but the second thing is one of our innovation, which is called biomonitor, and we have a couple of more in that line now, which has the ability, a small device which uses the room air to be completely not purified but decontaminate, which is very, very important thing. And we have done the testing in the smaller environment to a larger environment. Of course, you need a higher capacity in a larger environment or the space, but where we have actually gone down to 99.99% in terms of the microbial load. And that's where the cross infections are. If they are airborne pathogens, actually studies suggest, as you would imagine in ICU, it's not only airborne pathogens which actually cause, because there is a very small amount of time that non-airborne pathogens also can have the cross infectivity for various other issues. So this actually allows that on top of the environment-based cross infection. The second aspect is the surface-based cross infection, which is another art. So antimicrobial reagents, which actually would tone down in terms of, so there are now agents which actually can kill the pathogens once it arrives on it. So that's a surface-based. I would have, so we have just a second time supported them, biomonitor, and also Japanese funders have just funded them, which would allow you the major cause, which is the environment's cross infection. And this is actually more or less there. We would like to we are hoping to get product in the market in next quarter or so. So that if there is an interest, I'm happy to connect them with you and see if NIMHANS or allied sectors can benefit out of it, because at the end of this, we would like to, and I can say that infections do cause deaths, and also many of these innovators have their family reasons to get into this. And I would not specifically take examples because of privacy issues, but I think they are largely also driven by societal responsibility. So we would love to work with you clinicians who are the frontier of the healthcare delivery and see if this can be taken forward.
Thank you.
Thank you so much for an excellent presentation. And one question is, do you also act as an angel investor?
Yes, so we have funding programs, I would say, at our place, so which we work with both government, local, and private funders. So we have significant funding programs, so we can fund early ideas, even risky ideas, which has significant risk involved in them. We are more excited by them because this is something, if it works, we'll have a leap, a big leap forward rather than an incremental thing. So we do have that capability.
So they can come with the ideas, or they can write to you with they have some idea and they want that the works.
Indeed. So even if you have early idea, you don't need to have a startup. You can be an individual who can be supported. And once the proof of concept is achieved, you can decide to see if you want to now form a company or rather, close the project per se. So that is very, very possible. So several academic, postdoctoral faculty have actually benefited out of it to do that already. We have very high number who have actually benefited from this.
Tasleem.
Yeah.
Ravi here. I have a question.
Yeah.
So if somebody it's a follow-up of what Professor Satish Chandra asked. So if somebody, say postdoc or early career faculty want to approach you with an idea,
Correct.
how do they approach you? There will be specific calls or they just write to you. I think it will be beneficial to all the audience if you tell they have a.
Yeah, absolutely. So I think there both ways are possible. First of all, I think feel free to write to us so that we can tell you where your idea would fit, right? If it fits here, we can tell you that next call would come. So let's say for young idea, one would say that which has not proof of concept achieved, there's a program called BIG, which is starting on 1st Jan. So we can say the call will be open on 1st Jan and you apply there. But to be able to assess where do you fit, please feel to write to us. The emails are very open. You can write at ccamp@ccamp.res.in, or there are several emails on the website. They can write to me, tasleem@ccamp.res.in, and we can then see where their ideas fit. And then if the calls are open or something that we have running and they can already take a part of it.
Yeah, I have one specific question about your cornea project.
Yeah.
Where does it stand now? Is it ready for clinical trial?
So that cornea project, they have already data in the preclinical, and they would be hopefully looking at early work later next year, not immediately, but something they actually want to take it later next year in terms of testing it with early in humans.
Yeah, if you need any help, I can connect you with a very good eye institution which is open to research.
That would be lovely. That would be lovely. I think these are young innovators and they would always be, I think, very appreciative of experts in the field, considering they are not, the eye experts. They will be very appreciative of that. So we'll be grateful if that could be done.
Yeah, these are also a bunch of young ophthalmologists who always want to look at what is happening fresh, what is happening new.
So that would be lovely. I don't know how to get in touch with you, but I'll be happy to do that. Yeah.
So I have one question here. This is Lakshmi Rao.
Hi. Thanks for the invite. Yeah.
Yeah. So this is just for the benefit of us and also for the younger generation. You have showed us so many startups which is initiated and supported by CCAMP. Can you give us one example how it has been led this kind of startup? Which probably open an eye for us also and also for our younger generations.
Yeah. Did you mean how, if I got your question right, how we supported the startup, or
whether scientists have come forward with an idea, or you have encouraged them through funding or any other process of getting into startups?
Yeah. Absolutely. So I think this is a combination of everything. I think there have been many a times that people have ideas and they are looking to get support for that. But as you know, there is no better way than actually have the resources to support such ideas and call those ideas so that you can get them from all quarters, right? There is one use of word, there is a push mechanism, there is a pull mechanism. If you have funding, it allows you to pull ideas from anywhere, which is not part of your network. So it's not it's not a customized way. So I think initially we began to search for interesting ideas and we got very, but to scale up so that we have critical mass, so that we have enough people attempting those. We actually tied up with government machineries to build funding resources. So we are now pulling them in. So they're not in network, they see it somewhere and they apply to the idea. I'll just give you a quick example. Last 4 months, we have run a competition called National Bio Entrepreneurship Competition, which is India's biggest bio entrepreneurship competition. The total funding from private guys, not government or CCAM funding, including investment opportunities, 7.1 crores. And We got around 3,100 applications from there, and each and every state of the India, including Union Territories. This is done to ensure that the young talent gets a kind of unbiased platform to share their ideas and then show them further. So these are different mechanisms we are trying to pull them. And once they are in, once we recognize the potential in the idea, then the hand-holding starts and then we go further.
So you don't define any priority area?
I think it's a good question. We began with completely agnostic, but slowly and steadily we are beginning to make a specific calls, like as I mentioned in geriatrics. We want a lot to be done in geriatrics. All of us know from my own work in neurodegeneration, we know that geriatrics, India possibly will have the highest number, not the percentage, but the highest number of elderly as we go forward. And it will be a problem for a good lifestyle for them, a quality of life. And that is one. Agriculture is important. Maternal child health in India, again, is very important. AMR, India possibly is the epicenter of AMR for the world. And more importantly, as we go forward, something that can solve India's problems in terms of equivalent universal healthcare, if one want to call it, digital health. So we are looking at different areas also and align with different ministries. Like digital health will be mighty, as you can imagine, and agriculture will be agriculture ministry. So we are trying to align with them and build areas, but we are agnostic in general within life sciences and healthcare.
Excellent.
Thank you. Very interesting talk, and we learned a lot from you. Thank you very much.
Inspiring.
Thank you.
Actually, women should have this SLS, like science entrepreneurship and science innovation.
And then
they should communicate with this and with us.
I think out of this meeting, I think you should suggest and have to have something taking it further.
Otherwise, individual wise, it might not be possible.
And even have to have a nicer biomedical engineering department also.
Thank you, sir. So we'll go
Yes.
next one.
Pankaj.
Next one. Yeah. It's very nice to have you, Dr. Pankaj K. Joshi, this afternoon. And we are almost reaching afternoon now. And Pankaj Joshi is a science enthusiast who dreams of making a positive impact on human life. And that is very, very important because we are all looking towards that. How do we take the science to the human life? And he is PhD from G.B. Pant University of Agriculture and Technology, where he worked on developing transgenic plants that can grow under extreme conditions. During his postdoc at International Center for Genetic Engineering and Biotechnology, he was a part of the core team that made the notable discovery of metrons, a type of microRNA in plants. After his successful career in life science research, he joined Sigma Aldrich Chemical Private Limited, now part of the Merck, as a field application scientist in 2010. Outside his work, he enjoys spending time with his family and occasionally tries hand and at cooking and relax. And also he is into developing the head of the commercial marketing, research solutions, and his subject knowledge and process clarity, innovative and strategic thinking, and mindset of keeping the customer first have been the key drivers of his career growth. So his main interest is in the commercial marketing. So that is another important area all of us have to know. So I think we have a very important person to talk about it. Dr. Pankaj Joshi, over to you.
Thank you, sir. I'll just share my screen. Give me a second. Perfect. I believe you can see my screen.
Yes. Please go ahead.
Great. So good afternoon, everyone. Thank you for such a nice introduction. So to start with, the topic was topic of this session is options to advance career after PhD, the lesson learned. So about me, if I talk about coming from a very modest family, just a second. Coming from a very modest family upbringing, my interest in science culminated with the people dimension and led me to take up career in life sciences industry. Currently, I lead Merck Life Sciences commercial marketing, And like I was talking about the topic, it consists of two important words. One is option and another is lesson learned. So, it gave me a time and it gave me to reflect back on my life, like what are the options I had. So I was really thinking of two kind of options. Okay, what were my hypothetical options and what were my real options on that part? Right, so I reflected back on that part, and it was a very tricky one to look at. And to understand that, you need to really look at what was my story of life. Right. So when you look at me, I did my master's from a very small town in northern part of the country, which is Srinagar, Garhwal. And after that, I moved to the PhD. So it's normal, like in India, everybody did this master and usually moves toward the PhD side. And once we complete PhD, and the option gets like what to do after that. And for me, there was a twist. So in the final year of my PhD, I got married. So with the twist, the options changed. So for me, whether it was a teaching, postdoc, industry, or R&D, for me, the option became whatever I can get at earliest. Right? So when I looked at my path, one is plan A, and that plan A is for everybody. Where it's that once you do PhD, you move on to the postdoc, and from postdoc, you look to publish high impact publication, accumulate citations, and finally look towards the permanent positions. And there comes the dilemma, what to do and where to do. And usually after PhD, most of the students get into that part. And that dilemma stuck me too. And what I did after that part, specifically onto working on that part, I landed in ICGB, right, under Professor Sunil Mukherjee's group, where I was working with 2 PIs and 3 PhD students. It was tough to start as my work was supposed to be on a small RNA, and I had never handled things beyond plant tissue culture and PCR. This was the first time I understood the word agility. And I would request you all to remember this word agility because it remains there lifelong and it has to be imbibed within us. And with help of those young PhD students, I could learn a lot of tools and techniques and tricks from them. And the best part, they all could make me expert within just 2 to 3 months. And sometimes we talk about, the important thing is learning from your experience, which is happening into your life. The best part during that postdoc time was we always used to have paper presentations, and that we all have, whether we are into PhDs and papers, we all have those paper presentations. And during those paper presentations, specifically Dr. Mukherjee used to grill us in such a way that sometimes I used to get frustrated and I would say to myself that, I didn't wrote this paper, neither I reviewed it. Because he wanted us to have that end-to-end clarity and ensure that we get that knowledge and we speak well about it. What it helped me, because I was talking about those skill sets, it helped me to gain agility, it helped me to gain that confidence level, and it helped me to handle objections, which is very important as you progress in your career. Right? So overall, when you look at that part, it gave me a very, very big learning. One thing, what I felt when I completed my PhD, I used to assume that, PhD is the only hurdle. Once I go through it, I'll have my fruits of my own life. But, thought process changed. But because in reality, it doesn't work like that. After completing PhD, the another hurdle came in as a postdoc because you have to adapt to that new environment. You have to acclimatize to that new environment. That gave me a very big learning. While doing postdoc in 2009, I got inclined towards an application scientist role. And that was role in a life sciences company. I loved the way they used to come into our lab, present, give demos, and go. I explored that area. I said, let me try into that. What is this application scientist about? I got a position into a very well-known plasticware brand company. And you know what stuck? Again, the dilemma. And you know, with that offer, what I did? I didn't join and just continued with the lab. And I thought again about the plan A and started giving interviews in academia. Again, I got a job in a reputed private university. But again, when I was about to join, the same thing stuck me. And you all know that was dilemma. Right? So again, I didn't join that. So that happened around end of 2009. Again, in 2010, my project was about to end. And you know, literally when project was about to end, I was forced to have something like, I need something to do now because, you know, next 4 months and the project is going about to end. And now it was not dilemma, it was chaos, it was confusion. I had too many options, but actually nothing in my hand. There were, I thought of applying to the government jobs, then I said, by when I would get one. I thought of industry, I thought of academia, I thought of everything at that point of time. But the deadline was 4 months. This time, one of the skill which I would say acquired during my PhD and postdoc, that is networking, helped me a lot. I started calling my friends. I started calling various people who used to visit our labs to tell us about the products and started to find about the position. Luckily, I found an open position of application scientist at Sigma Aldrich. And you know, I went through 4 rounds of interviews. And again, when I received the offer, I was stuck by the same word, dilemma, right? Research or industry. And you know, that was the point when I remembered one of my favorite books, The Road Not Taken. 2 was diverse in a wood, and I took the one less traveled by. And that has made all the difference. There were a lot of contradictions which I heard from my peers, from my colleagues, from my scientists. You know, to an extent, Dr. Mukherjee called Merck's, the person to whom I was supposed to report, and asked him, tell me exactly what is Pankaj going to do? Isn't he leaving science? So it went to that level. And, you know, everybody told me, remember, Pankaj, I know you are going into that road. There are no U-turns. Industry is not easy where you can work on. What about traveling? You have to continuously travel. For you, I know, for a person like you, it will be very difficult to survive. And you know what? You have to go to lab and sell the things. I said, wow. You know, but I was determined. But by that time, I has done my all analytics, and I know I have nothing in hand, and this is the best possible option I could look through. And there is no much time which will need me to settle over there. And I was very sure about my skill sets, my capabilities. And I said, let me try. Who wants a U-turn in life? Let me drive myself within this area. I went ahead and joined. And my journey started. But before going further, let me conclude that options part. A option we all know. But what are my B, C, D options? Let us start with business development. Nowadays, companies like Merck or other life sciences companies, they take masters or PhD students as their business development manager. Marketing, product manager. My team has more than 20 product managers who are PhDs and taking care of product line across the country. Technical sales. Merck has more than 45 technical sales who are giving or doing the consultative sales to the scientists around them. Basically, they are helping science and helping them scientists to solve the toughest problem in life sciences. Technical support. We have a good team in Bangalore. We have got shared business services. Where are the technical experts who support various scientists across Europe and in India for their technical problems? Content writing. This is coming up new. We have a content curation team in shared business services who work towards curating content for the products. You know, you would see a lot of antibodies on our website, and when you look at the content, who curated it? People like you have curated it. Today, I'm looking out for some of the good content writers because I'm thinking about how can I take science to the masses. That is one of the open positions I have. Project management. Nowadays, we run a lot of projects. And you need a right scientific temperament to run those projects. R&D scientists, which is already open. Merck has 2 labs here in India. One is in Bangalore, which is a innovation lab, and one is in Chandigarh within IMTech. It's called Merck High-End Skill Development Center. We have close to around 4 scientists within those labs who are doing skill development and supporting people with various experimentation. Intellectual property and patent law, this has come really new and it's working out well. Another area which is very futuristic, I'll tell you why this futuristic word matters a lot, is data science and big data analytics. Anyone who has a good scientific knowledge and gets experience or learns these data science and big data analytics, I can tell you, you have got a good career option and good career growth. Scientific journalism, you could see now a lot of, including Bar Spectrum or other Hindu or other, even ET now, they all have those scientific columns and they are looking out for scientific journalists. Entrepreneurship, Dr. Tasleem talked a lot about it, you know, the life sciences startup. This is again coming out very big in the country, and you will see a lot of incubation centers who are incubating them. Market analyst, content developer, patent professional, or even medical writing. These all are part of a consulting. There are people I know who are working for different university, and on the side, they are starting work as a consultant for these kind of works. This is, we're called as BCD plans, but you know, these are the as good as A plans and could be very good ladder for the specific person's career. After these all things, you know, this is how I look. You know, so I did my bachelor's in science from Gurwal University, moving on to master's, PhD, and postdoc. You know, the learning curve doesn't stop here. Like I started my talk and I was talking about agility again and again. That continues. My learning curve still continues. Currently, I'm pursuing my MBA from IIT Bombay and Washington University. Right, so maybe I did my PhD. So you know, because of pandemic, this MBA has gotten into a PhD mode, and I think I'm going to finish it by only 2022. From career path point of view, I started as a research associate, moved on to technical sales, moved on to the regional sales manager, and you know, this was a crucial shift. When you look from a PhD point of view, people look you from a technical expert point of view. But you know, learning during work, and I'll talk about that, how I learned from my experiences, what was my learning. I was learning from what people are doing, and people could see, you know, this person can even bring a difference onto sales. And I was positioned into sales for a couple of years. After that, I moved to marketing. I used to look after marketing for only biology product till last August 2020. But recently, from September 2020, I moved to the director position, and I now head commercial marketing for Merck's Research Solution business. Right? This was about me. And now, what did I learn and how I came to this level? You know, one thing I would say to everyone is learn from PhD experience. A PhD is itself the biggest taskmaster. And when you reflect back from functional or technical knowledge, it leaves you with multiple interpersonal skill sets. You know, no doubt, when you talk about the functional and technical skill sets, you are PhD, you have those. And when I take interviews, I take it granted. Right? Where I look people is onto the interpersonal skill set side. You know, like when we talked about ideation, like what Dr. Taslim talked about in detail. In general, when you look at ideation, is like we think about how it works from idea from a brain, process, and motor response. We execute and we succeed. It doesn't work that way in a normal life. Ideation happens in a brain. At the start comes the confusion. There is panic, there is fear, there is insecurity, there is no motivation because it's kind of a self motivation coming in. There is a lot of hesitation, there is a lot of procrastination coming in, and then finally process execution happens, and then you succeed. This is how the things happen in a real life. These are when you look onto the right side of my screen, you will see these are some of the key skill set that I gained during my PhD experience. I'll not talk about each of them, but I already highlighted agility, which is very critical for me. But you could note it down and see how you can imbibe these skill set. I have got an easier way to imbibe that. I'll tell you in the conclusion of my slide. But one thing I believe that matters a lot is attitude. And this is me. This is one of my caricature drawn by my teammate for me. And attitude matters a lot. And this is one area where again that person is again PhD and very deeper into these kind of things. With this again, I got a time to reflect back onto my journey. Taking lead. If suppose one of your PI says something, take lead. Say, yeah, I can do it. Raise your hands. That's important. Because it will make you learn many things which you were not able to do. Helping others with the stuff. Keep on guiding people. Doesn't matter within your domain or outside your domain. During my PhD days, apart from science, I was known for a person who can repair people's computer. And that was way back in 2005. You could see how critical it was. But that helped me to do a lot of networking. Serving society. I was a part of you'd be knowing the Rotary Club. The younger branch of that Rotary Club is the Rotaract Club. And in my younger age, I used to go to villages for working with the polio mission, for supporting people from earthquakes and those all. And that helped me to build that confidence and talk to various people on relevant topics. Right? Apart from this, one area which Dr. Taslim talked about is idea, which is very critical. And ideation is very, very important. And the outcome of ideation is what Dr. Taslim featured out. I would say continue ideation and think about it. Keep your thinking hat on you always, and always be open to give and hear ideas. You never know which of your idea gets liked by someone and takes you to the next level. Right? The important thing next comes, I talked about networking. Start with me. This is my LinkedIn QR code, scan it, get connected. Increase your professional network. Look out for mentors. Learning from others who have followed similar path is one area. Understanding the context of a field different from yours. Connections to potential employers. And they can help. Today also, when you work around my LinkedIn, I get several notices and I look for the skill sets what people have. And that works well for several and even for me, because I get a chance to interact with talents. When I'm mentoring somebody, I take learning is not one way, but it's both ways. I give and I take. Right? An important message from me. Be futuristic. The skills which are today may not be relevant tomorrow. Fear of automation. Many skills are going to get automated. AI and machine learning are there. Look at around. How many people you use still the keyboard phones? How many people still watch movies on VCR? These are the things when you look at judgment and decision making, critical thinking, these have got low risk of automation. Look at how you can acquire these skills which have got a low risk of automation. And maybe, over the period of time where there is a high risk of automation, you will have machines working with, or all things will be automated. One point from a Merck point of view. we are looking for RPA side where we receive orders from the customer and that people can read those orders or machines can automatically read those orders. So the automation is coming very heavily and we are taking it up. Another thing, apart from that side, it matters what kind of a mindset you have. What I perceive and what I see and have interacted with the people, I've seen two kind of a mindset. A fixed mindset and a growth mindset. And when you speak to people, you can easily identify, okay, this is kind of a growth mindset and this person is going to take a bigger leap in his career. And you talk to somebody, you said, yeah, it's a fixed mindset, things are not going to work out even after 1 year. And fixed mindset is easier thing to do. I can easily avoid challenges. But on the other side, when I'm on the growth mindset, I will embrace those challenges. Let me see what I can do. I'll always go up with the solution. I'll not go to my PI or to my manager saying that, I'm facing so-and-so challenges. I will go and say that, I'm facing these challenges, but I see these 3 solutions coming up. Right? You look towards ignoring feedbacks and critics. Intelligence and talents are fixed, but when you look at the same side, there is a lot of positivity around. Look at those sides, how you can move towards that growth mindset type. Right, a last slide. Point was that how you imbibe them. I would say build them as a hobbies and build them as your skill set. I'll give you an example of a game that kids play. It's called as a Twister. And adults also find it quite interesting, the Twister. It works on their flexibility. And while the game may seem like following people's instruction and having fun, it does not require a certain amount. It does require a certain amount of negotiation and teamwork. To keep you following and to complete the task, it also helps you to be more comfortable with being in a close personal space with others without closing off. So think about what are hobbies that you develop, that you gain and learn these all skill sets. Right? This is all from my side. Thank you and all the best to everyone. Thank you.
Thank you, Dr. Pankaj, for bringing out your own story and building it up, and to say what are the things which are required for a post-PhD, and there are opportunities for the people to look into a less traveled area. That is absolutely right. I think there is a lot of area where people do not go, but there are certain attributes which are required for such a person. What do you think are the attributes for a person who is a scientist to have this marketing ability and then join that area and go into the marketing area?
Yeah, so a very nice question, I would say. So whenever I interview and from my product manager's position, I'm open for freshers. So when people come for interview and they are fresher, what I look at, first thing I talked about in my slides also, I look at what kind of attitude and a mindset the person has, because I believe, he's coming with that mindset, but can I train him? Has he got that right agility in place? How quick learner he is? Is he putting his thought process in place and coming up with right execution plans or talking about those? The point I identify these things doesn't matter what is the experience level. Trust me, I go ahead with that person.
The other point you clearly demonstrated was learning. Yeah. And I have a personal question. I'm interested in content writing, but I'm a retired scientist. Can I still apply?
Please do send an email to me. I'm interested. Very difficult to get a value out. And, I'm inclined towards taking sciences to people. That's the reason work has come out with these 2 labs and this kind of approach. I would say, let's do something.
Yeah,
I think as long as Raju's brain is working, there should not be any problem.
No, content, the Americans say content writing is very critical. Yeah.
Exactly.
So, translate into black and white.
Pankaj, I have a question, quick question. Do you still miss science, or you say that you are still in science?
I am still in science, with this setting up 2 labs, I had those labs also. And currently I'm working on some of the serology experiments in my lab. So I do visit lab, see people working onto the benches, guide them onto that part. So I am still in touch with science and working continuously towards that.
So Pankaj, I have a question. Thank you for taking our invite.
Thank you.
I know there are young Merck Scientist Award and all you are giving, like I mean to say, but
Yes.
the denomination that has been given is relatively less, I mean to say. But can you just tell me, like, does Merck even support like smaller laboratories and all with respect to grants or some fundings and all? If somebody comes out with a plan out there,
Sure.
it may not be of a direct interest to Merck. It's like designing up molecules and all. But are there any support programs at Sigma at least towards Merck?
True. Thanks, Dr. Bhupesh, for the invite. And you asked a very relevant question. So when you look at from a funding perspective, first thing, with government approving CSR as the possibility, yes, we are looking, we just invited some of the application from various institutes saying that, okay, we are looking towards funding with CSR and we are evaluating those. Second, we come up regularly with the grants, like around a year back, we had a Merck 350 years grant where we requested public grants in various research areas. And many people submitted from India into that. There are another accelerator programs from Merck, like Dr. Taslim was talking about startups. 2 startups from Bangalore got selected for that. They were incubated in the Merck Accelerator Center in Germany, and they got a good funding to support them. Another thing we regularly, one is the Merck Young Scientist, which you talked about. We launch it alternate years. It was in 2019, and we are launching it now. Denomination, thanks for the feedback. Do let me let me know what you think is the right denomination and let me work towards that, because we identified 11 winners and all got a good amount, but still if that's low, I'm ready to look on that part. And third part is that we keep on coming with the Badger Award, like somebody is doing work in a chemistry, they can submit that to that, and we keep on giving those awards. We keep on doing some of the awards onto neurosciences also. Like last time, we requested everybody to submit onto that part, and some students got that grant to travel or those kind of things. So we regularly do that kind of things.
Thank you.
I have a question. I have just one question. Like, this is for the benefit of the younger generation or upcoming research scientists. Like, how do Merck will encourage applications from a fresh PhDs within India? Or is there any scientist positions wherein they can also explore in your kind of organization?
Yes, I would say I have, like I told about the Merck, these Merck Innovation Labs. We have positions. If there are someone, please do apply.
All the time, or is it like, one has to approach whenever there is an advertisement?
Whenever there is advertisement, one thing is that if I get some kind of a specific email ID from this group, I can push all my advertisements over there. Recently, still I have an open position. We are looking for a head of biology, but that person would be guiding around 6 PhD people who are the product managers. That position is open. I'm looking for content writers. I'm looking for some kind of a web or data analytics. And these are the 3 open positions which I have. We keep on having a position onto the technical sales aspect. So if there is some common group, I can push those open positions over there.
There are some people like, they are trained only in the kind of academic kind of research, very detailed analysis and all. So, but they may not know how the industry's requirement is. Such people, when they want to change their field into industry, how do you, for example, it is not just the fresh ones. Even there are some people who would have worked as a SRA, they're hoping that they'll get into fixed position, then they realize that it doesn't happen. So by that time, they're also become very senior research scientists. Such people do also you give any support.
Yes. Recently, the lab scientist I've hired, she is quite a senior person. And, like I told, I look at the person agility and I would say inclination towards learning. When I got into Merck, I was quite a fresher. Recently, one of my product managers, she did her PhD from Max Planck, and we just hired her quite a fresh from there. And now she's one of the best product managers in Dubai. So just need the attitude of that person, and rest. It's my work, it's my duty to train people.
I also thought that was one of the take-home messages of your talk. A PhD has transformative skills embedded.
Yes. And the other important thing which you raised was the automation which is happening and taking away many jobs, and one need to find the new skills, which are extremely important. People cannot be rigid and cannot be living in their own direction. I think they need to acquire new skills, which are extremely important. Very important message. Thank you, sir.
Thanks a lot for the opportunity. Thank you.
Sunil, ready?
Yeah.
Yeah. Hi, Sunil.
Hi, sir. How are you?
Yeah, I'm privileged, rather I'm proud to introduce the next speaker, Sunil. And Sunil was my student, MPhil student, and he has done exceedingly well in his career. He is currently the UK head of pricing for Bristol Myers, managing their immunology and cardiovascular portfolio. It's pharmaceuticals, not their cigarettes. Prior to this, he was the global head of pricing and analytics at the Takeda Pharmaceuticals Oncology Unit, where he was managing the pricing strategy, approvals, and analytics for the entire oncology portfolio. After his PhD from Neurophysiology department, Sunil did his PhD in clinical neuroscience from Cambridge University, where he received the Commonwealth Fellowship. To do the PhD, he was part of James Fawcett's group at the MRC Cambridge Center for Brain Repair for his postdoctoral position, and he worked on axon regeneration. And it's a pleasure to welcome Sunil to give this talk. And I must also say he gave peace of mind to our entire family by finding a home for a cat rescued by my daughter. So she was very stressed about that. And thank you so much for that too. Sunil.
Thank you very much, sir. So thanks a lot for the introduction and for the invitation. So I think the topic for today is leveraging research training on whatever we learned during the MPhil and PhD days, and how do we take that forward into different avenues. I think, as sir very kindly introduced me, I'm currently at BMS leading their immunology and cardiovascular portfolio. But I think for the more important intro at this stage for me would be that I was a student of Nimhans, and I was a student of Professor Raju. So I think I'll start off with that as a level setting place. Now, before I start off, at the end of this talk or this discussion, there are 5 key things that I hope that I'm able to convey in this presentation. The first one is when we start off with something, there needs to be a vision of what that endpoint would look like. I'm not saying that by vision you mean what would your what would your life look like when you're 50 or 60 years old, but more importantly, if you're setting a career goal, then what would that ideal career goal look like? And the reason for that is, once we start with that endpoint in mind, we start to form a path towards that. And if we don't do that, it can become very chaotic and too many options / dilemma, etc., which is what I think Pankaj was alluding to in the previous talk as well. Now, to get to the end point, one thing we all have to accept is that there is no set process to get where you want to. There will be always a case of probability. There will be a case of success factors and what is practical from our point of view. But what would really help in each of these parts is networking. So yeah, I mean, I couldn't emphasize this enough. We need to get out of our labs and speak to people. There are different perspectives in different fields, and if there is a desire to go into a particular field, then we start networking with those people. The fourth one is never stop asking questions, and the fifth one is never stop trying. Both, I think these are the 5 key points which I wanted to highlight. And if nothing else, if we can remember these 5 points, I think that should be, that's probably hopefully job done for today's session. Now, I designed this talk from the perspective of a MPhil/PhD student who is considering different options and is not clear how to get there, what are the options available and how to get there. So there is a lot of overlap, I think, with some of these previous speakers, but hopefully I'll lay out a practical path towards that. And when I started off with research, I was very keen on research, to be honest, in neuroscience. It was my passion. It's still my passion. I still have Kindle book, which I always open and read once in a while because I just enjoy reading that book. But when I started off, my understanding of career options for a researcher was that it's a very streamlined process. You start off with your MPhil or PhD, or MPhil and PhD. And then you go on to do your postdoc research at a reputed lab, spend about 5 to 7 years, try to establish yourself within the field, and then use that to, and publish lots of papers in the process, hopefully in high impact practical journals. And then hopefully that will open up a few options in terms of getting tenured or permanent academic positions. So that was my understanding when I joined NIMHANS essentially. And I was pretty much looking forward to it. But then very quickly I realized, well, when I got to Cambridge, actually that there is a lot more that you can do than just research. And ultimately it then boils down to what kind of personality are you? And really that, and do you see yourself as a person who would be able to do research focus on a single molecule or a single mechanism for the rest of your life, which is what usually would happen. And it's a perfectly viable option and enjoyable option. Or are you the kind of person who likes to do different things and likes things a bit more fast-paced, or are a bit more adventurous? Now, what I've laid out here is that there are a lot of different career options which are bucketed into 4 broad categories. So what you would see here in the yellow boxes here is all about scientific publications. So either in science journalism, scientific publishing, medical communication, etc. And then there is a whole field around grant management, the conversion of ideas into entrepreneurship, which is what Taslim was referring to, I think. But that's where the technology transfer officers come into play. And then there is a whole field around public policy, shaping the public policy, either around scientific research or in terms of public health or in terms of specific disease area processes, etc. Now, in addition to this, there is also the research work, that actual research work that you can do. These are, as opposed to being in the academic side, we can also carry out research in the industry side, either with clinical research organizations or with pharmaceutical companies in their R&D and medical divisions. Now, outside of these 3, and something which we are not usually well aware of, at least I wasn't well aware of, are these 4th buckets of options, which is going into the very commercial side of the world, which we don't normally consider. The area around, working with financial institutions like banks and hedge funds, working with venture capital funds, starting your own startup, working as a strategy consultant, working in intellectual property law, working on the commercial side of pharmaceutical companies. So there's a whole world out there. And to be honest, as Pankaj was mentioning some time back, it really doesn't matter what your background is. It really doesn't. I have colleagues who have done PhD in medieval philosophy, and they are advising pharmaceutical companies now on growth strategies. So if such an unrelated field can lead to opportunities like this, then there is no reason why our training as MPhil or PhD students can't lead to a position like this. So I think that the key take-home message from this is that there's a whole world out there, and in the next few minutes, I hope to convey my learnings from 3 specific areas: startups, strategy consulting, and working with pharma companies. And it's I think the big caveat that I want to put in is that whatever I show or whatever I talk about, it's the opinion of n equal to 1. So please take it as it stands. Each person has their own opinion, but I'm quite happy to share mine, and then it's for others to take it into, because the circumstances can vary, and we react and behave differently to different circumstances. Right. So that's so having laid that out, so I'll just quickly walk you through my journey, which started off in the context of our discussion at NIMHANS. And then I would hope that during this journey, I would want to highlight some of the lessons that I learned. And the lessons learned are always in retrospect. When you actually do these things, are actually actions. Now, beyond that, I also hope to provide some practical insights into what the recruitment process looks like, get into that mindset of an interviewer or a recruiter who is looking for somebody to fill a position. So what does that actually look like, and therefore how do you need to prepare towards that? And then go into why us. I mean, it's such a different world, as I said here. This is such a different world. So why would they be looking at somebody like us, and what skill sets that we should be highlighting, or which is more valuable to them? So talk a bit about that, and then circle back to what next. What can you do as immediate next steps? So that's the overall plan for the next few minutes. And yeah, so let me start off with the first one. So a quick overview of my background. This has been my life journey, so to speak. I did my undergrad and MSc at Bangalore University. My schooling was at Sainik School, Korakonda in Andhra Pradesh. It was, though many people don't actually highlight schooling, for me, it was a life-defining moment to this day, and that's why I always put it there. But in the context of our discussion, my research career started at NIMHANS as an MPhil student in 2003 in the neurophysiology department. And then I went on to do my PhD in clinical neurosciences, working in spinal cord injuries at Cambridge. And during that time, I kind of started questioning myself, or introspecting, as to, is research really my long-term career? And very quickly, the answer was no for me. But I enjoyed elements of it, but not all of it as a lifestyle, as a permanent lifestyle. so I tried to do something different and took a risk and started a startup called as TKB and Associates in the hospitality industry. Nothing to do with research, nothing to do with science. It was just something different that I wanted to try. And that led to a career in strategy consulting for about 6-7 years, focusing on the pharmaceutical sciences or pharmaceutical industry. And from there on, more recently, I've now moved into the leadership positions in pharma industry, first at Takeda Oncology, and now at Bristol Myers Squibb as their UK head of pricing. So that's the overview of my background. Just to add a bit more flavor to it, at each of these organizations, I learned a lot. Now, would I say that I learned when I was there? I probably did. But I think what really helped me was there was something to take away from each of these. For me, NIMHANS opened the door to neuroscience. I was extremely passionate about neuroscience. And those 2 years at NIMHANS really gave me an insight into it. I also had the very good fortune of working with Professor Raju's group in ALS and learned a lot of different things over there, ultimately resulting in my dissertation focusing on motor neuron disease and the effect of cerebrospinal fluid on or trying to establish a cellular model of motor neuron disease using cerebrospinal fluid. Now, it was a very preliminary study, but it served as a proof of concept. And I believe that the work on the motor neuron cell lines is still ongoing at neurophysiology department. Now, from there, there was an opportunity to go to Cambridge at MRC Center for Brain Repair, where on the scientific side, I worked on gangliocytes and their role in spinal cord injuries. But I think, so this is on the scientific side in terms of my academic world. But what do I do now? So just a brief idea about what do I do now before I go into how did I make that transition. Now, in the first half of my career, I was a strategy consultant. And what does that mean? It means that you are working on three key focus areas in terms of corporate strategy, financial strategy, or general market entry strategy. So you would be very much working with the CEOs or the division heads of Fortune 500 companies and try to understand, try to answer some of the questions which they might be having. For example, they might come to you and say, hey, is my company in the right direction? What am I doing right and what am I doing wrong? Am I future-proof for the next 5 years? And if I'm not, then what are the corrective measures that we can take? Or it can be more tangible questions like, I have a goal of saving $350 million over the next year. Tell me, how can I do it? Or I have a goal of increasing my profit, which are going down right now. Tell me, what should I do? Or it can be more general market entry strategy. For example, I have a product and different countries have different requirements and I need to enter the markets in slightly different way, but I don't know how to do that. So give me a market entry strategy for taking my product, in this case, a medical product, to different countries. Now, most of my life, I've been focusing on, most of my life is probably an overstatement at this stage, but the past 6-7 years, I've been focusing mostly on the bucket A, corporate strategy, and the bucket C, which is market entry strategy, which is, we have a medical product which has just finished clinical trials. It's likely to get a regulatory approval, but we need to make it accessible to patients and at the right price. But at the same time, achieve that and try to achieve that balance between making it accessible, and also being recognized for its value in terms of the investments which the companies have made. It's a very difficult balance, especially when it comes to health. And when you are talking of countries where nearly 3/4 of, actually I would say 4/5 of the population has a very difficult payment model for paying for health. So how do you achieve that balance? And that's been my focus area for the last few years now. So I think one question which I'm assuming most of the people or the audience in this call have in their mind, at least the MPhil or PhD student, is how do you make the transition? How do you go from one day working in neuroscience, NSC34 cells, motor neuron cell lines, or working on spinal cord injury on gangliosides, doing your research work, to next day working with the CEOs of big pharmaceutical companies or redesigning their entire organization to future-proof it, to developing pricing strategy globally for different products, and making sure that you're playing a role in the healthcare policy of different countries, or the government policy of different countries. So what does that look like, the transition process? Now, it sounds big at its face value, but honestly, it isn't difficult. So it's hard work, but it's not difficult. And for me, now that I look back at it, there are a few guiding principles that I've always had. I think one advantage of a talk like this is that it forces you to reflect. And in the process of that reflection, I realized that throughout my student life and most of my adult life, I had a couple of guiding principles. The first one was, if I try, I may fail. But if I don't try, I will definitely fail. So there is no harm in trying. And the maximum that you would have is one failure. That's okay with me. I can live with that failure. And the second one was, as I said, it's not difficult, but it's hard work. And one of my friends, who is currently a professor in Ohio State, he and me come with very similar background, and he had this thing which I kind of adopted, which was deserve what you desire. So if you want to go towards consulting, if you want to go towards pharmaceutical industry, or if you want to start your own company, there has to be effort going behind it, and you need to be smart about it, but there has to be an effort going behind it. So these have been my guiding principles. That's what I realized. But how does that translate into practical actions? So for me, it was a couple of things. One, you try different things, something which will make you stand out. Sorry about the noise in the background if you're hearing anything. It's still early in the morning here, so there might be some disturbances here. You have to try different things, something that is uniquely different. And that really helps in terms of getting or broadening your exposure. And the second thing is talk to people. This is what I think Pankaj was highlighting. This is what Mr. Gopalakrishnan was highlighting. This is what even Taslim was highlighting in his talk. If you don't network, if you don't try, it's not going to work out. So that's the simple take-home message. If you don't take away anything else from this discussion, these are hopefully the 2 points that would be really helpful for you to take away. Now, so these are, I would acknowledge the fact that these are very high-level things and very generalist in terms of discussion points. But practically, what was it? So for me, it was. So I think a few practical things that helped me. I can highlight that, And hopefully that will also give some direction or some ideas about what we can do or what the others can do in their own life. Now, for me at NIMHANS, it was, I had good opportunities over there, to be honest. I mean, there were a lot of avenues available within the departmental activities like journal clubs, which focus you to think critically on different topics. Now, it doesn't feel like a lot, and especially when you're doing your MPhil research, when your PhD research, when you're bogged down in your day-to-day experiments, journal club feels like a waste of time. I did at that time at least. But I'll tell you what, it forces you to think critically. It forces you to think, ask the questions why, what, how. You can't do that. It's really, really important to keep on asking those questions. And if you don't know the answers, ask people who have done it. So an anecdotal example here. When I was giving my first journal club, it was a paper from Nature Neuroscience. And that was in my first journal club in NIMHANS. And I was not very sure about some of the aspects of experimental design and some of the conclusions that the authors were making. And these authors were from, I think, Calgary University in Canada at that time. I reached out to them. And I didn't know that I was doing something different. I reached out to them because I had those questions. And in the actual journal club discussion, when I was presenting my analysis of the paper, I highlighted the fact that I was not very clear why the authors were using this methodology or if it's the most accurate one in terms of the conclusion, etc. And therefore I reached out. Professor Raju, he actually was surprised that I actually reached out to the authors. And I was actually, for me, I was surprised that he was surprised about it. I thought that that's the normal thing to do. If you don't know, you ask. And that's when I realized that, now I realized that there are lots of people who at a certain level and don't ask further. The key here, the lesson being learned here is that we need to keep on asking those questions. And if you don't know, then you just keep digging. The other bit which I got really involved in was these non-research opportunities. Now, luckily for me, in 2004, 2005, we were hosting APICON, which is one of the biggest conferences in India. And it was being organized by for neurophysiology department. And luckily, I was responsible for the entire logistics operations of that conference, which feels like you're doing a lot of mundane activities. But to be honest, I actually quite enjoyed it. But in the process of organizing that, I very quickly realized that it's an amazing opportunity to network. It's an amazing opportunity to increase your visibility. And it's also an amazing opportunity to prioritize a very high pressure activities which you're not normally doing. And these are the things which are quite useful even in non-academic life, in the real world. Well, real world is probably a misnomer, but in other parts of the of career. Now, so those are some of the things I did at NIMHANS which really helped me. Practically speaking, in Cambridge, Cambridge opened a lot of doors. It has a lot of societies or clubs and a lot of avenues. You can just continue working with various organizations from there. So it was actually, it's called as a Cambridge bubble, but it also opens up the world for you. And I got involved into everything. And I don't know why. I was just interested because it was there for me to grab. So I got involved into it. So I got involved with business school, doing a certificate in business enterprise. I did a certificate in corporate finance over there, not because I want to do something, just because I thought it would be something different from working on gangliosides. The same thing in terms of business activities. I was working with the local tech entrepreneurs and the students to create a platform over there. And it ended up with us also linking up with Google, and the VP of Google actually being one of the key of the plenary or speakers at that particular event. I wrote a few chapters on entrepreneurship for a book. I've got involved in a lot of consulting projects, very similar to what C Camp essentially does, in terms of, you have an idea, you probably have a practical, implementable idea which can have impact in the real world. The question is, how do we take it to that real world? So I got involved in those kind of projects and initiatives to understand how do you translate basic research to real world impact. And then in addition to that, there were avenues for table tennis, cricket, rowing, etc. Now the reason I'm mentioning this is these are practical things that I did, but then it had benefits. And the benefits were, as I said earlier, it helped me in networking with people. It helped me in understanding different perspectives and different values, and it broadened the horizon for me. And it's a very critical soft skill to have when you're going into non-academic career, because in non-academic world, it's all about people-to-people relationships. I think even in academic world, it's people-to-people relationships. And for you to speak to other people, it's important to understand what their priorities are, what are they interested in, and these activities help you develop those. So these are some of the things that I wanted to highlight here. Okay, so I'll not repeat this, but one thing which I wanted to say is, during this entire process, and even now, to be honest, it's the most important thing that I've learned is to introspect, and introspect honestly, because we can very easily fool ourselves and say, this will work, this will not work, etc. But I think it's important to introspect whether or not you're doing the right thing or where you're lacking. And if you're lacking somewhere, what are the corrective steps you can take? If we don't even recognize that we are lacking in some steps or some aspects, then we can't even take those correct steps. So for me, that was the most important learning, thinking about it in retrospect now. But I always try to introspect, and I'm happy to admit that I do not. There are a lot of gaps in what even today when I'm trying to learn, and I try to identify those people and try to learn from them. Right. So this is all about my journey, as I was talking about some of the practical steps that I took and some of the key learnings from those practical steps. So the next question is, what does that recruitment process look like? If I am a MPhil or PhD student today, what would that path look like for me? What's my step one? So just a quick insight into the recruitment process. It's usually in the industry, be it in financial organizations or in consulting world or in pharmaceutical companies, there are, I would say, 3 to 4 different steps. One is your CV shortlisting. Believe me, it's one of the toughest things to get through. Usually, each CV gets, when I review a CV, I spend probably 30 to 45 seconds on one CV. If I'm able to, if that CV grabs my attention in 35 to 40 seconds, then we spend more time on it. If it doesn't grasp the attention within that time, then it's rejected. So what are the key things that we can do over there? The key thing here is your CV. So I try to keep my CV this is, by the way, these are screenshots of my very old CV, but I just wanted to put in here. It needs to be crisp and it needs to be relevant to the role. And what we try to do typically in the CV is we mention a lot about what exactly you have done. So I've done my MPhil in neurophysiology. I worked in NSA 34 cell lines being used as a cellular model along with glial monolayer, etc. So those are things that I have done. The question you need to, or the things that you need to actually highlight in the CV is what was the impact of doing that? They are not interested in your activities or your job description. They're interested in the impact of your activities. And if you can highlight that bit, then you stand out. And more importantly, highlight anything that was different, which was not usually expected out of you. So I had the opportunity, for example, in NIMHANS to organize this Epicon or be a part of this organizing committee for Epicon. And that's not part of my day job as an MPhil student in neurophysiology. So I made sure that I highlighted that. And that stood out in discussions further down. Now, these obviously vary based on the situations, but hopefully each one of us has some or the other options that are available or we can make or we can create to highlight some of these different kind of activities. Now, along with the CV shortlisting, there are usually a lot of online tests which either look at your aptitude or at your numeracy skills. And these are just a matter of practice. And anybody who's doing an MPhil or PhD, I'm pretty sure they can clear it, but it still needs practice because more often than not, you're not allowed to use a calculator. So it will test you for accuracy and for time. So these two things are just practice. And then once you clear through that, you have usually interviews, which can be multiple rounds, 3, 4, 5 rounds, depending on the company, but they usually fall into two broad buckets. One is the personal interview, and the other one is what we call as the business situation interview or the case interview. The personal interview is, I think as an interviewer, what I'm really looking for over there is, would I want you in my team? And in a business situation interview, there are two questions that I'm trying to answer. One is, would I want to put you in front of the CEO of a FTSE 500 company? And the second question is, do you have it in you to lead a large division which might have conflicting priorities, either within the division itself or with the other divisions? So these are some of the skill sets that you're looking for. So I mean, personal interview, the questions that you're usually looking around are, as an interviewer, what I'm looking for is, are you a team player? How structured is your thinking? Are you able to react to extreme stress? And can you think out of box? And in terms of a business interview, again, very similar questions, but in the business context over there, as opposed to your soft skill context. But for the common theme over here is, it's very important to organize your thoughts before you answer. Leverage your scientific thinking, which we all get trained on in terms of approaching a problem. And more importantly, and this is the fortunately or unfortunately, your entire career depends on you doing well in that 1 hour of interview time. And therefore, it's critical to just practice. There is no substitute for that. So you might have the skills, but if you don't do it on the day, then you lose the opportunity. And the only way to do it well on that day is to practice. So that's what the selection process looks like. So if anybody reaches out to me afterwards, then I can provide more details around it. I often provide coaching to people at various stages of their career in terms of when they have an interview or when they're trying to make a transition. So I'm quite happy to provide that one-on-one contact with anybody who wants that. But I think the key question here is, we are by essence all researchers. MPhil, PhD students, postdocs, we are all researchers. Why would an industry or a company, a financial organization, or a strategy consulting firm be interested in somebody like us as opposed to somebody who has done an MBA or who has done something in IT? What we tend to acknowledge, undervalue is there are a lot of different categories of skills that's required, and there's a lot that we get from research for those skills. So what I've highlighted here is 4 broad categories: problem solving, communication, dealing with stress, and personality. And the ones in the green on the right are the ones which we are trained for many years during the course of our research. And there are some where we are in amber, like for example, around communication skills and around, working with limited information or ambiguity. But those are the kind of skills which can be trained. But the most important thing, as Abhilash was highlighting in the previous talk, was we need to be coachable. I don't care whether or not you know anything about the field. It's my responsibility as the head of the department to make sure that you know that field. But there should be a willingness and plasticity from your side to be coachable. If that's not there, then everything else just falls apart. So these are some of the skills that I wanted to highlight in terms of what we are looking for and what we bring to the table. Okay, so finally, what next? So I'll go back to the 5 things that I started off with in the beginning. And if nothing else, in terms of your next steps, if we can think of what that vision, or let's say that in 5 years timeline from today, what good looks like for you. If we can start thinking about that today and say that, okay, this is where I want to be, it should hopefully start charting out a practical path for you. And it will also, once you know that this is the path that you're trying to lay out, the question then is, how do you do it? And for me, that's about network. And one practical way of doing that is LinkedIn. Facebook is more for social interactions, but LinkedIn is the professional networking. And believe me, there's a world of opportunity out there in these platforms. And the key thing is just keep asking questions. If you don't know how to reach out, how to find an opportunity. For example, the CCamp talk that was being done earlier, I found it quite interesting, but not many people still know about it. And that's probably half of the problem, is probably because CCamp hasn't been able to broaden its reach yet and awareness, which it's trying to do, obviously. But India is a vast country and there are a lot of institutions. But the other half is we need to look out. There are opportunities. So Google and see what funding opportunities are available out there. And CCamp, I'm sure, would come up in one of those front page results. And then you start digging around that. So never stop asking questions and just, keep trying. So I think those so these are the 5 things, I think, in terms of the immediate next steps that hopefully we all take away from this today. And hopefully it has helped everybody in terms of what needs to be done next. Now, before I end, a couple of things. One, I just absolutely want to, I'm really thankful for the different organizations and the people I met there and with whom I have interacted substantially. With Professor Raju, who was my mentor and guide during NIMHANS days, the staff of neurophysiology, and a couple of other people over there, late Professor Tarnath Shetty sir from Neurochemistry Department, who was my mentor as well. And then at Cambridge, a couple of sub-organizations over there, QTech and Judge Business School, and my supervisor over there, Professor James Fawcett. And ultimately, to be honest, it's my school, my alma mater, and my teachers and my classmates over there who have been a constant source of inspiration. So yeah, thank you very much to all of these different people. And please feel free to contact me by email or by LinkedIn. If you look up my name on LinkedIn, it should be coming out as one of the top results over there, hopefully. But one final thing, it's I think this is the departmental photo on the right side, but one of the key people who worked with me during that time was Anil. And yeah, he apparently recently passed away because of cancer. An amazing personality, one of my dear friends during that time. He used to call me Golgi. That was his nickname for me. A very jovial personality, and hopefully. Sorry?
Thank you. That name, I wanted you to repeat.
Oh, sorry. Golgi. He used to call me Golgi. Yeah. But yeah, thank you very much.
Thank you, Sunil, for bringing out your own experience. And I think a very important point you have given it to the young people who are in the field and who are on the lookout for how to get out and then find the way out. I think you have brought it out very, very nicely for the youngsters who have done their PhDs and looking forward to enter into the whole horizon outside. Very good. Thank you very much.
Thank you. Thank you.
Sunil, as your early career mentor, I'm really proud of whatever you have achieved. And you demonstrated how perseverance can pay off towards the end. And I have one question. Some of your peers who are continuing in academic career, what do they think of your achievement in a non-academic?
I don't know, to be honest. So I think my friends, both from NIMHANS and Cambridge, who have done their work, who are continuing their work in research field, I think the question is very similar to what I raised in this discussion right now, which is, how did you do that? I mean, how is it even possible? But that's a very, it feels like a very hard obstacle to cross. Actually, it isn't. It's not hard. It's just hard work. And to be honest, if you're clear in your mind that this is what I don't want to do and this is what I want to do, we tend to find a way out. And that's essentially what it is. So I haven't spent time thinking about what they think. I know that the question they ask is, how did you do it? But yeah.
I think it is your goal and what you want to achieve. And it is satisfaction what it gets you. That's all it matters. And it doesn't matter that what other person thinks. Thank you.
Thank you. Thank you.
So I thank you, the chairperson, Dr. Raju, Dr. Satish Chandra, for taking this session very, very smooth. And also to all the speakers for the inspiring talk. With this, we will conclude this session. After a short lunch break, we'll meet at 2 p.m. India time for the workshop on finding ideas to commercialize of academic research or how to turn findings into a business opportunity. Thank you all.
Bye, Sunil. Bye.
Bye, sir. Bye.
Sunil, hello from us also. Myself, Dr. Yogananda.
Hey, Yogananda. Hi. Hi, Bhupesh. Hi, Yogananda.
He was very close to us also.
Yes, of course. I used to make frequent trips to biophysics department.
So we will send you a separate email, okay? Do reply.
Yeah. Take care. Bye.
Sir,
Hello, can you hear me? I'm not able to hear you.
Oh, James going to. I'm trying to call. James, I'm trying to call you.
Yeah. Sorry, it's on silent mode. I was not able to unmute. So my phone was on silent.
So,
Sorry about the whole confusion, Lakshmi and
No
Bhupesh.
problem, no problem.
It was a big headache in the morning.
I was also a bit anxious, so that's why I was trying to plan
So-
you.
James.
Yeah.
So, how do we? I mean, can we start with
Over the phone.
Oh, can I call you?
Session is started. Take a minute off. So welcome all. From behalf of the organizers, I welcome you all to the fourth session of the symposium. This session is a workshop that would be chaired by two eminent scientists, Dr. Balaji Jayaprakash and Dr. James Clement. So Dr. Balaji Jayaprakash graduated as a PhD in chemistry from TFIR. He later went on to work as a visiting fellow at TFIR. Dr. Balaji did his postdoc under Professor Ryan at the Department of Biochemistry, Way Medical College of Cornell University. Later, he moved to the laboratory of Professor Silva in Department of Neurobiology at UCLA, Los Angeles. Currently, Dr. Balaji is heading the Neurodynamic Lab at the Indian Institute of Science, Bangalore. We are very happy to have you among us today. Our second chairperson for the workshop is Dr. James Clement. His journey as a researcher started at NCBS as a JRF. He followed it up by completing his PhD from University of Bristol, UK. He later continued to do a postdoctoral fellowship at the Scripps Research Institute, Florida. Now he is currently working as a faculty fellow at JNCSR, guiding young researchers at Clement Lab. We all extend our warm welcome to Dr. Clement and Dr. Balaji to chair the session and take the workshop forward.
Hello and good afternoon, everyone. It's been a wonderful 2 days of learning about various different experiences of people, how it is useful in the modern day context of neuroscientists. So today's session, the afternoon session, is about the new aspect of neuroscience research, right? I mean, it's not a new aspect, but it's a very, very valuable aspect of a neuroscience research. It's about finding ideas to commercialization of academic research. Right? Academic research has been happening for a long time, and we have been often asked the question of what use does neuroscience have to the public, right? So now this is directly addressing that, to some extent, addressing that question of taking that academic research to the very level of applications. And if you have to do that, who better than inviting the person whom they themselves have done this thing very well. So we have a wonderful session ahead, and I would now request James from JNCSR to introduce our workshop leader.
Thank you, Dr. Balaji. Thank you, Dr. Lakshmi and Dr. Bhupesh for organizing this. It's a pleasure to welcome Dr. Lakshmi Jagannathan, our workshop leader. She's the CEO of Derby Foundation. She's a very passionate startup ecosystem and incubation professional who firmly believes that ideas have to be nurtured faster to build businesses of tomorrow. A seasoned professional in the incubation ecosystem, her expertise is in establishing processes, metrics, and scaling up the incubation activities. Dr. Jagannathan has skill and expertise in drafting proposals for grants and support programs, and had been the principal coordinator for many funded projects from Government of India. Dr. Jagannathan has more than 3 decades of experience, including both academic and corporate experience. During her career, she has traveled extensively and has work exposure abroad and at home. She was working with Infotech Dubai, heading the quality assurance before joining Dayanda Sagar Institution. Dr. Jagannathan is currently the CEO of Derby Foundation, a not-for-profit technology business incubator hosted by the Dayanda Sagar Institution. She has been instrumental in envisioning the incubation program. She has played a pivotal role in the selection and execution of all student ideas to viable business opportunities through IEDC platform supported by Department of Science and Technology, Government of India. So not only that, she has mentored many startups which are established business units today, supporting a small number of pre-incubators and startups, both from institutes and also from entrepreneurs in Bangalore. She's instrumental in drafting and executing the IP policy for DSI. She was involved and encourages many faculty development programs on campus to build capacity and interest in entrepreneurship. She spearheads many entrepreneurship activities in association with National Entrepreneurship Network and other industry organizations. The Innovation and Entrepreneurship Development Center has grown in strength under her leadership. This center yearly engages hundreds of students through its programs, workshops, and competitions. She has many professional credentials. I request Dr. Balaji to speak a little bit about it.
It's actually my pleasure to read out the accolades of Dr. Lakshmi Jagannathan. And she has been, as James was mentioning, she has been really a role model to many business, role model and a mentor to many business startups. And to her accolades, she has been selected as a part of Women Entrepreneurship Quest program and Silicon Valley Immersion in 2019. And she has served as an expert mentor to many manager training, the manager training of the Wadhwani Foundation. And she has been in the advisory board of many technology business startups and incubators. From this, I would like Dr. Lakshmi Jagannathan to take over and lead the workshop. The workshop will have three main parts: idea validation for commercial validity, how to do a patent search, and building a sustainable model.
Thank you so much. I'm actually humbled by the introduction. Thank you so much. I think it's great to be with the NIMHANS fraternity, and we are really humbled. I fall short of words to take it forward. In fact, I had been at NIMHANS about a few months back doing a conference for, I think, women and women innovators with Dr. Lakshmi. Thank you. I would like to thank her as well for including us to be a part of this exciting program. Now, initially when we started the conversation with her, saying we wanted to do something on this, because a lot of academic researchers who do research, but very less of academic research gets commercialized to become a commercial startup venture. So that was a thought process which evolved. And then we wanted to do some sort of a hand-holding or a workshop for some people who have innovative ideas, who are researchers, how to commercialize their idea and take it forward. Then when we deliberated on this, then we came out with an idea that we could probably have three elements of the whole thought process structured in this. I would say probably 2 hours, a very short span, but at least glimpse of each of these could be put together. So that was the genesis of today's workshop. I'll just share my screen. Yeah, are you able to see my screen?
No, not yet.
No.
Yeah?
No, we're not able to see it yet.
Oh, okay. I'll share it again. Yeah.
Yeah, now we can see.
Yeah, sure. So what we did was internally, we also debated, spoke to a couple of experts, and then probably structured the workshop this way. What we wanted to do was probably next half an hour or so, I would just give an overview of, there is a framework called business model canvas. How is a business model canvas used to validate or build around your idea when you want to start a company? Then we have 2 more experts who've been invited for this workshop today on behalf of Derby Foundation. One is a patent attorney and a technology lawyer who throw light on what is IP, why IP protection is important, how it can be protected through patenting. And the last session is probably the highlight and the exciting session where you would have a real entrepreneur, a healthcare entrepreneur who has built a very good global company, an Indian startup. So this is the agenda for today. A quick, just probably a couple of minutes of what is Derby Foundation, what are we? Now, Derby Foundation is a technology business incubator. We are hosted by the Dayana Sagar Institutions, Bangalore. We are an incubator essentially supporting tech startups to help, starting from ideation, help them build their company and commercialize it, take it to market. We started in 2015. The incubator was incorporated as a Section 8 company. That's a not-for-profit. And I think last 5 years, we've grown in terms of our offerings and grown in terms of strength of what we have been trying to do. And last 2 years, specifically, we've been focusing more on healthcare. Well, essentially, any hospital, because Dayana Sagar also has a couple of hospitals in the group. So we thought that could be a very good green bed for testing, trying out, validating ideas on healthcare. These are some of the metrics indicating what is the kind of work we've been doing in terms of entrepreneurs you've supported, workshops you've done and invested and all that. So overall, we support entrepreneurs who are at a very early stage, from an ideation stage to people who are who have a proof of concept, who are ready to take it to market. Support we generally offer them is mentoring, technology support, prototyping support, access to funds, access to market, and a whole lot of things. Now, starting with the business model canvas, that is my gamut of what I'm going to talk to you today about. Any idea which has to reach the market, this is a typical journey what the idea takes through. Now, somebody starts with an idea. The idea has to be defined as to what is the idea all about. See, many of us have this idea somewhere very vaguely in our minds. What is it we want to do? But when we start defining, putting a structure around it, then a lot of things become, a lot of clarity comes in, a lot of questions also come in which needs to be answered. Once idea is defined, it has to be tested, of course, tested and validated with the customer. See, any startup, I would say the customer is a heart of or a nucleus of any startup, right? So customer validation is very important. Then based on the validation and the input from the customer, it is designed, the solution is designed. Then you can brand it, fund it, protect it through IP, then take it to market and sell it. This is the usual journey of a startup. Now, when you have an initial idea, why is the idea validation a very, very important requirement? I presume that predominantly most of the participants here are at the ideation stage. Somebody who has an early idea, maybe an outcome of your own thought process or an outcome of the research what you're currently pursuing. So when you have an idea, the idea has to be validated whether there is a potential to build a commercial entity or can you make a startup out of your idea. See, these are the typical questions which has to be answered when you're validating your idea. Is your product worthy it? Can your idea be converted to a product? How many people are there in the ecosystem who are already doing a similar thing? If they are so, what should be your unique selling proposition which will highlight so that you could outbeat your competition? Do you know whom are you going to sell? I think it's a very, very critical question. Many a times, all the more so in healthcare, you're very, very difficult to define who's your customer. Sometimes the customer may be the patient, sometimes maybe the healthcare provider, sometimes maybe the hospital. Because the supply chain, I mean, the entire, I would say, healthcare value chain is pretty long with multiple stakeholders. So defining who's your target customer you have in mind is very, very critical. So what are the capabilities? What can your product or a solution offer to the customer? Why should he buy? Who are your competitors? And most importantly, what are the regulatory issues that are associated with your product? Because building a healthcare product especially is little more complicated in terms of the regulatory as compared to most of the other technical products. Now, design thinking is again another subject by itself, but I just added this slide to bring out the point that design thinking is a non-linear process. You cannot say, I will ideate, I will build a prototype, I will test it, take it to the market. No, it is not a linear thought process, not a linear work process also. After you ideate, you build a prototype, build a solution. Once you build, you test, again there'll be a feedback, again go back, ideate what would be the solution. So throughout this design process or throughout the process of, I would say, from ideating to building your commercial entity, taking it to market, there are multiple back and forth cycles which the innovator or the would-be entrepreneur has to do before he launches the product in the market or before even deciding to commercialize. Now, having said that, business model canvas acts as a very, very important tool to validate your thought process and also structure your thought process and see what are the various elements of building your company, which could probably be facilitated by this canvas. Now, very interesting framework, which is worldwide use in the entrepreneurship space. It was a framework developed by Alexander Osterwalder. It's actually a visual representation for the main aspects as to how an enterprise defines, deliveries, and captures value. Now, for example, if you see on the right, these are the various blocks of the business model canvas. I will also go into the details of each of the block, at least a basic insight into each of these blocks. But broadly, the canvas helps the innovator to understand who are all the stakeholders, what are the relationship between the stakeholders, who wants what, and how do I propose. In fact, in Derby Foundation, we have 3 programs which we run for entrepreneurs. One is called a pre-incubation program, incubation and acceleration program. Typically, the pre-incubation program is for somebody who's an innovator, who has an idea, who's not yet formed a company. So we have run about 3 to 4 cohorts of the pre-incubation program. Some of the startups have come and told us that this whole exercise of building the business model canvas has helped them in such a way that some of them have even dropped the idea of starting a company, whereas some of them have pivoted the idea and taken it further. So it's a very, very important tool, I would say, to be constructed, again, keeping the customer as a core focus to help you to validate whether your idea can become a good, viable business proposition. So these are the 9 frameworks, what I was just now mentioning. And of course, first one starts with one, and one is a prime focus of any enterprise, the customer, right? So I think there has to be a very, very clear understanding of for whom are you creating value? Who are the customers who would either receive your service or receive your solution and are ready to pay? I think that pay has to be there. That is very, very important. Then the other elements are the number 2, who are the partners who are involved in you in running the business? Partners could be your suppliers, could be your distributors, could be the partnerships you have to form in order to execute, things like that. And what are the activities which your partner is going to do to complement you in your business? And what are the key activities you have to perform every day that is the core of your business? What are the key activities you do to sustain your business? Then number 4, you have in terms of the value add. So what are the value add you provide to the customers? Number 5 is the value proposition you deliver to your customer. How do you deliver these value proposition to your customer? Number 6, now how does your value proposition reach your customer? In fact, after this, I know at this point of time, maybe it is little vague to some of you. I have 2 examples of business model canvases done for different industries so that you would be able to relate to what I'm talking now. Now, how do you reach your value proposition? Through what channel do you reach your value proposition to the customer? Then number 7, the most important is your cost structure. Then you have your key resources needed for implementation. Then relationships, how do you maintain relationships? And then take it forward. Now, probably I will go to the examples and then come back. Now, first example I would probably like to take is an easier, straightforward example, which all of us understand is the example of the supermarket. Now, for example, taking the same business model canvas, what we just now discussed, keeping the supermarket in mind, who's your customer? Your customer is a mass market, or anybody and everybody in the society who wants to buy from you. Now, why will he come to you? So what is your value proposition? You are offering food, beverages, cleaning products, hygiene products, all of them at a very good quality, and your location is very accessible to them at a very affordable price, and you have wide offering of what you're trying to offer for them, right? This is what you want to do as a business proposition to the customer. Then who should be your partners who are going to help you in this execution? Probably you need to have definitely the suppliers who can supply the whole lot of things which can be a part of your supermarket. What does your activities involve? Starting from visiting your suppliers, building a relationship with them, buying their products, ensuring that there are enough stock in your supermarket, managing the logistics, and of course, selling to the customer. Are all these your key activities? And what are the key resources you need to set up and run the supermarket? Definitely need one entrepreneur, that is you, probably. And you need some employees, maybe full-time, maybe part-time. And definitely you need a shop, you need stocks, that is the material which has to be there, and initial investment to do all this, right? Now, how are you going to build your customer relationship with your customer? You may probably have some assistant who's there to help you build the relationship. Maybe an internal advertisement within the shop, could be outside advertisements, what you do. And how will you get the revenue for running your business? Definitely your broad revenue should be, you are buying a product, you're selling it, probably you have a markup price on which you sell it to them. Of course, you should have your cost structure. What is the cost involved? One is getting up your stock for the supermarket, the employee salary, what is there, then the depreciation on your stock, then the transportation cost and all this. So through this exercise, when you do this exercise, somebody who wants to set up a supermarket will now have a rough idea about who's your customer, what is needed to set up the business. And see, this is only the first level of the business model canvas. This has to be detailed out in terms of, say, for example, we take the cost structure. Real numbers have to be put in to see whether it really makes sense to have a commercially viable venture. Vis-a-vis the revenue that you're going to generate from this venture, and the partners you have and resources and a whole lot of things. Second example I've taken is for a a medical record management company. Now, this is a company, hypothetically a company, which is offering an application to manage the medical records of, say, a dentist. So obviously, the customer segment this person would be looking for would be the dental patients, the dentistry patients who are changing dentists or having surgical procedures done with the dentist, right? Now, in this situation, why will customers come to you? So your value proposition to the customers has to be very, very clear, right? Where you're looking at patients who want to transfer the medical records between doctors, something like what Practo is doing today, right? Now, simplify patients' consent for transfer, lead, reduce time, and all that. So how will you build customer relationships? Because you're able to save time and patients have greater control over their records. Since it's an app-based platform, what are the key activities you have to do? One is definitely development of the app itself and linking of dentist's office to the existing network which is available. Key resources is definitely the software development and the service quality and security needed for the software. Here, the key partners for this, here again, in any development of any application-based business, I think the very key important thing is developing of the ecosystem or the partners so that your platform, what you've developed, works very well. And here, the key partners you should look for as an entrepreneur could be the physicians or the dentists who are practicing, the hospitals, patients, insurance companies, and so on. So as we've seen in both the cases, from this supermarket to the medical record management company, the entire perspective of what needs to be done totally changes, right? Now, having seen these, so what are the key questions which anybody who has an idea wanting to start a company has to answer? So the key questions to be answered are, the first key question is, how will your startup deliver value? So as I said early on, I think the entire value prop about a startup or value prop about the idea you have, the market you're trying to create should be centered around the customer. So the first one is, what value proposition are you trying to create? Are you trying to do a solution which is customized to the customer? Or is your solution having a better design? Or is it better pricing to what he's currently using? Or is it going to reduce the risk for him? Or does it enhance his accessibility to anything? So the value proposition that you are offering to the customer has to come out very, very clearly. Now, how are you going to create and nurture customer relationships? This again is very, very important. See, in the case of a supermarket, we saw that the only channel for creating and nurturing would be when he or she comes to the shop to start off, right? The next one is, how will the customers be able to access your startup? Now, are you available through a digital media, through phone or in person, or should they come to you? Now, for example, if you say, I'm a hospital, now for the customers to access the hospital, you have to be physically available as a hospital so that people can come and avail your service. For example, if you take Practo, see, today if people want to access Practo, it is just a platform, right? So customers can access Practo as a platform. So this is again very, very important. If you say you are building a solution, you are building an enterprise, what is the methodology by which customers are going to access your service? Now, how can you validate these core ideas? I think this is very, very important. In fact, many startups whom I have seen, what they do is they are totally in love with their idea. You typically call them as a pink-eyed entrepreneur. They're totally in love with their idea. They do not see anything around the idea. They're so much in love with the idea. This is actually really could be disastrous many times. So before you really take the big plunge and start a company, I think very important to validate around these ideas, see what the customer wants and what can be done. First one is try to do whether you could do a market research. See, market research doesn't essentially mean a thorough academic research. It more so means connect with the people who matter, and people who matter here are the customers. So talk to customers, see how do you access them. First of all, find out whether the solution or what you're offering, is it going to really solve their pain points? Then find out what is a pain point they have, right? Now, many cases, if the entrepreneur is very clear that and very, I would say, confident that his solution is really required, see if you can build a minimal viable product which could be demonstrated, maybe a technical prototype, or even as a proposition. You could probably talk about your proposed solution to the customer, saying, this is what I have in mind, so I want your feedback. I think getting feedback from the customers are very, very critical at this stage. So receive feedback, and this can be used as a validation of your own thought process. So especially when you're building customer-centric products, it can never be a push into the market. It always has to be a pull from the customer side, right? So multiple ways a customer feedback could be obtained. You could go to a lot of, today, I mean, through online, there are a lot of survey sites. You could do a survey, you could do cold calling, you could do through your friends and circles and all that. So this could be done. I think this is very, very important exercise to validate your idea, whether your idea can become a commercial enterprise going forward. If you find there's a lot of value in what you're proposing, the next thing is you have to, before you really kick off your whole initiative, you should find out who could be your partners in this idea. Especially if your model business or whatever you're proposing needs very strong partnerships to execute. Now, for example, I will go back to the example of Practo itself. See, if I would say potential patient has to avail the services of Practo, I think it's very, very important for Practo to have firmed up the partnerships with all the hospitals, doctors, and all that. So all those people would become the partner for the startup. So accordingly, when somebody is building a business, if you feel that for your business, I think partnership is a very key thing. So you'll have to go talk to the partners, find out, are they willing to be a partner in this initiative? What are their conditions? How much do they expect? What conditions do they expect? A lot of things to be in place. Because this will also have a very huge impact on the financial planning, which you would do going forward. Now, what are the things that you would do in order to get going? That is your value proposition, distribution channels. Distribution channels are those channels through which your solution reaches the market. And how do you manage your customer relationships? And mainly, from where do you get revenue? I think identifying revenue is very, very important. Again, in many cases, it also depends on the business model. Now, for example, do you give it off as a service or do you give it as a pay-per-use? What is the business model you have? Accordingly, it will have an impact on your revenue as well. Now, what are the specific resources you need to generate? I think this again is very, very important for you to kick off. Now, if you are having a minimal viable product, that is a basic version of what you're trying to build, and demonstrate this to not only your customers, probably your partners as well. So this will help you sort of validate all these three critical questions that you need to answer. Next thing is, how will your startup capture value? I think this again is very, very important. Now, to understand if a customer has to come to you, what is the value that you're offering? As I said earlier on, see, value could be in terms of cost, in terms of features, in terms of convenience, multiple things, right? And in that case, so this has to be directly validated with your customer itself, like what is acceptable to him or her. And after validation, probably you should look at the cost structure of your startup. Because there are multiple ways of running a business. Are you offering a product, or are you offering a service, or is it a pay-per-use? All this will also impact your cost structure of your startup. And once you have an idea, you should also find out what are the multiple ways you can generate revenue. Because we have been seeing multiple startups, they start with one source of revenue, but then it's a long haul. I mean, you will not immediately break even and start seeing money. So you'll have to have multiple sources of revenue to sustain and then build on all this. Probably when Casey is going to talk in the last session, we would also get a lot of insights about how he built the company, what are the sources of revenue, how did they scale up and sustain. I think this is what we saw now, the supermarket and the dental company, what we saw. I think what I would do now is probably stop here and reserve the last 5 minutes if there's any specific questions on business model canvas. The reason I'm stopping here is because each of the sessions are 3 distinct buckets by themselves. So somebody who has a specific question on business model canvas or ideating, probably in the next 5 to 10 minutes, we could take that before we go into the next part of today's workshop.
Hello, Dr. This is Balaji. Yeah. So I think it was a wonderful talk and nice. Okay. It was.
Thank you so much.
Yeah, sure. It was nice to hear about the business model canvas. as many of us here would be from the neuroscience background, more specific example of perhaps drug, say if you think in terms of neuroscience lines, right, you may be thinking in terms of drug that you have discovered that may be acting in for a particular disease, or an equipment which can serve as a diagnostic purpose, or a lab equipment that people would use. These are the kind of things most likely you would be ideating. I'm not saying that is the only thing, but just a PhD is a training, right? So you would. So given this, is there kind of a blueprint or a kind of a template where people can plug in and then try to generate this business model canvas?
Yeah, definitely. In fact, I would also throw a little light. See, as I told you earlier on, see, Derby Foundation is focusing on healthcare. Now, one interesting initiative we've been doing from the beginning of this year is now we are supporting about 10 innovators who have an idea wanting to build a medical device. Most of these, I think out of the 10, I think all of them are into medical devices, and help them to build this for the next 1 or 2 years, give them all the inputs so that they could build, test it and validate it. So predominantly, I would say there are two components here. One is a business model canvas. Other one is building the solution itself. I think both of them have to go in tandem. See, and essentially for both of them, that is building the solution and the business model canvas, customer is the focus. Now for these, essentially what we do is say somebody comes to us with an idea saying, I am going to build this medical devices or a solution for this particular problem. Now what we do as a program, as a thing, what we do is we help them connect them to the key stakeholders. For example, somebody says, I am building a device which could probably, let us assume a non-invasive glucometer. If you say, no, this is a solution I'm trying to build. Or, in one of our startup innovator who's there, who's trying to build a smart shoe. Now, this shoe specifically is for a diabetic or patient with foot ulcer, right? Which also is able to detect the damage which is caused to nerves and all that. I think some of the people from this domain would be able to associate with that problem. Now, when there's somebody who's building a solution like that, we first help him to talk to the relevant guys who are there, the relevant stakeholders, could be doctors, could be physicians who are concerned, right? To get their inputs on how the solution has to be built, where it is going to be used. See, technology is one part. The predominant part is where it has to be deployed, how it is going to be used and things and all that. Then what happens the next stage, he builds a typical proof of concept as a smaller version, basic version of what he's intending to build. Then that is actually, we connect them to be deployed in hospitals, doctors, in the actual real scenario where it can be used to get a feedback. Then once the feedback is got, again, he comes back to his workbench, starts making tinkering and bringing about those changes, again goes back. So this is a back and forth process. Still some fine tuning is done. So at least he's able to build a minimal viable product. Now, after that, before he goes to the actual taking to the market, especially for a healthcare product, there are a lot of regulatory requirements to be met. Now, as an incubator, we are connected to a lot of experts who are experts in the medical domain, who can tell you whether you need a CE certification or ISO certification. Each of these certifications, what are the regulatory requirements to be met? How should your product be and things like that. So when finally they are able to build a product, probably at that stage, it is left to the entrepreneur. Some of them register a company where they're looking at raising funds and then take it forward.
Another quick short question, which is, so we talked about the multiple revenues that you need to look for, right? So there is there are two components to it, as I understand, perhaps, because one is the quantum of money or quantum of the funds on the revenues, and the other is integral to that is that typically in your experience, how long does it take? How long should I budget in terms of man years or time, human years that we need to budget in terms of lifetime, right?
Sure.
So that.
I think in the healthcare, professor, I think it's a longer gestation period. Starting from building something to at least will take about 4 or 5 years, before you really start commercializing. I'm talking about full-time engagement. And talking about multiple revenues. See, recently, I think one of the doctors who's also a pediatrician, he called me about 3-4 weeks back. Now, he and one of his co-founder, Now they are planning to, I mean, they are on the way or almost done a platform to manage vaccinations. Now he was talking about 2 or 3 revenue models for the vaccination itself. One is the platform, through the platform, connecting to various parents or people who would be using this platform to get their children vaccinated, keep a tab, more of a subscription model. That is one. Then another 2 is probably he would talk to, see, this platform would also be used by companies who are supplying vaccine to the clinicians and all that. That's another thing. Then the doctor was also mentioning about another device or a solution what they found out where it can minimize the pain during vaccination for kids. So probably by selling those kits, he could also make some more money. So we can see that there are multiple sources of revenue for the same company.
Okay. There are a few more questions.
Yes.
This is from, I don't know who is that person, but great clarity delivered, madam. Thank you. Is product development key for business? Any suggestions for basic science researcher in academics?
Okay. Definitely. I mean, if you're see what we have seen is, India, I think out of the 100 startups who were successful, I would say 95 to 96 are in non-product area. So first of all, building a product company is a huge challenge, in terms of the cost involved. Again, a longer gestation cycle to build a product and then take it to market. But then if you see a clear value proposition saying, if I build this product, there is a definite market, I think you should go with that. You should go with that. And see, today, if you see, I mean, I've been talking to people in multiple domains, be it biology, be it biotechnology, be it nanotechnology. Today, there are a lot of startups who are working in the deep tech area where basic sciences are required. So I think, yes, I mean, if there are somebody who's doing who's a hardcore researcher in basic sciences, number one, you could explore, see what you're working on could become a startup by itself. See, not everybody needs to become a startup, right? Not everybody needs to become an entrepreneur. But somebody who's very strong on basic research, you should probably see how you could engage with the startup who's working in allied fields. Now, last few weeks back, I was talking to a couple of researchers in the area of nanotechnology. Now, nanotech, again, is a basic science. Could be nanotech in physics, where you're talking about characterization, multiple things, and nanotechnology in biology, things like that. They are finding wide applications, be it in agriculture, be it in food, be it in healthcare. So I think basic sciences are finding applications everywhere. The only thing is, I think, see, researchers are very good, but they love to do research forever. I think that is I would say probably a dangerous sign, right? Unless you are really wedded to research. Some point of time, you should jump into commercialization. I think that's the key.
All right. Thank you.
Sure.
Over to you.
Sure. Yeah, so we are done with the questions. So we'll go ahead with the next session. Good, I've stopped at least 2 minutes before. In fact, Mr. Biju had, I think, half an hour. How much can I cover? I think I will open the floor for him. Should I also introduce Mr. Biju to take over the session now?
Yeah, please.
Yeah. Yeah. It's my pleasure to introduce Mr. Biju Nair to all of you here today afternoon. He's an independent technology lawyer with more than 2 decades of experience in data protection and especially defensive patent strategy. And thank you so much, Mr. Biju. I think it's in a short notice we reached out to you and he graciously agreed to be a part of this exciting workshop. Over to you, Mr. Biju. We are waiting to hear from you.
Thank you, Dr. Lakshmi. Good afternoon, everybody. My name is Biju Nair, and I look at technology from the legal perspective and the policy perspective. And I would like to talk about how IP from specifically from the umbrella of patents, how we can look at those concepts and ensure that we can use those. How do we take an idea to a patent stage, and how do we protect it? How do we ensure that there is a what are the various strategies of creating patents and protecting it. So I'll start with the basics, where we will talk about what is patents and give me 2 seconds. I'll just put on my slide. So is the slide presentation visible for everyone?
Yeah. Please, can you go to the presentation mode?
Yeah.
Thank you.
Yeah. So I'll be talking about nuances of IP, especially regarding the patents part. So IP is the umbrella under which there are various, trademark, copyright. So here today I'll be discussing only about patents. So what is a patent? It's basically a monopoly which is granted by each government. Like Indian government, the patent office will give you a monopoly for 20 years for you to commercially exploit it for an innovation. And it is generally for a period of 20 years once it is granted. So what are the requirements for you to get a patent? What are the fundamental ingredients or the criteria you have to fulfill to grant a patent? So one is novelty. The inventor needs to show that there is no something which is new, which is not in existence, non-obviousness, and there is an industrial application. So you would have seen in the academic circle, you would write a lot of academic research papers. So once you have written a research paper, it is no more, that idea or that thought process is no more novel because it becomes product. In case you're thinking of patenting something, you should not be publishing it. So that novelty factor still remains there. And as I said, there should be non-obviousness, then there should be industrial application. It should be something which can be utilized by the world at large. Then the patents law also segregates what can be patented, what cannot be patented. A process or method can be patented, a machine can be patented, a manufactured article can be patented, a new composition. The drugs, all are compositions, chemical compositions. A new variety of plant. A separate law for this, there is the Plant Varieties Act. Then it also segregates what cannot be patented. Software and business methods cannot be patented. Software as such cannot be patented. Biotechnology, medical methods, inventions against morality. These are the broad things which cannot be patented. But there are further guidelines, like in case of software, there are further guidelines. What software can be patented, that's called computer-related invention guidelines. Patent Office of the country has come out with guidelines around that. Similarly, all these areas, they have come out with guidelines and, directions. So now coming from, looking at it from an academic perspective, I do a great research. So typically I would publish it in any journal. And then I generally go for doing a patents. And so before filing for a patent, what should I do? I should do a search. So as I said earlier, if you do a publication, it becomes a prior art. So there is novelty lost. It is known to public at large, or the community in the research community, at least. So you should avoid publication if you are thinking of going for a patent. You should stop yourself from disclosures. So first thing you should do is a patent search. There are various platforms. So if you want to do an Indian patent search, there is Government of India's the Patent Office website, which is listed here. You can go there and do a search. And based on your patent search, you will be able to understand whether there is prior art, whether there is already a patent granted in this field of subject. And you will also be able to understand whether somebody has commercialized that patents. So for example, that patents was granted to Indian Institute of Science, for example. But Indian Institute of Science has assigned it to, let's say, Tata Technologies. So you understand that Tata Technologies has a need and commercial value for those patents. So a patent search has multiple value for you. One, you will understand whether there is a prior art or there is a prior patent granted. And if it has had any commercial value for that patent, somebody has bought it, it has been assigned, all this information will be available for you. So how do you do this? You can do this by putting keywords. So if, as I said earlier, patent is a monopoly granted by each country. So for example, you want to file a patent in India, you will go into the patent office website and do the search. If you want to go have a patent in the European Union, then you will go to the European Union Patent Office website and do that search. And there are generic websites like Google also where you can do this search. So all these platforms for US jurisdiction, you can go to the US Patent Office, USPTO's office site and do this search. So you would do this search by clicking in the right keywords, understand the invention for performing thorough search, and determine the relevant patent classifications, which are the categories of patents also you will identify. And if you see, there are global cooperation treaties, that is patent cooperation treaties, where you can, sitting in India, file patents in various jurisdictions. So that is the PCT cooperation, we call it as a PCT application, in which you can sit in one country and apply for patents in various jurisdictions. So at 148 countries across the globe are part of this patent cooperation treaty. So after doing the search, when you find that there is a relevant prior art document has been identified, what are the details of those prior art documents? Because sometimes you could be able to differentiate between that prior art and your innovation. So you should also look into those aspects because there's a thin line of difference. Because patent drafting is a skill where you have to look into the claim, and the broader the claim, more the infringement would happen. So as a patent agent, you would always look into how to broaden your claim so that various aspects are covered in that application. At the patent office side, they will try to reduce the broadness of the claim. So it's a thin line of difference between broadening the claim. So your objective is to broaden the claim, and the objective of the patent office is to reduce the scope of the claim. So as I said, you also have to look into various geographies when you are trying to do a patent. You will also understand what is the commercial value, what has been the success rate of patents, what is the reason for denial of the patents in certain jurisdictions, what is the ground for opposition. Was this patent being opposed, this subject matter has been opposed in various jurisdictions. Opposition can happen at various stages, pre-grant stage and post-grant stage. And as I said, the assignee search also will be valuable because who has bought those patents, who has assigned been. You would see that the University of California has got the maximum patents granted in the globe as an academic institution. So if this academic institution has been able to get maximum number of patents, what is it done with those patents? Because sometimes that field of work may be of not interest to that university. So they could assign it to a company or any other individual to monetize it. So you could also see, for example, there is a great academic person and let's say he or she has been granted various patents. So we can do a search based on that person's name. So you would understand that what are the patents they have been granted. So all this way you can do a patent search, and there are various prior art literature. Like in case of US jurisdiction, the ip.org is a platform where you can go and do a search to understand whether there is prior art, whether there is prior literature, and all those things. Now let's look into various types of application. So one is the provisional application which you have applied, where it's a temporary application and the invention is not finalized and it's still at the experimental stage. Then, as I said earlier, there is a convention, the Patent Corporation Treaty is there. So that is the convention application where you file claiming priority. So for example, today you have filed in India under the convention application, you would claim a priority on this day, even in US or any other jurisdiction who are party to this Patent Corporation Treaty. Then there is ordinary and provisional application also. As I said, you can file an international application under the Patent Corporation Treaty. And there is also another type of application where, you want to do some modification of a patent application you have already done. And there is slight improvement or changes in the existing application you have made. You can also do that. And that sometimes you would also be doing multiple applications around the same subject matter. So this is called divisional application. Although generally it is not advised to file a divisional application unless you feel that it's a path-breaking innovation and stuff, because you would also learn in the process, what are the reasons for
Yeah, I think we are.
I think this is hanging, I think.
Dr. Lakshmi, I think we have missed Mr. Biju.
Now he has come. Now I think he is muted.
Mr. Biju,
you are muted. Can you unmute yourself?
Mr. Biju, you are muted. Mr. Biju, you are muted.
Yeah.
So maybe Lakshmi.
Yeah. Yeah. 1 second.
Yeah, I think your voice is also, there is a breakage in the voice. I think there's some bandwidth issue or what, I don't know.
Am I audible now?
Yeah. Perfect. Yeah.
Yeah. Is my screen visible to all of you?
No.
Is my screen visible?
No.
Not yet.
Okay. Okay, I think the screen is still not.
Yes. Yeah.
Okay. The screen is visible, no? Okay.
You can move on to the presentation slideshow.
Yeah. 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 So I was talking about the various opposition you will find in a patent application is at the pre-grant stage. So once you have made an application to the patent office, and once all the office objections has been taken care of, this patent application is published in the patents journal. And once it is published, anybody can go for a pre-grant opposition at that stage. So, so this is a stage before the patent has been granted. And once the patent has been granted, within 1 year also anybody can, who is an interested party. So previously anybody could have filed an objection or opposition, but once the patent has been granted, only an interested party can file for an opposition, and within the time period of 1 year. So now let's look into what are the various common mistakes, especially in the academic circle, before going for a patent. As I earlier said, publishing before the patenting. It is common that in academic circle that we we have academic papers and stuff. And in case you have revealed everything there, it becomes prior art, and that's one of the requirement. There should be novelty. So because of which your patent will not be granted on that subject matter. And so before you file for a patent, you should also do prior art search. So whether there is any publication, whether it could be as even any business, article which states all those details about what is this innovation. And also it could be that, publishing improvements after filing a provisional application. So you have applied for patents, made an application, and you are publishing something before the patent has been granted. Because again, the prior art clicks in. Then also making statements in public at large. So all these things, if you are done it privately, like it is internal, it is not public, then things are okay, still okay. But if you have made public statements about the patentability of the future invention, then that's also a problem, which we find commonly. Now let's look at, so what we have spoken about is filing for patents, and that's an strategy where you have a financial wherewithal, and you also have the time and resources to file for patents in various jurisdictions. But certain times, certain times we also find that certain subject matters are not core to the university's work or the lab in which they are working. So in those cases, what happens is, they also have to ensure that this subject matter is protected from patent filing by somebody else. So in those scenarios, what we suggest is defensive publication. So what happens in a defensive publication is it becomes a prior art, and if somebody else goes for patent filing, they will their patent application will be rejected on the ground that there is a prior art, and your publication becomes the prior art in that case. The only disadvantage to defensive publication is, as I said earlier, that you yourself cannot file a patent on the same subject matter. But you can stop by this method, by defensive publication, others filing from a patent on the same subject matter. And where you feel that this is not very core to the work you are doing, and or you don't have a financial resource to file for a patent. So in all those scenarios, or you want to stop a patent in a different jurisdiction where you are in, like you want to ensure that in the US Patent Office, nobody files for a patent on this subject matter. Or this is so fundamental that you don't want somebody to have a commercial interest and encroach upon this area of technology. So all these reasons could be a reason for you to file a defensive publication. Then there are global communities like Open Invention Network and LOT Network, which provides you a defensive patent strategy. So you would have seen there are 3 types of entities globally. One is an operating entity, which does operation and they have patents to defend themselves. But sometimes these entities also behave like a patent troll, where they use their patent portfolio to assert it against various entities. It could be universities, it could be other companies, it could be startups, it could be anybody. So Open Invention Network creates an ecosystem where fundamental technology around Linux and open source is protected from patent tension. And this is a global community. And here there are two strategies against different types of problems, patent tension. One is patent tension from operating entities. So operating entities are entities which has some operation and they also have patents. So they want to assert their patents and make money out of those patent infringement cases. In such cases where it is on fundamental technology like Linux and open source, what you can have is you can join the community. It is free of cost. You get a patent tension-free ecosystem on 3,300 and softwares and applications. Some of them could be in usage in medical technology. Some may not be in medical technology, but a lot of resources are there, like ERP solutions are there on medical technology, which is based on open source. So a lot of usage is there. We also have 1,300 patents in this community, which is in all areas of technology. Some of them are in medical technology, where we have spent almost $100 million US. Some of them are in biometrics. 100 of these patents are in biometrics. Each of the community member can use these patent pieces without paying any royalty. Can commercially exploit these patent pieces. The object of these patent pieces is that in case a community member is attacked by an operating entity which behaves like a patent troll, then we can lend this to the community member and they can counter retaliate against a patent troll. So there are, this community also supports the defensive publication, especially in US. And as I said, joining this community is free of cost. The other community is also called as LOT network, license on transfer. Since most of these patent trolls, which are entities which just buy patents, they don't have any operation, they buy patents and then start filing patent infringement cases. So it could be a startup they would be filing a patent infringement against, or it could be a university, or it could be the biggest company in the world. Their only objective is to monetize from the patents, and which they have not innovated. They have bought it from somebody else. And this is a community which stands for license on transfer. So when any lot member, we have 1,000 members globally. So any lot member, when they sell any of those patents, in case that patent falls in the hands of a patent troll, that patent troll cannot use this patent which a lot member sold against another lot member. That's why the term license on transfer. So this is a manner in which almost 12% of all the US patents granted is owned by some of the community members of LOT. And this way, 12% of patents are away from the hands of patent trolls. Especially in jurisdictions like US and Germany, many of the universities also have faced litigation from these patent trolls. So many universities are also part of LOT network and OIM. The other issue which I also find among universities is once they have patents, they also have a problem of commercialization. So the common problem which I find is they are not able to identify partners, or they are not able to identify opportunities in the right sector. Like, for example, any sector, any medical field, they are not able to. So one way of looking at it is, in the past, in the patents database, each country's database, you could look and see who in the past has bought those patents. Or sometimes joint venture and collaboration between industry and academia is also a way where in which commercialization has happened. The other is also where instances has been where there has been R&D collaboration which is happening between academic institutions and commercial institutions. So these are the various ways. Various universities abroad also have transfer of technology departments where their only objective is to commercialize the patents which has been owned by these universities. And in certain cases, we have also seen universities selling these patents to commercial entities or any entity who is ready to purchase this. So with that, I would end my session, and I understand I'm standing in between the next speaker who has commercially enabled his work globally. So I think I have taken my time.
Thank you. Thank you so much, Mr. Biju. Any questions on patenting IP?
Dr. Biju, I have a small question. Any example of a university in India like patenting like some of their innovative results? Like of course in US and all, they have their own cell.
Sorry?
Of course in US and all, they have their own cell.
Yes. So Indian Institute of Science has almost 1,000+ patents, although their success in commercialization has not been great, but they have attempted. Now some private universities also, I think last year it was University at Chandigarh, which had maximum, it's a private university, which had filed for maximum number of patents, I think 500 patents as of date. So the success rate of Indian universities in commercialization has not been great. The government of India is also putting a great emphasis on this. As you have already seen, China has overtaken US in the filing ecosystem. So one thing which I think the US example gives us to learn is that quality of patents is very important. We should not be looking for low quality patents. So that would backfire for the economy as such in the long run.
Okay, there's one question in the chat box.
Yeah.
How do you help the academicians to do any patenting? Is there any how to approach the right person
and
to
the cost part also?
Yeah, it includes even the fund also. How do we go to fund and also?
So that's a good question. In fact, there are various departments of the government, and also some of the universities have their own patent cell. And even the government of India, and in I think BIRAC and other grants also provides you some money for patent filing. Even the Karnataka government does give you money post they reimburse. In case of Karnataka government, they reimburse you the money even for patent under the international treaties. As a researcher, I think the best money is to take through the government grants in the medical sector and all. Grants, BIRAC grants, and various grants are there. So government grants are there, private entities are also providing grants. Some of the universities also have their own fund for patent filing. I know of private universities which have created fund, and they give a lot of impetus to their students to file for patents. And it's also a medium of advertisement for them.
Yeah.
In fact, DBT, DST, they have their own patent cells. So suppose you have a DBT funded project, and as part of the project, you have come up with a novel drug molecule, you want to patent it. So if you inform the funding agency that this is through a funded project, so that funding agency will take care of the charges, whatever cost. That's what I understand. So correct, sir?
Yes, yes.
Can I ask a question?
Yes.
If you have time.
Yes.
So, for example, if you make a derivative of a particular compound or something, but it has not been patented, can you patent for both the main compound as well as for the derivative for a specific treatment?
Yeah, as I said earlier in my this one, if you fulfill all those criterias of patentability, so I think it will be best, the person who has done it, who is innovator, he himself does that work at the first instance at his level and looks for, does that search, he will get a lot of information if there is prior art. Because, if we don't do that exercise at our level, and, sometimes after a year or two, the opposition comes, and in the opposition, we see that there is a prior art. So I think a lot of homework has to be done before we do a patent filing at our individual level and at the patent attorney's level.
Okay, thank you.
Last question, like not exactly question, just a help. It will be very much helpful for the viewers, like to have your email ID and contact details. If possible, can you put it in the chat box?
Yeah, I'll put it in my chat box.
Thank you very much.
Okay, thank you.
Thank you. Thank you so much, Ms. Biju. Yeah, thank you so much. I think now we'll come to the last leg of today's session, which is the most exciting one. In fact, Mr. Casey has already joined. Thank you so much. It's my pleasure to formally give a brief introduction of Mr. Chandrasekhar, who's fondly known as Casey in the startup ecosystem, a technology veteran with about more than 4 decades of experience and a very strong believer in democratizing healthcare. So we thought he is one of the very successful Indian entrepreneur who needs to be showcased, to all of us to understand and emulate how he is built. He is the CEO and founder of Forest Health Private Limited. The company has grown from strength to strength under his leadership and is present in 26 countries now. Casey, I think we are all waiting eagerly to hear the story of how an Indian startup, which is now a global company, how have you done this? Yeah, please, over to you.
Thank you, Lakshmi, and good afternoon to everybody. So I'll basically, I think I have like 30-40 minutes. So quickly run through. I saw the heading as idea to IP to product to market. So I think one of the critical things for a medical devices company is basically to understand the problem. I think understanding the problem becomes the most critical parameter for a medical devices company, because the more in depth you know the problem you want to solve, the solutions can be better, right? So I think the in-depth understanding. So we took preventable blindness as our goal, and one thing which I continuously reiterate, and probably if people would have heard me, would have heard this many times, but I still want to repeat. Our aim was not to build a medical devices company. Our aim was to build, our aim was to eradicate avoidable blindness using technology, and medical device was a consequence, because we found having a medical device doing certain functionalities was a bottleneck. And if I have to democratize eye screening, we had to break this bottleneck. And that is why we created medical device and not the other way, right? It's not that we decided that we will become a medical device company and thereby went about creating this. So why I reiterate this when I say understanding the problem is important. I think understanding the problem is not just about what is the problem you want to solve, but also about many things which are very behaviorally oriented, right? Technical, I think a lot of solutions can be found. And even if you don't have a solution, you can outsource, right? But I think behavioral understanding of, for example, India has the largest blind population in the world. So why India has got the largest blind population in the world? So you need to kind of look at those kind of basic questions. So number of ophthalmologists are comparatively lower. And next, you have to understand, why does a patient come to a hospital much later? So it is not only connected to him, it is also connected to, people who are in his family who should bring him to the hospital, the economics around it, the travel, the accessibility. So you need to kind of go in depth. It is not just, okay, I want to create a product for treating jaundice of babies. So it's you don't take it that way. I think the end product can be that, but you need to analyze how big is that problem, why is that problem occurring, and what, by you creating a product or a solution or a device or whatever it is, how will it get solved, and how it connects to the behavioral pattern of people, right? One thing for a startup, which is very important to understand, is we cannot take or we cannot change too many things in the behavior, right? If doctors are used to doing in one way, right? And if you are coming up with an innovation which is completely radically shifting the whole thing, it may be great, but unfortunately, you will spend a lot of time in convincing the doctors to make that shift, and that convincing, time and cost of doing that, and probably the probability of doing that will actually overpower the innovation. So I think we'll have to do that in small baby steps, where you do something which is mainstream, where behaviorally people are used to doing. So, for example, if people are used to using a stethoscope, people come up with a digital stethoscope. So this is a marginal improvement. But then when you make that and you become an established player, then you can do something radical, because now people kind of respect you, that you have made a product which works, it's worth the money and all that. So I'm not saying don't do radical innovations. They are very critical. But I think for a startup, unless you can actually make a significant impact either through the government or through yourself, these smaller steps really kind of help. So I think the first thing I would strongly recommend is look at the problem very, very deeply from all angles. And no innovation is of any use if it cannot be put to use, because it is actually not an innovation. Because you can call it an innovation, but it is honestly not, because if it is not seen the light of the day, it is not met the intended purpose. If it is not going and solving a common man's problem, we have not, it's not an innovation. So I think understanding it from a market orientation, understanding it from who's going to buy, who's going to use, who's going to benefit, those are things which should be fairly clear, which becomes a very important part when you design the product, right? So if you have this knowledge, then your product designing becomes far more clear, because you know who's the user, and you can design the product. The usability functionalities can be based on the user, right? It is not just based on solving a problem. It is based on who's also going to use it, right? So those are things which I would say is very critical. And when you are actually going through this, you will also have why it has not got solved before as one of the questions, right? So if either it is an ignored problem, or people have made solutions which are not currently tackling the current problem, or it is very expensive. It could be many of those parameters. But so if you figure out why it has not been solved, then actually you get into the methodology of solving the problem. And that methodology could be either it could be a process, it could be a way in which you are doing, and that could be your intellectual property. So then, as Dr. or Mr. Biju Nair talked about, you can go about patenting it once you have created, and do the other formalities, so that you protect yourself as far as competitors from coming. Because when you go through this cycle, you spend a lot of time analyzing the problem, you spend a lot of effort, and your product may kind of from a product creation standpoint, maybe only a 6-month story. But for you to come to that, you would have done research for 1 year in understanding many things. If I want to cut, copy, paste, I can directly cut, copy, paste what you have done. Your 1 year of effort may kind of go waste, and I'll cut, copy, paste only your 6 months. So protect yourself on the intellectual property, which is very critical. But I think that not every product is capable of creating an intellectual property, right? So if you try to solve the problem in a different way. So for example, in our case, we had to solve the problem that existing devices were very expensive, existing devices were very bulky, existing devices were using dilation of the eye, existing devices were only in very high-end ophthalmology clinics. So when we have to go and create a product which is basically that, why can't I democratize eye screening? why should eye screening be done only at an ophthalmology hospital? Why can I not separate imaging from diagnostics, right? Why can't I image a person anywhere, but the diagnosis happens at an eye doctor? Because we are also playing with reality. If we are having only 20,000 ophthalmologists, so you have only 20,000 access points for solving a problem, which is a surgery or a treatment or giving medicines. But what existed before was that the imaging was also happening at the same 20,000 points. I'm not, all the 20,000 did not have, but I'm saying even if you take at the market size, it is only those 20,000 doctors, right? So imaging was happening only where the doctors were, which is obvious because people who were coming to the doctors were people who were known patients. But the problem we were trying to solve was that patients were coming to the hospitals much later. That is why preventable blindness was happening. So why don't we ensure that we provide more access? Because one of the points which came when we analyzed the problem is that why people are not coming early is because they don't have access. First, they don't believe they have a problem. By the time they believe and realize, it is too late. And by the time they realize and they find an access to an eye doctor, it is still too late. And most of the time they also drop out because they think affordability is an issue. Now, if you have to cross all the barriers, you need to do one after the other time. So you cannot replace a doctor, right? Doctor is the one who can fundamentally do the clinical part. He's the only one who can solve the problem. But can we not do things which he was doing and getting overwhelmed because he was screening, he was diagnosing, he was treating, and he was overwhelmed? So can we not use the doctors more effectively? Because this 20,000 cannot grow to 200,000, right?Maybe marginally will go up by 10%, 15%. So this is the limitation. And with this limitation, how with technology we can change? So that is the, I would say, the solution statement which we were thinking, for which medical device became a bottleneck, where when we were working, okay, if I have to think that, why should we not screen at a diabetic clinic? Why should we not screen at a primary, at a general physician's place? Because people are going to a general physician with a health seeking behavior. They're not going for eye screening, but they're going with a health seeking behavior. The GP is somebody the doctor, the patient trusts. Now, if the GP can look at the patient history and say, okay, he's diabetic or he's hypertensive, it is important for him to get his eyes checked. And instead of sending him to an eye doctor, which is what he was earlier doing, if it can be checked there, imaging is done there, the checking is done by the ophthalmologist, and then GP advises him, like, you don't seem to have a problem, or you seem to have a problem, go and see the eye doctor. So the number of people, if you screen are 10, the number of people whom you will send to an eye doctor is only 3, but you are screening all the 10. And the eye doctor, to see these 10 images, probably takes a fraction of a second compared to these 10 patients walking into these high hospitals with a problem. So, understanding the limitation of what we have versus how do we solve the problem versus what was missing becomes our problem statement. And then we go towards the problem statement. Once we have defined that, okay, I now need a magic box, which I will eventually put it in many places, and it should take undilated images. It should take decent quality images, which an ophthalmologist can grade. It should be cost effective. It should be affordable. It should be, you should be able to take it from one place to another, because you may want to run a camp, you may want to do weekends on something else. But whereas current optical equipments were very sensitive, they were only in the retina clinic, and once they were fixed, they were not moved from one place to another. So we need to kind of look at all of that, and then you go about looking at how do I make, if this is the magic box, how do I go about making it? So what are the technology which is required? And when you get into that, so after you analyze this, you funnel it down. Okay, I have to make this. And then you do a technology discussion. Okay, should I use CMOS camera? Should I use CCD camera? Should I use halogen lighting? Should I use LED lighting? Should I use this optics, that optics? What should be the field of view? those are very, very important discussions which you need to have, which is very product specific, right? I think before we come there, coming to making a device, I would say, is the most critical part. If your problem definition is very clear, your specification for the product becomes very clear, right? And then I'm not saying that technically it will be easy. You know, we couldn't find a solution for more than a year, right? We failed many times. But since the problem statement was very clear, we didn't go with something which, you know, was a temporary kind of a solution. We had to create something which will work on those you know, environments, right? It has to be portable, it has to be rugged. So we had to make extremely good optomechanics, which will, once the lenses are fit, it cannot move. It will work in dusty conditions. How do you manage dust? So, you know, sealing it became important. There was a lot of light scattering. So how do I prevent light scattering? So anodizing, good optomechanics and anodizing became important. How do I cut costs? CCDs were expensive. Let me do CMOS. But when I do CMOS, the image quality was coming down. So how can I improve image quality with image processing? Those are fundamentally the technology challenges, which obviously the technical people will be able to solve, or they can bring in experts who can help them solve the problem, right? Now, when you do all this, in our case, we were very lucky that when we went and did a diligence on whether we are infringing any patent and things like that, we found, to our surprise, we never designed it that way. But because we approached the problem differently, probably that was the reason why when we designed the product, we were not infringing any existing product, right? And we were also able to find out new ways which we were doing, which we were able to find. So that safeguards your business, right? But I think that is, it is not that, okay, I have found something very unique, so I'll go and patent it and then I'll go and make a product. Sometimes it may work, but it may not work in all instances, because what happens is, you know, it may be a new idea for a patent, but it may not be useful for creating or solving a problem. So I think getting that correct first and then getting into the next technical challenge is the second part. Now, the third important thing, and I think we cannot ignore it even at the stage of, you know, in the problem understanding, is that once you make a product, we have to actually see, we cannot live in government grant or XYZ. We have to sell the product and survive, right? So, and obviously, you being a startup, nobody knows you. Why will they trust you? Why will they buy from you? And what will you price? And at what price it will be, you know, you will be able to kind of sell it and make money, right? Now, at that price, will it sell? Why will somebody buy an ophthalmology equipment for 5 lakhs? So our first product was 5 lakhs. So which is greater than a Maruti car's price at that time, right? So to buy a Maruti car, people take a lot of thinking, and you know, it's a life ambition for a lot of people, right? And for an eye doctor, obviously, it's a big thing, even though it's a tool. Why should he buy a product, that too from an unknown startup, right? And what is the guarantee it will work? So you need to kind of figure out that portion also. I'm not saying that you can find out solutions because you are new, you don't even have the contacts, but I think it is very important that when you have a problem statement, first to determine whether that is a good enough statement, and then what is a solution, how is that solution different from the current one, at what price points you can make it, and what price point you think the market will accept it, will you make enough money, and more importantly, will at that price point, whoever are the buyers, will they buy it? I think that validation is very, very critical, because a lot of brilliant ideas, because they don't go to the market, die there, because people realize this is a very big problem. And a lot of times what happens is, you see a problem in your family or your friend circle, and you feel, oh, there was no solution. So you go about emotionally getting attached to that problem, and start finding solutions to that. And maybe you crack the solution, right? And you spend 1-2 years on that. And then finally, when you think that you'll build a company and take it to market and all that, you realize either the market is too small, or the prices which you have created, the market is not willing to accept, or it is not a sustainable model where you hire these many number of people to do it. the market doesn't, does not exist. So I think those validations also has to be done, right? Now, of course, when I say all of this, it looks very complex because, oh, I have to find the problem. I have to find a technology solution to it. I have to also find out whether the market will accept it, at what price I will make, what technology. So it looks very complex. But I can guarantee you that the moment you have a deeper understanding of the problem, a lot of questions get answered, right? And you are interacting with, the experts. You're talking to doctors, and the doctors know better, right? They know why, X is there, and a lot of ideas come from doctors. They tell you that this will work, this will not work, right? And it is very critical that you take those discussions. Doctors have limited time, but when you spend those 1 hour, half an hour, 3 hours with them, you get these get these insights, and you have to really use those insights and also validate them. So you get different input from different doctors. You need to kind of collect all of them, assimilate, and then take your own judgment, right? So we were very fortunate that we had the opportunity to interact with probably the world's largest and India's one of the leading eye institutions, Aravind Eye Hospital. So we were able to bounce a lot of our ideas, our thinking process, from a technical standpoint, from a business standpoint, from a commercially viable standpoint, from a usability standpoint, and get some inputs that, so finding a very good institution or doctor who will support your initiative and also give you time, not only from understanding the problem, but also when you say that if I make a solution like this, will it work? And he is also willing to test out a few things. So I think those in India, we are actually very blessed because doctors are extremely cooperative. They're very, they're willing to, work with the industry, work with young entrepreneurs, and they are wanting to contribute. So I think, and we as Indians should use that very effectively, right? Because we have not, and also the kind of cases we get, right? The kind of eye problems in our industry, if we see that the variety of problems, what we'll get in a very short span of time is phenomenal. So when you are building a product, just to give you an example, right? If you're making a product in the Western world, you are always used to seeing Caucasian eyes. Now, Caucasian eyes tend to reflect more. So the light, what you put on that will be comparatively lower. But when you come to Indian or African eyes, they are much more darker and they reflect less. So you'll have to throw more light. So a device which is actually made for the Western market doesn't immediately work in Indian patients, right? The images are dark. So you learn all of those things, and then because you get a lot of these corner cases which are extreme, you are building a product which is suddenly trying to solve almost 90% of the problem. And that is why we can go global, right? If we build a product from India and get it tested. So in India, obviously, you get really squeezed on the price side because you have to make a real affordable product, right? For you to survive, you have to then, your cost has to be comparatively low. So if you can build a product like that, then you can actually take it to the global markets. Of course, one of the very important things which we need to kind of do is, we as Indians are very good in prototyping, right? We are very good in finding a technology solution. But what we lack is how to productize that. See, a product is very different from a prototype, right? A prototype is something which is like a proof of concept. You are able to do something, you are able to do 5 of that and it works. But when you have to make hundreds of those, thousands of that, there has to be, your design has to be repeatable. And mind you, when you are producing, it will be produced by workers. And when you made your prototype, it could have been done by engineers. So engineers will adjust, do things because they designed it. But when you're giving it to workers, they want clear instructions and they will assemble as per instructions. So the product design has to be so good that it is repeatable. So you make 100, 500, 1,000, 5,000, you have to buy, the design has to be so good that it is repeatable. That is one. The second important thing is you need to do extremely good packaging, right? What we lack is we do all of those things, but we don't do a good user manual. We think, oh, I have to spend another 100 rupees on that or 500 rupees. We don't do a good, instructions. We don't put very good labeling, right? And we don't do good packaging, which, you ship it, he receives it and it comes in broken condition. So we try to cut cost on few things, which are actually the first thing somebody sees, right? When you want to go to international markets, right? So the packaging, the label, the way it is printed, how rugged the packaging box is. Of course, the package is going to be thrown all over the place. And when he opens up, what kind of environment friendly material you have used. When he opens up, how easy it is, the instructions. Have you put it in languages which he or she should only will understand? Has the instruction being clear? Are you putting the right power plug for the country you have shipped to? Will it work in those voltage conditions? So those are kind of things. And how will you do after sales service? So these are all important points, but we as Indians generally tend to ignore that, because we think that, once we made a product, value for money, that is good enough. I think when you transform from a prototyping proof of concept company to a product company and want to take it global, I think these are very, very important points. I'm not saying that you can do it in day one, because definitely there is a lot of resource limitations, right? So you need to kind of have it in your mind, but you will decide, okay, when I make the 100th unit, when I have this cash, then I will invest in that. So the reason why I'm saying this is generally people ignore that, right? But you have to put it in your roadmap, because then even for an Indian doctor, even though you may be going and doing an hand holding, it is important that you have all these hygiene factors, because we can produce world-class products from India, right? So I think that if we have it in our mind, we can obviously phase it out based on our financial constraint, because as a startup, you're actually fighting too many problems, right? You don't have money, right? And a medical devices company doesn't get funded that easily. And then the concept, what you're working on should be scale, you should be able to find a solution, and that solution should work, and that doctor should buy it, and you should collect the money, and then take it to many more people, right? It should be, so we are having more challenges, so we need to but we should keep this in mind. Then the other important part is the regulatory part, right? And India is now already coming up with a regulatory framework. Earlier it was not very mandatory, but I think this you'll have to integrate into your product creation roadmap. I would say that we used to follow CE as the benchmark, because even though CE, we were not exporting to Europe or anything in the first 3, 4, 5 years, we kept CE as the benchmark and tried to create a product meeting CE specifications, right? So when it is meeting the CE, when it has to meet the CE specifications, you will have to make changes, let's say, to your power electronics, so that you don't fail in EMI, EMC, you don't fail in XYZ, right? Now, once you have actually made a product and then realize now we'll have to get, pass the CE test or whatever it is, then you may actually have even a design change. Now, a design change at that stage may be much, much more expensive. You may have even created a product mold, and now with the new change, it may not be fitting into the product mold. So you need to kind of have those things also in mind. And it is better that you actually, if you decide that my product is only an Indian product, then look at only the Indian standards. But if you think that I'm going to make this product for the world, I'm going to sell it in the US, I'm going to sell it in Europe. So you need to know what is the US FDA standard for your device. What are the tests you have to do? What is for CE? If it is for Health Canada, what is for Health Canada? And you may do it after 5 years. But when you're doing in the product design, ensure that it will pass those tests, because after you have made 200 units, it is very difficult to change the design to meet a particular specification. And then the amount you will spend will be far, far higher, right? So those are smaller things which somebody has to keep in mind. The last thing, which is about market, right? Now, how do you go and sell it, right? So the first few units, your key opinion leaders, or people with whom you work with, become your obvious choice, right? So you sell to them either, at discounted price or free of cost or whatever it is. That is a strategy. But then after that, you need to kind of scale it to the next set of doctors or next set of buyers. How do you do that, right? Now, there are two ways. One, you use the standard dealer distributor business, right? Where you go to somebody, let's say if you're in cardiology device, so you can go to a distributor who's already who's selling cardiology products, go and give it to him and probably use him because he's already got the contact, so he will go and sell it. But the problem in that is if you have made a very offbeat product, which requires a lot of concept selling, the dealer may be very good, maybe having extremely good contacts, but he's only used to selling boxes. There's a standard product, there are 3 makers, I sell this is the specification. And so people ask, so it's like, okay, I'm buying an X-ray machine, digital X-ray, no digital X-ray, this is the spec, this is the spec, this is mine, okay, this price, so they are very good in that, right? Now if you're going and making a concept selling, which is slightly different, where you'll have to go and spend time with the doctor why he should buy your device, because doctor is not used to it, then a dealer distributor may not work out, right? So you may have to use probably your own sales force again, which is a cost, right? Now, the advantages of that is when you're actually creating a product in the early stage, you need to also get feedback from doctors or users. And that feedback will be much more correct if you use your own people, right? Including you go and get the feedback, or your own colleagues go and get the feedback. You get the right feedback. So you also you just don't blindly listen to what doctor says. If doctor says something or the user says something, you question him why it is needed, and then understand the genuinity of this, and then try and incorporate those changes. But if you're going through a dealer distributor channel, some of these things will get lost, right? It doesn't come back to you, so you may lose market share on a later date. But once you have established the product, then it is very important that you use a dealer distributor channel, because they can actually take you faster, right? Organically, you growing with sales team and other things inside becomes fairly expensive. And then how do you take it global? Because global, right? India, fortunately or unfortunately, has one thing, which is we don't either have a good name or a bad name, right? In medical devices, India, people have not heard. In software, at least we have very good name. In medical devices, we don't have a good name, neither we have a bad name. So you need to, so people don't, just because you made a product and say, okay, I got US FDA, people don't stand in queue and buy your products, right? So they want to know how reliable it is. Are you, first of all, a trustworthy company to work with? Are you a fly-by-night company? If I buy a product, will I get service? What is the shelf life of the product? So you need to establish that credibility. And how do you establish that credibility? By actually attending some of these events where you talk to these doctors. They continuously see you. They don't buy, but they know that you're existing. And they know your, let's say, India story or Asia story, right? And then slowly convert them into buying, and the first buyer, the second buyer, and the 10th buyer, and then it's easy. So similarly, you also work with those distributors. You continuously meet them. They see that you are not a single product company. You're creating multiple products, and they feel that working with you, they will be able to fit in a gap which they already had, or they will make more margins, or you have a far superior product which is selling well. Those kind of contribute to these distributors signing up. So it is a long journey, and it's a tough journey, but the satisfaction what you get in this is very high. It's also not very glamorous, because it's not e-commerce, or you're not doing a SaaS business where you get valuations of 500 million, 800 million. Investors are waiting to put money. It's a very tough business, and also the growth is quite slow, right? The entry barriers are high. For you to enter it takes time. For you to establish takes much more time. To have a credible product takes much more time. So it's a long grind, and you need to be patient and have the same passion or even more passion than what you had when you started. And if you get that right, and if you give a product which is solving the problem, I think you can be successful. So I'll stop here. And
Thank you so much. It was probably at the energy level of infinity. I don't know. I mean, the passion, what you've done, I think so well it came out. Thank you so much. So, any questions from the participants?
So, Dr. Chandrasekhar, I have a small question. You came out with an idea before starting up a company. So, in the first stage, like who were your investors? Like, was it like from your pocket itself, or they were like government agencies, or Derby Foundation, or some other? So, how exactly it started?
Yeah. In 2010, unfortunately, there were not too many agencies. In fact, there were not too many VCs also. See, today, there are a lot of seed funds. There are a lot of BIRAC, people like Derby Foundation. A lot of people hand-holding is there, right? And also mentoring. Like, for example, if you were starting a software company, it was, you could immediately think how Mr. Narayan Murthy made it, or how Wipro happened, or how TCS happened. So there was something to look forward to and try to kind of create your niche and work towards it. In our space, it was comparatively very limited. So we initially bootstrapped ourselves. We worked as consultants for some companies and got some money and put this money back in. And then slowly got some angel funding, right? The angel funding also, I would say, was luck, because we knew that individual very well and he was willing to trust us. I don't think if I repeat it today, anybody will trust me. So again, it may look very cliche, but I'll repeat it. I always believe that if your intentions are very good, you get divine intervention. So we got divine intervention many times. Otherwise, we would have not even survived, right? And so I think today opportunities are very, very good. There is so many funds which are seed funds, mentorship. You can go under incubation. At least get a lot of these basic hygiene factors ready, right? The place and labs, and at least some seed money. Those things are available. Those days, unfortunately, it was not there, but we were lucky to survive.
I have one question. Now you have experience. Now you have established one setup. So now is there any possibility that you can help someone else if they come up with an idea?
So I think see, two things which we want to do now. I think, see, the biggest problem area is when you get into manufacturing, right? Idea and other things are one, because idea is very, very what do you call, very sector specific, very problem. You need to have a little bit of in-depth understanding whether that idea will work or not, right? Of course, we can evaluate, but we are also learning, right? I think what we are willing to do, and this is what I also said to many people, is that, see, there is certain hygiene factor in manufacturing which is required, right? Which is following 13485 process, FDA process if it is required, CE process if you are going to export, and it is a overhead. And when we started, there were contract manufacturers, but they were actually making established designs. They were contract manufacturing, right? There is a difference between making a product which is semi-finished to a product which is fully finished, which has got defined bill of material, defined. So one thing which we can contribute is, if somebody has got a prototype, we can help them to do design for manufacturing, and do value engineering, and do production, both batch as well as high volume production, which definitely I think will take a lot of headache out of them, because till you reach economies of scale, that's a huge problem, right? Because if you want to price a product at 5 lakhs, and if your cost of making it is 4.5 lakhs, you will not survive, right? And the product, because you're making it 4.5 and you try to sell it at 15 lakhs, nobody will buy. So it's like chicken and egg problem. And then people will ask you a lot of questions. Are you meeting this specification? Are you meeting? So I think that is one area which we think we will definitely contribute. The other area, obviously, see, we are not experts across domains, right? We can only say, we can only ask whether you have asked these questions and whether these questions have got answered and your solution answers those questions. Those basic minimum stuff we can help. But I don't think if somebody is making a product on dentistry, right? But if apart from taking that, it is an imaging device, doing basic minimum ideas, I don't think we will understand dentistry the way he would have understood, or I'm assuming that. So there maybe our contribution will be limited, but we can do a reasonable contribution on the manufacturing, value engineering.
See, actually speaking, like any academics, any professionals, they come from the academic setup. But in the academic setup, we do not have a trainer who will teach us through this entire process in the setup. So how we can do that? Like, for example, medical device is the basic requirement is having the knowledge of anatomy, physiology, and biochemistry of that. These three things one has to know that. But only that much in the academic setup will be taught, but not in the next level. Like, how these devices are made. For example, the ventilator, and how that fits into the anatomy and physiology of that. But this is possible only by people who have achieved in their profession, like you. So how you can get involved?
Yeah, I think, see, what we can basically do is, so let's say that somebody comes up with an idea, for creating something using something, right? So we can, we may be not doing 100% of the work, but we may actually ask them 50 questions, which they have to go and find answers. Some of them we find answers ourselves. And then we can suggest to them, for example, if they're using, I'm just giving some vague example. If they're using some kind of lighting, we can say, no, this lighting will not work, use thermal imaging. This is not, it is end of life, or it will not work at that price point. There is also this. So those kind of ideas we can give, but we will also can ask them many questions for which they can go and find out answers, right? Because they would be rubbing shoulders with the clinical experts and get the answer. So we can ask them those questions, which they can get answers to. And then together we can build, let's say, a plan or a scale up of a device, which ultimately can reach the market.
Okay,
so
that's
that we can do definitely.
No, probably I would also like to add here to what Professor Lakshmi raised here. No, see, this is where the role of incubators, where we are able to connect to experts and do a lot of things can be done. We would also be happy to see how we could probably, starting from getting ideas from your researchers who want to build companies out of them, then connect them to various parts of the ecosystem can be done.
Okay, that's great. Yeah.
Yeah.
All right.
There is a question on the chat box. Shall I read?
Yeah.
Yes. Yeah, please.
Yeah. So someone is asking, medical device developers need basic understanding of physiology, anatomy, etc. Can you elucidate the importance of biomedical scientists in this area?
So I think, see, biomedical scientists are actually the most well equipped to handle this, because they learn a lot of biology. In fact, I went to engineering because I didn't like biology. People, biomedical engineers do definitely understand, and they are also taught a lot of safety factors which a body can take or cannot take. So I think biomedical engineers are actually very well suited. They can play many roles. They can play in, I would say that biomedical engineers should become extremely good product managers. The reason why I'm saying this is, actually in a medical devices company, the role of product manager is the most critical thing. The reason why is because it's actually even, I would say, the most critical, because identifying the need, identifying the solution, whether you have the technical competency to do, how will you, what is the desired output, and all those things is actually worked out by the product manager. So biomedical engineers are best suited for product managers because they have the knowledge of the physiology, as well as they have the knowledge of instrumentation and electronics and all that, right? So I think they probably are best suited to make or build medical devices. Maybe they can play larger roles even in R&D, but R&D, if it's a very let's say image processing specific problem, an expert, a PhD in image processing will be far more better. But I think in a basic scenario where you're trying to look at products and you're having multiple things, a biomedical engineer is best suited for a product management role, and which is actually, I would say, the most critical role for any product company or medical devices company.
Dr. Chandrasekhar, I request please put your contact details in the chat box.
Sure, I'll do that.
Okay, it was a very, very sorry. It was a very, very informative and excellent, exciting section, and I think this is first of its kind in terms of the neuroscience symposium, where we talk about commercializing the ideas from the academic research all the way to the industry. With that, I will call the session to a close.
Thank you. Thank you so much, Casey and Nair. Thank you so much.
Thank you.
Thank you, Professor Lakshmi. Thank you.
So heartful thanks to the chairperson and also to Dr. Lakshmi Jagannathan, Mr. Biju Nair, Dr. Chandrasekhar Kuppaswamy, and in fact, special thanks to the Derby Foundation for enlightening us with the workshop content. Thank you, ma'am.
Thank you so much. Pleasure is ours.
I next request our IIM General Secretary at NBRC, Manisha, Professor Pankaj Seth, for his remark on this 2-day symposium. Sir.
Yeah, it's indeed an honor to be asked to provide a remark. Indian Academy of Neurosciences, as you would know, is the third largest organization of neuroscientists in the Asia region. And we have grown over the period of years. What we have been able to do so far is, to bring together all the neuroscientists. And in addition to what we do as an annual meeting for IAN, IAN is now playing more roles with active chapter activities as this one. Can you hear me?
Yeah.
Okay. So like this one organized by the NIMHANS chapter, or the Bangalore chapter, I should say, with the active scientists like Dr. Lakshmi Rao and Bhupesh, of course, and others, all of you. We thank you all for your help in enhancing the activities of the IAN. Now, IAN, what we would like to see is also have more role to play in development of new neuroscientists. Building the critical mass, as we call it at the National Brain Research Center, also is one of the mandate of having more and more neuroscientists, enabling them to do very good, particularly the brain research in the country. In that direction, what IAN, I would like to see in IAN is to develop some kind of strength building and mentoring capacities which IAN could render, because we have a lot of established neuroscientists in the country and also some members which are outside the country. I would also like to tell that in addition to running their lab, there are various other options now what the scientists can take over, after doing your PhD. So as IAN, as an organization, we are working with our executive committee members and trying to understand as to how IAN can cater to the needs of neuroscientists. Number one, of course, to enable them to do better neuroscience, guide them into new institutions, new possibilities of neuroscience research. Institute like National Brain Research Center NIMHANS could come together to develop more platforms where it could enable the young neuroscientists to get directions, to look for opportunities and so on. We would also like, if needed, to play a role as mentor, and we can join hands with our other IN members. And we have a good presence now. Indian Academy of Neuroscience has a good presence in Japanese Neuroscience Society. We are showcasing Indian neuroscience at those platforms if we want to go global. We are joining hands also with ISN, which is International Society of Neurochemistry, and other organizations which are doing neuroscience around the world. With that, if I have missed anything else which IN can play a role in promoting neuroscience and helping younger neuroscientists, I would ask my senior Dr. Vinay Khanna to add on to that.
So thank you, Dr. Seth, for your humble words. Now I would invite our IN Secretary Headquarters, Dr. Vinay K. Khanna. But before that, I would a special thanks to Dr. Khanna for staying with us throughout the 2-day symposium. Thank you, sir. Sir, you are mute, sir.
Thank you, Dr. Bhupesh. I'm a bit happy and also nervous that I'm being monitored by Bhupesh throughout these 2 days, that he was taking my attendance also. Members of the organizing committee at the National Institute of Mental Health and Neurosciences, the dynamic organizer of this symposium, Dr. Lakshmi Rao, distinguished neuroscientists connected from different places in India and globe, ladies and gentlemen, a very good evening to all of you. It has been an enlightening experience on being connected with the symposium on Sketch and Etch creative ideas in neuroscience for these 2 days. I reiterate the remarks of my colleague, Dr. Pankaj Seth, the General Secretary of Indian Academy of Neurosciences, who has really covered all the aspects of the IN where as far as the role of IN is concerned and where IN can further pitch in. As a matter of fact, the neuroscience in India as a professional discipline has grown and today is at threshold to take off, to touch new heights. With the experience gained over last few years, today we are in the position to focus the outcome of the research not only in academics, but also to convert this experience into a commercial viable enterprise. That's what I'm very much fascinated to hear the different facets and aspects which have been covered in different sessions and also during the course of the workshop as a part of this program. While there are ample opportunities to build the career in this fascinating discipline, convergence of ideas with focused goal is much required to achieve excellence. Truthfully, there is no dearth of talent. And Dr. APJ Abdul Kalam, a scientist, thinker, and the former president of this great country, rightly mentioned that all of us do not have equal talent, but certainly all of us have an equal opportunity to develop our talents. The idea should have niche with translational approach to serve the society at all levels. Mr. Shiv Khera, in one of his address, rightly mentioned that winners do not do different things, but they do things differently. The society has given us a lot, and thus we should also involve ourselves to serve the society with more commitment and dedication, involving the young generation of neuroscientists who have more dreams and ambitions. The interest that is generated and floating of new ideas during these 2 days will help us to move forward. It will be worthwhile to consolidate recommendations and suggestions by the participants and the distinguished speakers on the IN portal for follow-up and further processing. The members of the IN will definitely help as far as the further to consolidate the ideas, to brainstorm using their frontal cortex more, because this is one of the area which is known for its creative thinking on this important issue, to converge with viable roadmap that will encourage the young researchers with vigor and energy to proceed further. These recommendations will definitely help the science agencies to create new vistas and opportunities at different levels. I appreciate the endeavors of the organizers, and especially Dr. Lakshmi Rao and Dr. Bhupesh, for developing an interesting and well-structured program. Further, I wish all the best to my younger colleagues in their future endeavors. I'm sure many of these colleagues will be taking up key positions in the time to come. Thank you all for patient hearing. Jai Hind.
Small correction. So this is actually a combination, like we have all 4 institutes have joined together under the leadership of our president, Bangalore chapter, Dr. Vindhyam Kuti. So it is not just 1 or 2 people have worked on it, and all of us gave their idea. Everyone has given ideas. For example, JNCSR or Indian Institute of Science and INSTEM from NCBS, we have Dr. Ravi Mutashiti. Everyone has gave different ideas. So we have only put everything together and made this happen.
I'm very happy that Dr. Lakshmi has been able to correct me at this point. I once again appreciate the endeavors, all the different sets of, all the different cases where the neurons are there in Bangalore and other places who have really joined in this endeavor. Yeah. And also I wanted to check how attentive Dr. Lakshmi is, who has corrected me at this point of time. So this was basically a gap from my side just to ensure, to assess how attentive she is. With these words, I once again thank all the members as well as the organizing committee is concerned, and all those people who have been involved and who have enjoyed in this endeavor. And really, I really enjoyed, because I remained connected, for which Bhupesh has probably, he can always tell that I remained for throughout these 2 days. I thoroughly enjoyed the program, and especially the workshop, where the organizers have invited very good people who shared their thoughts. I was rather thinking how I can further take the advantage of these suggestions further. Thank you. Thanks a lot.
So thank you, Dr. Vinay Khanna and Dr.
My pleasure.
For giving an overview about the vision, motive and commitment of IN. So I now request our professor from Neurochemistry Department, Dr. Sarada Subramaniam, to give the concluding remarks.
Dear dignitaries on-site and those who are joining online, we appreciate your involvement and engagement to this symposium. It's very heartening to note that you all had fruitful discussions and open chats. But I personally believe that 2 days is not just adequate for this symposium. The main theme of the symposium was Sketch and Etch creative ideas in neuroscience. This was covered in 4 succinct sessions, beginning with science as culture, experiences in early life post-PhD. So a doctor of philosophy and science, after receiving the degree, the parts being laid into cutting-edge research, drug discoveries, roads leading to state private universities, sometimes even crossing the borders and landing in industry, or boldly and confidently setting up a startup to scaling it up further. Then we had the second session with spotlight on PhD students. We appreciated the lucid presentations made by these PhD scholars. We have also taken note of the few key concerns which were raised by these speakers. I would like to list a few, the most important ones among that. An appeal to Government of India or the private funding agencies for financial support, not limiting to postdoctoral research, but considering for minor research projects, particularly at the undergraduate level and at the postgraduate level, so that the interest in neuroscience research that can be kindled in the formative years. Then the need for a single window system, fast-track process of evaluation is also suggested. The intellectual curiosity, looking for scientific basis, and the burning desire to make a difference to the society, and the deep urge to improve the quality of life is very commendable, as we heard from these PhD scholars. And certainly not to miss out on the need for introducing mental health and wellness in the high school curriculum. I think we sincerely hope that our decision makers and policy makers take this point into consideration and we revamp the curriculum early on. Then the day 2 began session 3 today morning. It was very enriching and we have learned from the thought leaders and successful entrepreneurs. It was very reassuring to hear that world-class research is possible from India. The power of research and entrepreneurship in making 21st century as India's century could very well form the vision and mission for the current times. So in this session, how the soft skills that we possess or what we would have acquired through PhD course can be put to our advantage for career development. They were very well highlighted by these eminent speakers. Then the need for agility or the resilience and the willingness to learn, the right attitude coupled with aptitude, and the importance of networking. This was very well discussed. Of course, the suggestions for increasing the visibility, having a crisp and impactful CV were also made. So as we sit our professional platform, the next step would be to emphasize on identifying the emerging areas, address them in the mission mode program, so that ultimately the community can benefit and this can make the career very meaningful. So while doing so, in line with this, some of the established larger institutes, I mean larger only in the manpower, I don't undermine the quality of the research that comes out from the smaller institutes. Here the point is, so that these large institutions, so the fact that they have a better infrastructure, they can make it as an inclusive way to include smaller institutes in the nearby locale and work towards establishing research parks and working towards incubation centers. So some of these key messages is what we have received from the thoughtful leaders and eminent speakers we had in session 3. As we turned to the most sought after workshop in the afternoon, we were taken through the commercial world requirements, and I'm sure most of us were the first time listeners to this workshop. And some of the salient points that we noted were that the blocks of business model, they were very well explained in simple terms. The nuance of intellectual property protection, the definite do's and the certain don'ts in filing patents, including the defensive patent strategies were explained. Identifying, understanding, analyzing the problems turned out to be the key step. Then create a prototype, validate it, and package it into the right market. And this must be very convincing to the customers. So as I observed through these excellent presentations and the very careful preparations that went into it, and the positive participations by all the attendees, I can conclude that the purpose of this symposium has been accomplished. So I hope that you have learned through this symposium will help you etch out a beautiful, successful, and joyous careers in the future. Thank you.
Thank you, Madam, for the concluding remarks. I would finally thank all the participants, speakers, chairpersons for making this symposium a grand success. A special thanks to the Derby Foundation, Bangalore. I would also thank the Indian Academy of Neuroscience for supporting the Bangalore chapter in continuity and for sharing the details of the symposium worldwide to the neuroscience community. I also present my heartfelt thanks to the NIMHANS administration, our beloved Director Professor Gurraj and our Registrar Professor Sankarnarayan Rao for their kind support. I thank the head of the departments and faculties, in particular Department of Neurophysiology, Department of Biophysics, CPNT, and Biochemistry for their continuous support. I also thank the employees of the Information Technology Department for their IT support. Thank to the IIM Bangalore chapter organizing team, student volunteers. Also, special thanks to Zahera and Niveda for preparing the abstract for the symposium. A special thanks to the Biomedical Engineering Department, Babish and Chandru for their support, continuous support. And finally, we also thank all other persons involved directly or indirectly in the successful completion of this symposia, if in case I missed any. Thank you very much, sir. Thank you, ma'am.
Thank you. Thank you.
Thank you so much, sir.
Thank you, sir.
So we will prepare the final report of that, and Dr. Khanna, please, you have to help us in.
I'll definitely do that, not a problem. Congratulations to all of you. I really enjoyed. I thoroughly enjoyed.
Thank you.
Thank you.